So hi everyone. Now I'll be going to cover one major thing, which is floating routes. Okay, the topic is floating route. So in the floating route topic, okay, I'll be taking some Cisco latest series IOL. Okay, so I'll be taking 3 routers. Okay, so guys, can you see this design? Like there is a router with the 2 ISP.
Yes, sir.
Okay, let me take a Windows machine. Okay, so this is the design, and let me connect with the internet. So now you can see there are 2 ISP, ISP, ISP2. So this is the second ISP. So let me change to Vodafone, because whenever you change the names of devices, it feels like we are doing some real stuff. So right now, guys, can you see this design? Yeah.
Yeah.
Okay, so let's call 192.160. Okay, so this side I'll be going to configure 1.1. Maybe just because I'm here doing testing only. So do not just think why we are giving private IP to Airtel. This is just for a test. Okay. So from this side we have
2.1.
2.1 and this is 2.2. Okay, from this side, Vodafone, Airtel, like they all are basically connected to this internet. Okay, they all ISPs are connected with internet, and this is your user, which is a LAN user, where I'm going to configure 192.168. This is a very simple design. This is a CCNA lab. Consider this is a CCNA lab, not NP. But I'll just show some good things about this lab. Okay, so the lab is up. The devices are almost up. Yeah. So when you want to see like R1, so this is R1 device. Airtel. Okay, so this is Vodafone. Okay, and this is my Windows machine. Okay, so the window machine password is test123. Okay. So all the consoles are here. So please let me know if screen is visible and the design is also visible to you. Yeah, now it's visible, everyone.
Yes, sir.
Yes, sir. Yes, sir. Yes,
Okay,
sir.
so what we will do, first thing, we will be going to configure the LAN side, where we have given 3.1. Yeah. Yes or no? This is R1 router config T hostname R1. Yes.
Yes.
Yes, sir.
Okay. So after that E02 IP address 192.168.3.2, 3.1 is okay. Okay. So I have configured the interface, and remember this is my LAN side. So I can say here LAN interface. Okay. So what command I have added here?
Description.
Description. So interface E00 description. This link is for Airtel. Yes.
Yes.
So suppose this is 100 Mbps link. So I will be going to write here 100 Mbps. After that, I'll be going to get IP from my ISP. So that IP I will configure. Yes.
Yes.
After E01, I will be going to configure like 2.1. And description, you can add here Vodafone. Okay, so this is my backup connection, like 50 Mbps. Clear, everyone?
Yes.
Okay, in the real world, why description commands are important? Because when you are going to see, okay, suppose you're maybe Airtel called you and say there is a Airtel, there are some CRC error, there is a fiber link damage. Please shift your traffic to Vodafone. What you will do? Suppose Airtel fiber maintenance is going on. Airtel क्या बोल रहा है? Fiber का maintenance है. Okay, so you will get a lot of errors because whenever a fiber cable maintenance goes, your link will be up, down, and you will get a lot of tickets automatically in the production network, right?
Yes.
Yes or no?
Yes,
So
sir.
what you have to do, you need to shut down the interface. तो जब भी कोई एयरटेल वोडाफोन जैसी कंपनीज फाइबर मेंटेनेंस करती हैं तो वो इंटरफेस आपको बंद करना पड़ता है. ठीक है, समझ आ गया?
Yes, sir.
You need to shut down the interface. How you will check that I want to shut down?
Description.
There is some issues in Airtel. Now you want to shut down the port. Why description command is important? Because directly you will come to know which link is my Airtel link, which is Vodafone, and which is my LAN interface. Can you see the power of description command?
Troubleshoot में भी
Yes,
काम
sir.
होता है.
Yes, very, very popular command in the troubleshooting. Okay. Clear, everyone?
Yes.
So just you need to add what a description, whatever description you want to write. Clear? Okay, very good.
Okay.
So after that, I'll be going to put a default route here. How to add a default route? IP route. Yeah. This is how we add a static
0.0.
route. So 0.0.0.0.0.0.0. Okay, I want to forward traffic to Airtel 1.2 and AD value. What you want to set AD value? Name. You can enter a name also. Name Airtel. Okay, and AD value you have already given, but if you have not given, you can add a number here 1. So what command I have entered here? IP route 0.0.0.0.0.0.192.168.1.2 is my next hop. सामने वाले का IP को क्या बोलते हैं? The other side is called the next hop.
Next.
So 1.2 IP is your next hop IP.
Yes, sir.
So why first 0? This is first set of 0 says any network. The second set of 0 means any subnet mask. Okay, कोई भी network है, any network, any subnet mask forward all traffic to 1.2, which is Airtel, and where I am going to set up AD value 1. Clear है सभी को? All clear, everyone? Okay,
Yes.
great. Okay, now you need, so 100 Mbps is my, this Airtel is my 100 Mbps, right? Yes. So I have a backup connection at Vodafone. So I will do IP route 0.0.0.0. Turn off your mic, Gurpreet, Mohammed, Saurabh, Manoj, Rahul, Miron. Okay, everyone. Okay, 0.0.0. Now this is my backup connection, which is 192.162.2. Name is Vodafone. But this is my backup connection, and where I'm going to add a AD value 2. Can I put 20? Yes.
Yes.
So you can specify between 1 to 255. But lower is better or higher is better?
Lower.
Lower is preferable.
Lower is better.
Yes. So now tell me, my router is going to prefer which path, Airtel or Vodafone?
Airtel.
Okay, let me
Airtel.
configure these Airtel device because these are not configured. Okay. So host name Airtel. Okay, for your better practicals, we have added real internet in the labs. Okay. You do not have to imagine network here. You can connect real networks. Okay, so what you have to do whenever you open this lab, you can see a internet here. Okay, जब भी आप ये lab करोगे ना, whenever you do this lab on E01, you just need to enter here IP address DHCP. Okay, automatically Airtel device will pick internet from. So basically, this internet means this is my office or router. Okay, so just you need to enter this on Airtel. That's it. Okay, so there is a Vodafone here.
Sir,
IP.
map करना
Just hold on. Vodafone. So tell me, guys, the topic is complex or easy?
Easy, sir.
easy.
Yes,
Some things
Saurabh,
are
easy
new,
लग रहा है,
but
मुश्किल है.
most of the same.
Good.
Easy, sir.
So E01 IP address, because this is my WAN interface which is going to internet. What I will add here, because in
DHCP.
networking lab, IP address DHCP. Okay, clear everyone?
Yes.
Okay, great. So
To get the internet on land, the first we need to do the map, right?
I'm not getting your voice, Adil.
So to get the internet on land, the first we need to do the map, right?
Yeah, we have to do NAT, correct. So even on, because this is my office router, na? So we have to do NAT here also because we have imagine our networks, Airtel, Vodafone. Okay. So normally, like what I'll be going to do here. Yeah, I'm just thinking about this because if we create a loopback, that's fine. But here, like Airtel is configured. And now just let's test, do we have internet connectivity? Because I connected with the internet, which is my office router. And if you try to ping, what is Google DNS IP? 8.8.8.8?
Yes.
This is the Google DNS. If you ping this IP, it means internet is working fine, right?
Yeah.
So can I ping? Let's see. No, I'm not able to ping. Maybe I'm not getting IP. Okay. So let me check if I'm not getting IP or not. Okay, I'm getting IP here. Okay, so I got the internet route. So why I'm not able to ping? Let me check Google. So even see, if I type Google, still 8888 is going, right? Okay, why the internet is not working? Okay, just hold on, guys. I think I have not added internet permissions, maybe. Okay, so this lab I'm using 8087. Okay, I have to test it why it's not working. Okay, I'll fix it very soon. Okay, but right now what we can do here, okay, for testing purpose, I will create a loopback here on Airtel. Okay. Sorry. So I will create a loopback here 88888. Okay, and if I create a same loopback on Vodafone, so it means I created why I'm creating loopback. Tell me, my CCNA students. So why we are creating a loopback here? So that we can imagine there is a internet connectivity, right?
Yeah.
So if R1, you can see here, so there is R1, and on R1 we got default routes. So we have forwarded the traffic, and if you check routing table, So tell me which path is preferred. AD value 1. Can you see the AD value 2 path here?
No.
You cannot see, right? So it means if you have same path from two different AD value, so which path will be installed?
Yes.
Lower AD value, right?
No.
So if you ping here 8.8.8.8, yeah, I can ping because I created a loopback here on Airtel. So consider I created a loopback Airtel and Vodafone. यहाँ पर मैंने just imagine करवाया कि internet है इन दोनों के पास. So this is the reason on Airtel and Vodafone I have created a loopback. Okay, on Vodafone also. And when you ping from R1, so tell me which path is preferred now. If I trace route 8.8.8, so
Airtel.
which traffic is going from which next hop? Can you see?
Yes, 1.2.
So the command is trace route 8.8.8 numeric, which will not resolve into DNS. It is a faster way to do trace route on routers. So where the traffic is going on 1.2. Yeah. And there is some problem on Airtel now. You want to switch traffic to Vodafone. So tell me if Airtel link goes down, if E00 goes down, so router will forward traffic to Vodafone?
Yes.
Let's see. I shut down the interface, which is Airtel interface, and automatically my AD value static route, default route with AD value 2 came up in the routing table. Can you see that? But it was not before. So this topic is called floating default routes. What is the topic name?
Floating default.
Floating default routes.
Floating default.
Routes.
Okay, so it means I have forwarded all my traffic with AD value 1. And when this link goes down or Airtel ISP goes down, anything, automatically my traffic will shift to AD value 2. Very simple, right?
Yes.
Yes, sir.
The most simple lab, right?
Yeah.
So that's
Sir, you
called.
have created a loopback for internet connectivity.
Yeah. I just, because there was some issue. So what I did, I created a loopback here with 8.8.8.8. And here also I configured 8.8.8. Okay, so if you want to test it from Windows machine, what you normally do in this router? Okay, tell me 3.1 can Airtel. So the Airtel router knows about 3.1?
Yes.
Where it is. So if I check show IP route 192.168.3.1, do we have a network in the table?
No.
No. Because route.
Basically R1. So these are my public IPs. Okay.
Sir, I have a question.
Yes.
Suppose the connectivity from Airtel router goes down to the internet.
Okay.
The internet comes to it. Will it work? Will it shift to the Vodafone router?
So
or
you
not?
mean to say that this link goes down?
Right.
So then you have to do SLA tracking.
Okay.
Okay. So so you need to check if you guys are comfortable. It will be little advanced. If you want, I can cover right now, or maybe later on you want. So I don't know if that's also in the content, but I'm okay if you want. So let me check if we have SLA. So it is there, but in last of the topics.
HSRP we can use here.
No. HSRP we cannot use in the WAN connections.
Okay.
You can use in LAN, or ISP can use in their own network.
Oh,
But
yeah, that is I.
You cannot say Airtel, please change this IP and Vodafone this.
Yeah.
Yeah.
Thought, I was thinking if Airtel and Vodafone as a router.
So tell me what you have to configure so that my Windows machine will ping Airtel and Vodafone. NAT. So what is ACL? We will create ACL. Okay. We will create ACL number like 1. So basically here I'm permitting which network? My LAN network, because I want to give access to this network, right? Because I want this 3.0 to access internet. Yes or no?
Yes.
So I will create access list 1 permit 3.0 and what is the wildcard mask 0000255.
Yes.
So
Right.
subnet mask ka ulta, opposite of subnet mask is wildcard mask. So you have given access list 1 permit. Okay, this is the way you configure NAT. Okay, and after that you say IP NAT inside source list 1. Okay, so you are calling ACL 1. You are calling this 3.0 network and you are going to change this into which interface?
E/0. 0.
What else? Overload? Yeah? Just hold on. I want to see something here. Yeah. Okay. So basically when you have a router, okay, you cannot NAT with the 2 interfaces. Okay, let me show you what problem we will face. If you say IP NAT inside, if you are not good at NAT, okay, so please check NAT video, okay, and try to cover your basic NAT concept, okay. So IP NAT inside source list 1 interface, which is interface Airtel interface E00 overload. Overload is a keyword so that you can send a lot of computers traffic and all your private connections will get converted into one single IP, which is called PAT, right? Also, you have another interface, which is E0/1. Okay, but if you check your running configuration, okay, if you check your running configuration, so only one command is applied. You cannot see the other command. E00 gone, right?
Correct. Yes.
समझे? So if you give E00, then what will happen? Your E00 is there, but E01 is got lost. So what you will do when you have 2 ISPs?
Route maps. You can use a route map.
So you need to do a route map with the NAT. Okay. So when you have 2 ISP, what you will do? Route map. Route map is like your if else statement. Route map क्या होते हैं? If else statement होते हैं. सुने if else?
Yes, in Excel.
So what do you have to do?
If 0/0 is down, it should go as 0/1.
So basically we will remove this. So this is, I'm talking about the production network. Even in CCNP, CCI, this concept is not there. Trust me. Okay. So this is according to the industry design, and most of like you will see that some companies have one router. They have 2 ISP connections on one router. So what I'll do here, I will remove. So till now, any problem? अभी तक ऐसा कोई बच्चा है यहाँ पे जिसको कुछ नहीं समझ आ रहा? Anyone here who is not able to understand in anything? Yes. शर्माओ मत. I can give you
So can
solution
you
if you are not able
repeat
to understand.
the last thing that what you just said that if and else the thing?
Yeah,
Can you
I'll
repeat?
configure right now. Before that, till now, like AD value 0, 1, AD value 2, and the simple NAT I have tried to configure by making ACL. तो ये जो हमने ACL बनाया है, so everybody know how to make this ACL, yes?
Yes, yes.
Great.
That's understood.
After that, there is a problem in NAT because you got to know we cannot put NAT policy to 2 interfaces by default. Yes? तो अगर हम एक को लगा रहे हैं तो दूसरा अपने आप हट रहा है ना?
Yes, correct.
And if you not able to configure on both the interface, what will happen? You will only send. So if this
Correct.
ISP
Right.
goes down, let me tell you what is the problem we will face. Let me show you the problem first. So if you have a NAT here with this command like E00, okay, and if your E00 interface is up because I shut down that previously, and okay, how you get IP address? Let me give manually. How you give IP? ncpa.cpl is the short form. Okay. Okay, so what IP I have to give here? 192.168.3.2.
Yes.
So this is what we call the real experience. Okay, so let's see if we can ping 192.168 3.1. Can I ping my gateway?
Yes.
Yes, sir.
Okay, let's test if I can ping internet, ping 8.8.8.8. Can I ping? Let's see. 8888. I have created loopback, right?
Correct.
So let's see if my traffic is going to 8888. Okay, it's taking time because we need to see if NAT is working fine. Okay, so there was we have not given this command E02 IP NAT inside.
Outside.
Okay, and interface E00 IP NAT.
Outside.
So we need to give E01 also.
Yes, sir.
Interface E01 also IP NAT outside. On your WAN interfaces, you will give IP NAT outside. On your LAN interface, you will give inside. Clear, everyone?
Yes, sir.
Okay, let's test now if I can ping 8.8.8. Can I ping now 8888?
Yes, sir.
So now tell me if Airtel, so Airtel has a default route, which is, sorry, router has a default route of Airtel, which is AD value 1. So if Airtel got a fiber maintenance right now, so what you will do in that case, because
Shut
of
down.
you will not get too many errors, you will shut down that interface.
Yes, sir.
So your router traffic shift
Vodafone.
Vodafone.
Yes,
But
sir.
can I check internet is working or not? Let's see. This is the problem you will face.
Okay.
So then what you have to do you think every time you will go and change the NAT command here? Okay,
Not
suppose you do
possible, sir.
manually. Suppose you are
Yeah,
a...
laptop
It
का
should
charger का
be
दे देना.
automatically, sir.
Yes, yes, yes. Who is shouting? ऐसे बात करते हो?
On E01, it's all NAT is already configured,
Yeah,
right?
that was the problem because I can only apply to one interface. Either I
We
can
can't,
apply to E01
Oh, okay, okay.
now we
or
can't
either
able to access
E00.
the internet, right? After
Yeah.
shut down the interface.
Yes, because I can only apply. So either you have to do manually. Okay, या तो आपको manual करना होगा change. And obviously
Okay.
you will not do manually every time. So you can see E00 is applied. So now E00 link is down. So you need to move the traffic from E00 to E01. So this is the
Yeah.
command.
Yes, sir.
So dynamic mapping in use cannot change. Means your traffic, there is NAT translations and all, right?
Yes, sir.
So you can see there is a dynamic NAT and all stuff. So you need to give first clear IP NAT translations star. Okay, this is the command. So then after that, you need to give this command.
Yes, sir.
So how many steps? More, 2-3 more steps. So
Right.
now if you try to ping 888 or 888, so now it is working. So do you think every time we will call network engineer and say, oh man, put a static route? Oh, sorry, add a NAT
Change the
command.
NAT, yeah.
NAT command.
No.
Okay, suppose if Airtel internet comes back. Okay, and remember what is the problem? Airtel is your 100 Mbps, Vodafone is 50.
Yes, sir.
Yes or no?
Yeah.
Yes, sir.
So you will still, internet is working fine. So let's see if I have added a E00 command. Okay, so if I have given no shutdown command, traffic is still going from E01. But what do you see here? Because now the interface came up. जैसे इंटरफेस आप आया उसने स्टैटिक राउट दोबारा किधर कर दिया?
Airtel पे.
Airtel पे कर दिए.
So when my interface came up, Airtel like router moved the static route to the first ISP. Yeah? Yes or no?
Yes.
So it means logically this command is again wrong now. Yeah?
Yes.
Because you are forwarding NAT with which interface? E01, but your static route is going in which interface?
E00.
E00. 1.2 IPs on which interface? E00.
E00.
There is a problem, yes or no? Everybody agree, say yes.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Agree, sir.
Agree, sir.
Okay, सोचो क्या करेंगे? वैसे मैंने हिंट दे दिया था.
again changing back manually all those things.
Route map.
It's a complicated solution problem, right?
HSRP, sir.
Route map. So route map.
No, HSRP, or standby routing
Route
protocol.
map if you're using in the BGP, na sir?
Route map you can use anywhere. Even I will show you in static routing.
Sir, HSRP. hot
अरे
standby routing
HSRP
protocol.
मामा
LAN.
नहीं चलता इधर.
I
You
thought
cannot
can
say
we use
Airtel. You cannot call Airtel and Vodafone. Okay, Airtel Vodafone, put yourself into same subnet because HSRP works in same subnet.
Okay.
समझ आ रहा है?
Sir, can we use static netting?
Static NAT कैसे?
So that's
Like
why
you have to
we need dynamic
mapping.
NAT, I guess.
So if you have 100 users here, so you are saying like you need to buy 100 public
Yeah,
IPs.
Not at all possible.
Yes, sir.
Yes, Benjamin.
AD values.
Okay, basically I have already given that answer. This problem can be solved with only one thing, that's called route map.
Route map under NAT.
Okay, so I'll tell you which is very easy. Route map, I will tell you from very basic what is route map. But today, just understand there is a policy which I'm going to set right now. You just need to understand route map is if else statement. So what is if else? If this works, then make this policy. If this happens, make this policy. Okay. So what I have to do now? I will create a route map here. Route map. So what Airtel ISP name is Airtel, right?
Airtel.
So we will create a route map with any name like Airtel. Okay, remember A is in the uppercase because it's case sensitive. Airtel permit 10. So permit 10 basically is my so just ignore, just say route map Airtel and just say what is the ACL?
ACL 1.
Huh?
ACL 1.
So match you need to say match any match IP
Yeah.
address. Okay, you can put any ACL number. What ACL we created for 3.1? One. So you will say match IP address 1. Address means it's not IP address. Do not get confused. Match IP address means supply the ACL. So I'm calling ACL 1. Which ACL I created? Remember, do show. Like if you check do show access list. So I have this ACL, right? 3.0.
Yes, sir.
So ACL number is 1. So I called this ACL match IP address 1. And I'm also giving whenever this route map is applied, match interface. Which interface?
0.
E0. 0. Clear, everyone?
Yes.
So now let's create another route map. Route map Vodafone match IP address again which ACL 1. But this time match interface which
is
0/1.
01.
E0/1. Clear, everyone?
Yes.
Yes, sir.
So very simple. We created a logic here. Route map Vodafone. Okay. So whenever a route map Vodafone is applied, what will happen? It will match ACL 1, which is 3.0, and it will forward a traffic to which interface?
0/1.
0/1.
Clear?
Yes.
And under the Airtel, what we did here? So you can check your logics, which is called route maps, by saying show route map. So you can see we created 2 route maps. First is Airtel. So what a Airtel route map is doing, match ACL 1 and set interface E0 0. ऐसे ही हमने एक वोडाफोन का बनाया कि जैसी ACL 1 मिले, once I get ACL 1, apply which interface? E0 1. Clear, everyone?
Yes.
So now the problem was we will not be able to give the commands.
Sir,
Hanji.
so this interface that we are mapping in route map, is it same like when we log into interface and put that command route map with inside command?
No. This time here we have given E00 Airtel interface. Here you have to give the Vodafone interface. But ACL number is same.
Yeah, but no, inside interface also we have to add that route map, no?
Yeah,
Within
that I'll tell you where we have to apply that.
Okay. So this is not same as that.
Just give me 5 minutes.
Okay.
So if so what was the problem? This was the problem. Either I can go E01 or either I can go with E00. That was the problem.
Yeah.
Correct, yeah.
We will not be able to configure this. Yeah. So we will remove all this. Okay. We will remove all the NAT, remove this command, and I will configure IP NAT inside source. This time my source is route map. Airtel. Okay, what was the route map? Exactly, you have to enter the same route map Airtel, and this time your interface is
FAG
E/0/0.
interface E00 overload, and the same thing you have to enter IP NAT inside source route map
Vodafone.
Vodafone interface
E0/1.
E01
overload.
And when you check your show running config, please do this practical, okay, by tomorrow.
Sure, sir.
Can you see both the NAT commands now, guys?
Yes.
Yes, sir.
Okay, now let's test it. If internet is working fine, where the static route is going now? So my internet traffic is going to Airtel.
Yes, sir.
So let's test 8.8.8 going to Airtel. Yes.
Yes, sir.
So if I shut down the interface E00, what will happen? Traffic will
go to Vodafone.
Vodafone or not? Let's see.
इसमें जो पहले बना देंगे सपोज एयरटेल अगर फर्स्ट में है तो एयरटेल फर्स्ट रहेगा वोडाफोन
नहीं, let me do a clear NAT because I think that is the only issue. Now it's working. See?
ये थोड़ा टाइम लेता है सारा सब.
Yeah. Okay, so actually I just so maybe there is
it was taking the old translation.
Yeah. But normally you can do this clear IP NAT translation. Okay.
Okay, sir.
And in this lab, and now it's fixed now. Can you see that?
Sir, in live also we have to do this clear.
No. Clear. So sometimes see normally. So if you check here, so these routers are your latest devices.
Yeah.
Okay. So you can see this is a version 15.7.
Yes, sir.
So there are few. This is a development test software. Can you see here a development test software?
Yes, sir.
Yes, sir.
So sometimes there are some glitches, little bit, which you can be fixed manually, but in real production networks. So most of the times your software is a stable release.
Okay. Sir, one more question. Like if we have two departments, so like by using route map, we can also like divert both the department on different ISPs.
Yes, correct. You can do that.
Okay, sir.
I do not have one user here. Even I can show you PBR, but let's learn slowly. Okay.
Yes.
So at least, yeah, this is a very normal lab. Okay. If you feel like route map is complex, just avoid it. Okay. Because I want to complete one lab. At least you will watch this video. When I will cover route map topic, you can come back and watch this video again and you will be feeling like, yes, I did something great, which will be helpful for you in the industry.
Yes, sir. Let's go slowly here.
Clear, everyone?
Yes, sir.
Yes, sir.
Okay, so you got to know about basic route map, right? Like how to filter it all. Okay, then we'll discuss about more further things also. Okay, so do you know what is redistribution, guys?
So redistributions.
Yes, sir. I know.
Yeah, it allows the two
protocols.
Different protocols.
Okay, I'll cover that topic also. Okay, so right now, what's your try to do this lab and try to cover your basic ACL NAT concepts. Okay, which topics? ACL and NAT. Okay, just try to complete these classes so that you will get an idea.
Okay, sir.
Okay, I'll not be stretching too much today because it's your first day. I want to definitely some days we will be doing 3 hours classes also. But I think some guys are learning for after so many years maybe. So let's learn slowly. Okay. We will not rush with the syllabus content.
Sir,
Yeah.
we do, sir, actually, I don't have like hands-on experience for this EVNG software, sir. So can like.
Yeah, sure. So basically what happens, okay, guys, please, you guys can do these labs, right?
सर तो ये लैब एक्सेस लिमिटेड होता है या फिर अनलिमिटेड?
So basically for fair usage is unlimited. समझे? Now
Sir, I guess
समझदार को इशारा काफी है.
we are not authorized to create a new topology.
Yes, whenever you want to create a new topology, you can just send the design. My team will create it for you, because last time we have given access to students and they deleted all labs.
Okay, sir, that's what they are saying. Like when I asked, so they will create us.
Yeah, you can give any design. You can make a design in Packet Tracer. We will make a design it for you. Okay.
Okay, sir.
We can do it on our own lab also, na, in GNS3 and all.
Yeah. That let me give you idea like how you will be like how to do practicals kind of. Okay. So there are, see, first of all, the software is a Packet Tracer, which is no use on CCNP. So maybe we can cover 10 to 20% topics, like 20% from Packet Tracer. Sometimes when the topic is very simple, maybe sometime, okay, because when I want to show you some header or when so maybe I can cover Packet Tracer, maybe less than 10%. Okay.
Okay.
So the second thing, you can install GNS3. So GNS3 is a tool which, like if you have 4 GB laptop or 8 GB at least, so then you can use a laptop, this software called GNS3. It's a good software, but I do not like it. Not because I do not like because it takes a lot of CPU. Okay. So it takes a lot of CPU. That's the only thing.
Yes.
Okay. So this is a software, you just need to create a project from here. Maybe some of you have used it.
Yes.
My CCNA guys have not used it because they directly worked on EVNG.
Yes.
So these are the routers like that. Okay, you can pick here, you can connect the cables from here. Okay, like this. And you can turn on the devices from here. So this is a good tool. Okay, so you can see here. And directly you will get the console. Okay. But the problem with this, like I do not feel like, because it takes a lot of CPU first of all. Okay. And when you run GNS3 for VMware, there are a lot of complications. If you feel like it is easy, definitely you can install. But there is always a problem in GNS3 with the switches. Okay. But nowadays, like you can run switch images also in GNS3. So routing to space there is a problem in switching sometimes, but now I think that's also fixed by GNS3. Now you can run aram, say like you can use like switches and all. Okay. So the conclusion is like, I'll give you EVNG. Okay. So there is another tool which is called EVNG. Even our labs are powered on EVNG. So this EVNG is something like a better tool, not because of just it's easy. You just need to run inside VMware player. Okay, you have to download VMware player and all, and then you can just configure this. And also guys, if you want to set up your own lab, okay, like so we are giving you lab access for sure. Okay. But still, if you want, you can install into your laptop and configure this Eve. So you need to download the EVNG Community Edition, because Pro Edition is a paid, Community Edition is a free. So Community Edition, you can download here, free Eve Community Edition. You can click here on the Google Mirror. Okay, you need to download this OVF file, not ISO. Okay, because you are going to install inside your laptop. If you have a spare laptop directly you want to run that, still I would prefer go for this option, EVNG OEVF. Download this 1.1 GB file. Okay, and when you download this, this file will be open in VMware Player. Okay, so you can
Okay.
download VMware Player. If you use a MacBook, you have to download VMware Fusion, which is, I think, not free.
Available, I think.
Yeah, yeah. And it's very annoying also.
Yes, sir.
So it's better you install like directly. You can use R Labs. Okay. So you can see workstation 16.0 player for Windows. Okay. And you can download this.
Sir,
Okay.
only
So
VMware Fusion, like Fusion version, specific version is required, or any version
no,
if
no,
we
no.
got any crack list
I
for
have
Mac?
VMware Fusion. I think I paid $50 also for Fusion, but it never worked very well in my MacBook. So what I did here, I have a Windows machine, like laptop. Okay,
sir.
virtual machine I use sometimes there only. Okay. I have servers here. So
Okay.
you also got the servers. Okay, but yes, like after the batch, maybe after like if you are going to learn with us for next 3 months, 6 months, so till your batch is running, you will be going to get the lab access. But additionally, we will always give 1 month, 2 months extra time, and sometimes like up to 2 months more than that also. So you do not have worry about the lab. So you will have enough time to practice. But still, I'll give you EVNG, because the problem with EVNG, when you download this EVNG, okay, you need to install a lot of images and you need to crack the files, a lot of complications, right?
Yes, sir.
So what we did here, we have one EVNG modified by ourselves. Okay, we have a version which is EVNG NK edition or something, you can say light or something. So where you have routers, which is an ASA firewall image. You do not have to do anything. Just double install VMware Player. Second step, first install VMware Player. Just click on that file and you will be ready with your EVNG platform. Okay.
Okay.
So maybe I do not have a Windows laptop right now. So maybe by next week, I'll share you like how to install that exactly, and you can use in your laptop also. Okay. Okay. So we are going to start the EIGRP. Okay. So EIGRP. So what is the full form of EIGRP? That stands for Enhanced, okay, Interior Gateway Routing Protocol. Okay, so before this EIGRP, there was one protocol which is obsolete now. So EIGRP से पहले एक protocol था IGRP, but this IGRP is no longer used because this is obsolete. Okay, so Cisco made first IGRP, which is Interior Gateway Routing Protocol, and after some time they released the Enhanced Interior Gateway Routing Protocol. So this is a derivative of Interior Gateway Protocol. So this is the new version, and it support VLSM. It supports subnetting. Okay, so and this EIGRP also support high speed interfaces, like high speed interface metrics, because every protocol calculate the metrics, right? So remember, like if you studied about RIP, so what is the metric of RIP? Yes. What is the metric of, not AD value, I'm asking metric. Metric is hop count. Like RIP always check the hop count, that how many routers are coming in my way. Okay, so tell me, like if you have studied RIP, suppose this is one router. Okay, so this is my destination network, like 10.x.x.x, suppose, and there is one another path. Okay, so this is 1 GB path. I'm talking about RIP right now, and these are 100 Mbps. Sorry. So this is 10 GB. The below links are 10 GB. So tell me, if you are using RIP, which path this router will follow if you are using RIP? The first path A or path B? In the case of RIP protocol, so RIP only checks the hop count. So you can see if we go from path A, the first and 2, the hop count is 2. The path A has a hop count of 2. तो दो राउटर बीच में आ रहे हैं अगर A path से जाएंगे. Okay, but if we go from the B path, the hop count is like 1, 2, 3, okay, 4. So the hop count is 4. So the RIP routing protocol is going to use this as the best path. So this is why we do not use RIP in industries, because RIP is not an intelligent protocol. RIP do not check bandwidth. Okay, maybe someone will ask you, maybe in interviews, that why we do not use RIP. Obviously, we can only use maximum up to 16 routers in RIP protocol, but another disadvantage is that we can't check the bandwidth. RIP do not check bandwidth, it checks the hop count only. But when we talk about EIGRP or OSPF, though both protocols check the bandwidth. Okay, so if you use EIGRP, tell me which path we will follow. अगर हम यहाँ पे EIGRP configure कर दें, instead of RIP, if we will use EIGRP, which path will be used? Then B path will be used. B path will be used because B path has 10 GB links and the A path has only 1 GB links. And if you use OSPF also, which path will be considered? OSPF use करेंगे तो भी कौन सा path use होगा? So when you will use EIGRP OSPF, the path B will be the best path. A is not the best path. Prashant, RIP is just a basic protocol. You can check maybe somewhere or maybe in my YouTube channel also. Okay, so you can check that RIP is, we do not use RIP nowadays. Okay, but the configuration is same. Metric, yeah. So when we talk about EIGRP metric, okay, so EIGRP, like in EIGRP, we can support up to 255 routers. Okay, so we can use up to 255 hops, but in hops means devices, right? So we can go up to 255, but by default, if you configure in Cisco, by default it is 100. So you have to give one command, maximum distance something, maximum hop. There is a one command. Then only you can increase 255. Okay, so by default, if you use EIGRP, so all routers by default they support 100 routers, but you have to increase it 255. So the default value is 100. तो default में आप 100 routers use कर सकते हैं और increase करके, so by increasing that number you can go up to 255. Okay, so EIGRP uses one algorithm which is called dual algorithm. So that is called diffusing update algorithm. Okay, so dual stand for diffusing update algorithm. So this protocol is used for identify network paths, okay, रास्ते ढूंढने के लिए यूज होता है, identify network paths and provide faster convergence. What is convergence, guys? Okay, I will explain this technical. Okay, because this dual algorithm will pre-calculate the loop free backup path. Pre-calculate means पहले से ही calculate करके रखता है. Pre-calculate loop free backup path. So what is the best? Why we use a dual? This is the answer. Why EIGRP uses which algorithm? Dual algorithm. Okay, dual algorithm. And what is the use of dual algorithm? It pre-calculate the loop free backup path. Okay, तो ये पहले से ही backup path को calculate करके अपने table में रखता है. Okay, it calculates the backup path and it stores into the topology table of EIGRP, which we are going to understand. Okay, So let me show you example. What is convergence? Okay, first we need to understand this word convergence. Okay, so suppose this is your primary link. Okay, suppose this is path A. So path A आपका primary link है. Okay, so maybe you have a backup link from this side. Okay, maybe this is your backup path. This is B. Okay, bandwidth is same, like 1 GB links. So if path A is the best path, suppose if we are going from this LAN network to this destination, तो अगर हम इस साइड से destination ये है हमारा, so the destination is around 10.x.x. Okay, so maybe we are going from this direction. So when router will forward the traffic, it will use the primary path, right? This is my primary path. तो ये मेरा main primary रास्ता है. So this is primary path. This is my backup path. Okay. So so I'll explain that thing later. So primary link, suppose if primary link is down, or maybe the router is down. So we are discussing about convergence. So if primary link is down, okay, so normally if you check about any other protocol like RIP, OSPF, right, so they have to calculate the path again. So in दूसरे अगर कोई और protocol है, suppose you are using RIP, OSPF or maybe some other protocol, so router has to calculate the path again. तो router को दोबारा से रास्ता ढूंढना पड़ेगा. But EIGRP uses dual algorithm, which is smart algorithm. So it pre-calculate the loop free path. So पहले से ये backup path अपने table में रखता है. Okay, so already EIGRP store the backup path into one table, which is called topology table. Okay, so if we have A path in the table, we have B path also. Okay, so the best path is A. So this will be in my which table? All the best path we have into which table, guys? Routing table, right? So we have A path in the routing table, but if A path goes down, so what will happen from the topology table? The B path will become my best path, right? Yes. So the best was A, but if A goes down, the B path instantly go into my routing table, right? And that becomes my best path. So this is called faster convergence. That if any link goes down, how much time the router or protocol is taking to choose the second path as the primary path. तो कितना टाइम लग रहा है प्राइमरी डाउन होने के बाद सेकेंडरी पाथ को बेस्ट बनाना. Okay, so if my primary fails, how much time it takes to make my backup path as my primary path? Okay, so that is called convergence. So in case of EIGRP, the convergence is very fast because the reason is because EIGRP dual algorithm pre-calculate the loop free backup path. Is this clear, everyone? Okay, so primary path अगर डाउन हो जाता है ना तो बैकअप पाथ को प्राइमरी बनाना पड़ेगा ना. So if primary path goes down, the backup path will become my best path, right? So the time it takes to make this backup path as my primary path means very simple, guys. Like if A path was my best path, right? So if A path goes down, the B path will become my best. So this time, how much time it is taking, that is called convergence. Okay, identify the network paths. Okay, it identified the network path, like we have path A, path B. Another faster convergence because we store the pre-calculated paths in the topology table. Mahfuz, we have not discussed that right now. Saju, the loop free path you will understand later on. Okay, so you can consider the backup path. Loop free, you need to understand some advanced concepts of EIGRP. Okay, this is just a beginning, guys. Just hold on. We are going to learn those things. So if my primary path comes back, If primary path comes back, yes, the primary path will take the position again. Okay, so B will become my backup. If primary comes back, the path A will all take his position back. Okay, so chalte hain aage. So the next concept of EIGRP, we will understand more theory, don't worry. So autonomous system. Okay, many students have confusion about autonomous system in EIGRP and BGP. Okay, so first of all, AS number in BGP and this EIGRP is completely different. Okay, so whenever we use actual AS number is like we have to buy this number. Okay, why we need AS number? To run the BGP protocol. Okay, so there is no significance in AS number or in EIGRP. So why we need AS number? Because every company, we will learn this in BGP, but you can understand every company who runs BGP, they need this number called AS number. Okay, so the AS number, it is like 1265535. Okay, so you can see that 1265335. So the companies who runs BGP, suppose this is one company. Okay, so maybe this is another company. Okay, this is another company. Maybe they are service provider or something. So when they are connected with each other, they communicate with the protocol which is called BGP. Okay, we will learn this later on. Okay, so BGP is called Internet Routing Protocol. Okay, BGP is the only protocol in the world which is managing the internet. Okay, so you can understand the AS number in BGP is different, but when we talk about AS number in EIGRP, okay, so the concept is same, but we can use any number in EIGRP. Okay, we can use any AS number in EIGRP because that is local to the router. Okay, that do not go beyond your company. Okay, so to make you more understand, तो क्या होगा देखो यहाँ पे, suppose this is one company, this is one company. Okay, so when we connect multiple routers in the company, okay, that these routers are going to run protocols which are IGP, interior gateway protocols. IGP stand for interior gateway protocols. Okay, so this is another company. This company will also run IGP protocol, okay, inside the company. So what are IGP protocols? Like RIP, EIGRP, OSPF, there is one ISIS. So these all are interior gateway protocols. But whenever we connect from one company to another company, that is called EGP. That stand for exterior gateway protocol. Okay, and there is only one protocol under this category, that is called BGP. So it means whenever we want to connect with the different companies or maybe different ISPs, then we use BGP, and then you use this number called AS number. Okay, so when we talk about the actual AS number, we use in BGP. So remember this. But when we use AS number in EIGRP, so when you will configure EIGRP, the command is like router EIGRP and the number. Okay, so you can number like a 70 or 80 router EIGRP 1, router EIG. So this number is also known as AS number. Okay, so why we have AS number in EIGRP? Okay, so that you can run multiple EIGRP also. So run multiple EIGRP process. Okay, so we can run multiple EIGRP process. So for example, suppose we have a router here. Okay, from this side, like between these two router, you can run EIGRP1. Okay, maybe EIGRP1. So between these two routers, you can run EIGRP2. Okay, like this. So you can see this router is running EIGRP2 on the left side and EIGRP1 on the right side. Okay, so this is one important aspect why we have AS number in EIGRP, so that we can run multiple EIGRP process. Okay, remember, routers within the same AS will communicate with each other. Router within the same AS, router, let me write here. So routers within the same AS, same AS number communicate. Okay, suppose you run EIGRP1 here also. Okay, so they will become friends, right? They will become neighbor, they will share information with each other. But if you have EIGRP, maybe this is also one. But if this router is running different AS number, this router will not get routes, and this router will also not share routes with another AS number. So whenever you connect EIGRP, okay, so the AS number should be same, else they will not become neighbors. नहीं तो वो neighbor नहीं बनेंगे. Okay, they will not become neighbor. So we will do this practical, don't worry. Okay, but I'm just showing you that EIGRP uses one AS number, and do not get confused, like actual AS number is used in BGP. Here in EIGRP, you can say that it is just a syntax. Okay, and what is the use of AS number in EIGRP? We can run multiple EIGRP process in one router. Okay, so run multiple EIGRP process in a router. Okay, so you run IGP inside, and when you connect with the different vendors, so you use EGP this side. Okay, so which is the only protocol under exterior gateway protocol? That is BGP. EGP category के अंदर सिर्फ BGP आता है. Okay, so IGP has many protocols like RIP, EIGRP, OSPF, ISIS. For EIGRP AS number not required to buy. Yes, we do not have to buy AS number for EIGRP, because this is for internal use. This is interior gateway protocols. These protocols we run inside the company. Okay, so these are protocol we run for outside the company. No, Hardeep, like you can't run multiple EIGRP process on one interface. Okay, I'll show you this, don't worry, I'll show you this practical. So ye padhenge hum, don't worry. Okay, so next is like EIGRP. Okay, so EIGRP. Yes, Puneet. Puneet, you have a doubt? Hello. Yes, Puneet. Yes, Mr. Raju.
Sir, EIGRP optimization concept there is no, sir. That can also explain, also.
EIGRP optimization?
Yeah, in EIG optimization, that is stub and
yeah, we will learn stubs. Yeah, that is an advanced topic.
Yeah, SIA and stuck in active.
Yeah, stuck in active, stub areas, everything we will learn in the content.
Okay, okay. Sir.
You want me to explain right now?
Yeah, yes. Sir.
But this is not, this is the first class, bro.
Okay. Sir.
Okay, so EIGRP uses this protocol which is called PDM. EIGRP uses PDM. PDM stand for protocol dependent modules. Okay, this is the only protocol in the world which support protocol dependent modules. Means EIGRP supports obviously IPv4. Okay, many other protocols support IPv4, IPv6. Okay. Okay, so there are many other protocols which we do not use nowadays, like IPX, Apple Talk. Okay, but yes, EIGRP uses many different protocols like IPv4, IPv6, IPX, Apple Talk, which is discontinued in 2013. IPX also Internet Protocol Exchange. So we never use these things, but EIGRP uses this protocol dependent modules. Okay, so you can say that in interview, if someone will ask you in interview, what is the difference between EIGRP and OSPF? So you can say that EIGRP uses multi-protocol dependent modules, or EIGRP supports protocol dependent modules. EIGRP can be used with the different protocols. Okay, this is just a theory, like EIGRP supports different modules. That's it. Okay, so we have to learn which is called EIGRP terminology now. Okay, so guys, this PDM, you do not have to go in depth of this. Just it's a theory part. Yeah, EIGRP supports protocol dependent module, like different protocol. That's it. Okay. Yeah. So EIGRP terminology. So what is the terminology? Terminology means how EIGRP calculate best path. We will understand how EIGRP calculate the best path, and also how EIGRP calculate the loop free path. Okay. So you need to understand, I think, three things. First, you need to understand what is successor. Okay, this is a word which we need to understand, successor. There is another thing which is called a feasible successor. Okay, the third thing we have to understand, that is called feasible distance. Okay, and another is called advertise, or there is another name of this, advertise distance, and some books you will see this is also known as a reported distance. Okay, reported and advertised distance is same thing, reported distance. So if we learn all these things, 1, 2, 3, 4, and the fifth is called feasibility condition. Feasibility condition. The fifth point is the most asked question in EIGRP interviews. If someone will ask you EIGRP, they will ask about the feasibility condition. ठीक है, so ये concept हम पढ़ने वाले. So first you have to learn what is successor. Okay. Okay, so we have a router here. Okay, so we have a path from here. Okay. So there is one another path like this. So EIGRP calculate the metric. Okay, EIGRP calculates the metric. There is a formula. Okay, we will understand that formula as well. But as of now, you can understand This is my primary path. Why? Because if you check the feasibility condition, or which we call FDAD. Okay, so tell me, the higher is preferred or the lower value is preferred in EIGRP? Yes, guys. Guys, lower. Okay, not higher. Okay, high bandwidth, but EIGRP का एक फॉर्मूला है, वो जो आप जब निकालोगे उसको तभी सॉल्व आएगा. ओके, so here I will show this in some lab. Okay, maybe I'm going to use, even this is CCNP, but we can use packet tracer for this small lab, because here we are going to learn the concept. Okay, so normally 70-80% of the labs we are going to use like the advanced devices. Okay, but for like 10-20% small topics we can still use packet tracer. There is no shame in using packet tracer in CCNP, even if it is helping you. Okay. Okay, so we are going to learn these concepts today. Okay, this is very important session of EIGRP, so please complete this. Okay. Okay, so what we will do to understand FDAD value, so we can use any routers. Even I can use GNS3 or even G, but this small practical, to just understand EIGRP, we can use this packet tracer, which is a free software from Cisco. Okay, you can use this for very small labs because it's very handy. You can just turn on the devices within 2 minutes. So I will take one router. You can see I have taken 4 routers. So let me connect the cables. Okay, so can you see that we have gigaports? Okay, so what I'll do, I will create a small loop back here. Okay, and this will be my destination address. Okay, so we can use any loop back. So why we are creating loop back? Just for one destination address. Okay, तो यहाँ loop back हम ले रहे हैं destination address को imagine कर रहे हैं. So we can take any network like maybe 20.1/24. This will be my destination IP address. Okay, so this is my destination address from this side. Okay, so we can configure EIGRP between these devices. So let's rename. This is R1. Okay, this is router 1, this is router 2, this is router 3, this is router 4. Okay, very simple topology. I will not make you overwhelmed. So this is very, very, very simple topology. Okay, so you can see router 1, 2, 3, 4. Ganesh, it will be. Okay, let's see. If we can't, maybe we can try the LAN network. Okay, so I'm going to configure this very simple topology. So you can give any network here. So let's call 12.1.1 or maybe 24. This is 24 side network. This is 13 network we are using, and this is 34. So you can see how I have used the subnets. So between 1 and 2 routers, I have taken 12. Between 2 and 4 routers, I have taken 24 subnet. Between 1 and 3, I have taken 30 network. Between 3 and 4, I have taken 34, just for the lab purpose. Okay, so let's configure. So guys, please always use Notepad for the configurations because it will be very helpful for you to do the bulk configuration. Okay, maybe you have not done this practice in CCNA, but request everyone to use the Notepad before doing any configuration. Okay, it will be more easy. So the first router one. Okay, so we will use enable config t interface GIG000 IP address 12.1.1. Okay, very simple config. So let's copy paste GI001, which is 13.1.1.1. Very simple. And how we will configure EIGRP? Please check if you have not seen EIGRP before. Router EIGRP. Okay, you can give any AS number. Okay, let's give 1. Okay, so you can give 100 also, 200 also. Let's give 1, which is simple. And you need to type the network command. So what will be the network ID? You can see this is a /24, 3 times 255. So my network ID will be 12.1.1.0. Very simple. After that, my another network ID is 3255. So we can use the 13.1.1 as my network ID. Very simple. But EIGRP, if you want to support subnetting, you have to give one more command, which is called no auto summary. Okay, so no auto summary means by default devices do auto summary. What is auto summary? So you can see this is a class A network. So when router is going to send update from one router to another router, router will send the by default subnet mask. तो क्या होगा? So just hold on. Okay, so yeah. So when this, if auto summary is enabled, agar auto summary enabled hai, if auto summary is enabled, yeah, just hold on, my pen tablet is giving me some issue. एक सेकंड दो गाइस. Yeah, now it's okay. So you can see when we will send this network, if auto summary is enabled, these are CCNA concepts, but I have seen many people who join CCNP, they still lack in these skills. This is why I'm showing you. So if auto summary is enabled, this router will receive 12.0.0.8. Okay, but in actual my network is /24. If you want to send the exact slash value to another router, if you want to support subnetting, in short, what I'm trying to say, if you want to support subnetting, you have to give no auto summary, else the device will send the by default subnet mask. Clear, everyone? Clear, everyone? Yes, I want everyone yes in the chat. Ayush, I'll discuss with you later on. Okay, so the same process you can copy paste and do this on all the routers, which is very simple. So let's go to R2. What we will do, we will just change the IP GI00. So I will take the last octet 2 here. Okay, so GI001, this is router 2. So I can use 13.2 here. This is router 2. So I'm just taking 2 IP in the last. This is router 1. I'm taking the last octet 1. So you can identify this IP belongs to router 2 and the EIGRP process is 12 and 24. Very simple. So let's go to router 3. So you can see the notepad is super easy to configure. So 000, we will use 13.1.1.3 on G001 and we will have 34.1.1.3. So router EIGRP 13.1.1.0 and router EIGRP 134.1.0. So the last router I'm going to copy paste. Okay, this is how you configure EIGRP, guys. Route interface GI00, this is 24.1.1.4 and GI001, that is 34.1.1.4. Okay, so here what we have to take 24 and 34. I'm sure this is not giving challenge to you, so this is very easy. So you can just go to the CLI windows of the devices and you can copy paste this config. Done. So let's go to router 2. Make sure you do the correct copy paste. Okay, so guys, एक चीज मैं और बताना चाहता हूँ. Suppose, okay, so this is router 3. So I remember, like in real production network, what happened? Okay, so this was a mistake, but we had maintenance window. Okay, so what mistakenly, like I copy paste another router config and another router, and this is human error. Maybe this is not like, maybe I do not have a potential to become engineer, right? If I have copy pasted wrong, maybe it will happen with you also. So what I'm trying to show you, this can be possible. Okay, so maybe this will happen to you also. Suppose I copy pasted router 4 config in router 3. Okay, so do not get impact. Okay, if you are in maintenance window, of course. So what you can do, you can copy paste the same config. Okay, so you can copy paste somewhere else and you can just type, give this command, no, and no. That's it. Okay, so you just have to give no command on the IP address, no command on the router EIGRP, and you can remove this because we do not. Okay, so we can use this no IP address only. गलती से हो जाता है ना, गलती हो जाती है भाई, बड़े बड़े लोगों से हो जाती है. So if you do this mistake, maybe suppose we have copy pasted router for configuration router 3. Okay, this is I am showing you with my real experience. ये होता है, बड़े बड़ों के साथ हो जाता है. Okay, so you can just remove the old config. Now you can copy paste the correct config. Okay, you can copy paste like this. You can copy paste the correct config now. Okay, and we forgot to give the host names. Please make sure you give the host names. Whenever you do practical, it is easy for you to identify the devices. So let's copy paste the router 4. Nobody appreciated me for that thing. We trainers are actually hungry for appreciations. Yeah, it was a rollback plan. Yes, it is a rollback plan. Like if something happens wrong, so you have to roll back. Roll back means please come with the old config. ठीक है, तो roll back plan था ये हमारा. You just give the no IP because we just did this config. You do not have to reset the complete router. So whatever commands you have given, just give the no and paste the correct config. Okay, so router 4 is left with one loopback. Router 4 पर एक loopback भी बनाना है. So I can create a loopback here, interface loopback 0, IP address 192.168.20.1. Okay, and we need to add this whenever you add a network. Okay, whenever you add a network, automatically it will not go in EIGRP. Okay, so whenever you add a network 20.0, you need to add this under EIGRP. So I have this config, so you can copy paste. So I have added the loopback in my network also. Okay, so let's check on R1 if we are getting that destination address in the router 1 table. This is host R1. So I'm checking on R1 now. So if you check show IP route, so currently I'm getting that loopback from one path. So maybe we will see from second path also. Only we are receiving from the lower path. Okay, I think there is a problem. Aditya, we have created a loopback for testing. This will be my destination address. You can create a LAN network here. You can build you can connect a switch and put some devices there. So I just saved my time by creating a loopback. Okay, so maybe something wrong. Let me, so how to troubleshoot right now, you can see this route I am not getting from both path. Okay, मुझे दोनों रास्तों से path नहीं आ रहा है. So it should be coming from two paths, but it is only showing me one path. Maybe one path from this side has a problem. So let's troubleshoot. Okay, so EIGRP makes how many tables, guys? So remember, EIGRP makes 3 tables. First is neighbor table, which will consist of directly connected routers. Directly connected neighbors or directly connected routers. Okay, directly connected. After that, we have a table which is called topology table, which will, this will consist of list of all the networks, list of all received or list of all the prefixes. Prefix means routes. Okay, use technical words. List of all the prefix. Okay, and the third will contain your routing table, and routing table will always have best path. Okay, so first we get all the neighbors, and then neighbors share the routes, which we will add into topology table, and from topology table the best path will move into routing table. Okay, so you can see R1 will receive R2 in the neighbor table, then R2 will send the routes to R1, we will add in the topology table, and then we will choose the best path and add into the routing table. So all tables are related or dependent on each other. ठीक है, तो सारे राउटर एक दूसरे पर डिपेंडेंट है और tables are dependent on each other. Sir, R2 config is wrong there. IP address we have issued. Okay. Let's see, guys. एक गलती हो गई है. So let's go to R2. Okay, so we have done some mistake. Not you, me, actually, but we were doing together. So R2 is wrong. There is IP address we have issued 13. Okay, so R2 this. Yeah, so here we have to give 24.1.1.2. Very good. So this was a troubleshooting step where we have the misconfiguration where the config should be 24. And this is why you guys can troubleshoot here. Show this is router 2. Okay, and if we check the neighbor, show IP EIGRP neighbors, it is only showing me R1 is my neighbor. So R2 is only showing 12.1.1, which is R1. R1 is neighbor, but R4 is not neighbor because there was a mismatch in the IP address. So once I gave the correct IP, so we became neighbor with R4 also. And you can see we got both neighbors in R2. Okay, and now you can check on R1 also. We will receive the route from both directions. Can you see that? So now it is showing me this path I am receiving from both the paths. तो मुझे दोनों रास्तों से I am getting the route from both the paths. Can you see that? I am checking on R1. I am checking on R1. I am receiving this path from both the paths. Okay, so how I got it? So you can see I am receiving 192. This network, this is my network. So I'm receiving from 13.1.3, which is I'm receiving from router 3, and I'm same route I'm receiving from 12.1.2. And why it is showing me this is whenever you see two links in the routing table, जब भी आप देखते हो routing table में दो रास्ते दिख रहे हैं, whenever you see two paths in the routing table, this is what we call ECMP. What is this? Equal cost. Okay, so this is what we call. Yes, guys. Equal cost traffic. Yes, great. ECMP is equal cost multiple path. So ECMP called equal cost multipath, not multiple, multipath. Okay, so this is called ECMP, or you can also say that equal cost load balancing. Some also say equal cost load balancing. Okay, so now we are getting the same path, but why EIGRP is considering both paths same? Because all the links are 1 GB. Okay, all the links are 1 GB. तो मेरे सारे रास्ते क्या हैं 1 GB. So all my links are 1 GB path, and you can see this is this whatever value you guys see here. This is called feasible distance. Remember, we have to learn something. Okay, so there were 4 parameter, 5 things. Okay. Okay, sorry guys, एक call आ गया था. Okay, so ECMP equal cost multipath. So let's understand this ECMP and all these things. Okay, so this is called EIGRP. So अब ध्यान से बैठ जाओ, बहुत जरूरी टॉपिक है. Whenever you guys need break, just let me know. I'll give you 5-10 minutes break. But this is very important. एक ही बारी में करके खत्म करो, समझ रहे हो? Many people they keep dragging CCNP for a year. Okay, many students, even my students, those who have done CCNP last year, they are coming back now that they want to learn, they want to revise. So what I'm trying to say, why you are keep dragging one particular thing for a year? Just do it and move to other courses, the advanced things like SD-WAN, firewall. Just do it one time. You do not have to drag yourself in the same course for 5 years, 10 years, right? So just do it one time with full potential, with full what we call, with your full hard work, because you keep dragging this course for a year, 2 years like this. So do it one time, just make a goal. This routing switching is not rocket science. Okay, we do not have to be perfect in routing switching. Even I'm teaching you this, still I'm telling you just do it one time and move forward. ठीक है, तो sorry, I was showing you some EIGRP metric. ओके ओके, एक फॉर्मूला था यार, मुझे बस वो निकालना है. This one. So okay, yeah, this is the formula. So I just need these details. Okay, so I'm making your notes, don't worry. तो मैं notes बना रहा हूँ. Okay, so let's calculate the formula. Okay, so let's calculate the formula. So this is the formula to understand about EIGRP matrix. So first, how you will understand this? When you will understand how EIGRP calculate the traffic. Vijay, you can ask in LinkedIn. Okay, so you can see this is a formula like bandwidth. There is a formula 10 to the power of 7 and whatever bandwidth you have, and so 1 2 3 4 5 6 7, so 7 zeros. This is the formula, bandwidth 10 to the power of 7 divided by your actual bandwidth. Okay, so tell me what is the lowest. So what we have to get, lower bandwidth link. तो हमें सबसे lower bandwidth link निकालना है. So tell me what is the lowest bandwidth link for first path. So let's calculate the first path, this path. So this link is also 1 GB, this link is also 1 GB, right? And this is a loop back. So you can see the lower bandwidth link is 1 GB. So we do not have lower than 1 GB. Yes or no? क्या 1 GB से lower link है हमारे पास यहाँ पे? Do we have lower than 1 GB? Do we have any lower path than 1 GB? No. So we will take 1 GB. Okay, so you can check here also. You can go to the router. How to check the bandwidth? You type show interface GIG000 and you can check your bandwidth. This is showing you 1000 Mbps, and you can check the bandwidth in kbps. So you have to take this value, k kilobits kb. Okay, so you can take 1 2 3 4 5 6 and just put here. So this is your formula. So you have to divide the lower bandwidth, which is 10 to, you have 1 GB. So this is in KB, kilobytes. So you have to write in kilobytes, and you can divide by 10 to the power of 7. And tell me what you will get. You will get a 10. Yes or no? You will get 10. Yes or no? अगर मैं 10 की पावर 7 को 10 की पावर 6 से डिवाइड करूंगा, if I am going to divide 10 to the power of 7 with 10 to the power of 6, I will get 10. Yes, all agree? Okay, so this is the first step to calculate EIGRP metric. This is what EIGRP is already doing. And then we need to take the delay of all the links. So what is delay? Like every link has a delay. So you can see the delay is a 10. Can you see that? DLY, this is delay. This is 10 for 1 GB link. So you can type 10. This is delay, DLY. You need to sum. आपको add करना है. You have to add delay. This is also 1 GB, the same delay. Delay is 10, 10, 10 here, 10 here. And let's check the delay on loop back. Okay, if you are not using loopback, you can use LAN network also. But I am checking for loopback. I have created loopback. So you can see the delay is of 5000. Can you see this is a loopback? So the delay is giving me a delay of 5000. This is by default for loopback. Okay, so don't get confused why it is 5000. This is for loopback by default. You can take LAN network, you can connect a switch also if you are getting confused. So you can see we have a delay 10 plus 10 plus 5000, and then what is the value we get? Sum karna hai hame. So what is the value? We will get 5020. Yes. If we plus all the delays, 10 plus 10 plus 5000, we will get 5020. Right? Very simple. The first was to get the low. Nobody, like, I'm sure there is no one who is actually showing you how to calculate bandwidth. So please focus here. This will make your EIGRP more strong when you actually know the protocol, you understand it in very depth. Thanks, Ivakin. ठीक है, तो ये ध्यान देखो. And now, so you can see this is in what we call this symbol. When we see this symbol, USEC, what is this? What is USEC? This is called microseconds. USEC is called microseconds. Yes. Okay. So this is just whenever you calculate the time delay, so you need to divide that with 10. Okay, for EIGRP, and you will get what? You will get 502. Yes or no? Okay, because the time is in microseconds, so you can divide by 10 and you will get 502 number. Okay, so the formula is here. The bandwidth 10 to the power of 7 divided by minimum bandwidth in the path. So the minimum bandwidth we had is 1 GB. We have written in 1 kbps, and then we will use delay, sum of delays. We will add it and we will divide by 10 because the delay is in microsecond, and we will get the 502. The last formula, this is the complete EIGRP formula. Okay, so you need to plus the bandwidth you will get. So what bandwidth we got? 10. And what is the delay we got? The delay we got is 502, and you need to multiply by 256. Why 256? Because in EIGRP you need to multiply by 256. But if you want to calculate IGRP metric, you do not have to calculate multiply by 256. Okay, but IGRP protocol is not used nowadays, so you need to multiply 256. This is the formula of EIGRP. Minimum bandwidth plus sum of delays into 256. So tell me, what is the value you are getting? क्या value निकल रहा है देखो. Let me show you with the calculator. Okay, so let me take the basic calculator. So 10, okay, 10 plus 50, shit. Yeah. So 502 into 256. Okay, I'm doing something wrong. So maybe 502, let's do addition first. Okay, 502 plus 10 is okay, and then multiply 256. Sorry guys. Okay, 512 into 256. So you can see we got the value. So remember that board, remember in our school days we have learned that board mass something that we need to remember. So we need to multiply, right? But it is giving us wrong, so we have to add first here. So I was checking according to the board mass. So just simply plus it and then multiply it, and you will get the value, which is 131072. 131072. Okay, so this is the FD value. This is how EIGRP calculated, and it is showing you the exact value I have calculated for you all. How cool. Can you see that? 131072. And if you calculate the same for the lower path, because the cost is same, everything is same, delay is same, it is also giving you the same exact value for my lower path also. Abhishek, if you are not getting, so just 502 plus 10, this is 512. You can see you need to plus here and then you can multiply to 56. यहाँ पे brackets हैं देखो, right? So we can plus 512, you will give 512 into 256. So you can see we can now understand how the EIGRP is calculating the bandwidth. If you read books, okay, so in some books you will see this formula which is little complex to understand. This one, how simple is that? Obviously we can't learn this. This is so complex, maybe looking like we are like working for Elon Musk. So it's like very simple. I have made it very simple so that you can use this one. Okay, so very simple, 131072. So we found it. Yeah. Yes, I know, Hardeep. Okay, so 131072 we got it. Okay. So what is this? This is my full metric from here to here. Yes or no? From my source, because we are checking on router, from my source to destination, this is my full metric, and this is known as a feasible distance. The metric from the source to destination, that metric is called, the complete metric is known as feasible distance. Feasible distance. Okay, and the metric from your neighbor router to the destination. Okay, if you check from here, the total metric is called feasible distance, but if you check from your neighbor from R2 to R4, that is called reported or advertised distance. Advertise, or we can call this reported distance. Reported distance. Okay, so router 2 will also check the metric from here to here, and that metric is called advertised reported distance. The metric from neighbor to the router 4, this destination, is called advertised reported. And when you check the router 1 and you see only FD value here, but if you check the topology table in EIGRP, show IP EIGRP topology, so you see this network and you see both the networks here, both the path, and you see this first value. Okay, तो जो यहाँ दिख रहा है, this value is this feasible distance value, and this advertised distance is this value. So first it is showing me FD value, after that it is showing me AD value. This AD, do not get confused about administrative distance. That is different thing. Here I am talking about advertise distance, or if you are getting confused about AD value, you can call this RD. Many people say RD. तो पहली वैल्यू जो दिख रही है मुझे FD वैल्यू है, और ये वाली वैल्यू जो दिख रही है, दिस इज RD वैल्यू. This first value is FD, the second value is RD. Yes, delay is different on every interface if interface varies. Okay, so if an interface is different bandwidth, then definitely delay will also vary. But if the bandwidth is same, the delay will be same. Okay, so let's see what is feasible distance. So you can see feasible distance, the total distance from source to destination is known as a feasible distance. right? And what is reported distance? The distance from your neighbor to destination is called reported distance. Shashank, we will learn that. Just hold on. Yes, correct, Harsh. Very good. So you can see, if you check R1, so you can note down this value. Let's copy paste and let's note down here with the box. Okay, so what value we are getting for the primary path and the secondary path? Okay, so you can see this is my feasible. This first value is my FD value and the second value is my RD value. Okay, yes, very simple. So the first value is my FD value and second is RD. But this RD is the value from my neighbor to destination. Yes or no? For this router, the RD value from my neighbor to destination. Okay, so remember, but if you check on this router, this value will be my, if you check on this router, this value will be my FD value. For R2, this value is FD. For R1, this is RD value. Right? If you check R2, if you check R2 topology table, show IP EIGRP topology. So you can see the 192 network, the FD value is 130816, and this is my FD value on router 2. Can you see that? Like routers are obviously, you can see this is my FD and RD. And if you see this is my FD, I'm checking on R2. R2 is showing me FD is 130816, but this FD is actually RD for R1. Can you see that? ये जो value है और ये value है same है, because if I check on R1, this is my RD. Okay, but for if you check on R2, this is my FD. Yes, Nusrat. We can use 255 routers, but we can use different AS numbers, Nusrat, if we want to support more than 255 routers. एक AS में 255 होता है. Yes, Gurjeet, you have a doubt?
सर मैं फर्स्ट टाइम आज ज्वाइन किया है, तो CCNP के लिए सबसे बात हुई थी. सर जैसे हमारी क्लास चल रही है CCNP में जैन 2020 में किया था CCNP.
Gurjeet, check with the team now. Here we are discussing the technical doubts. Yes, Krishna. Krishna, you have a doubt? Yes, Vikas.
Hello. Hello, sir. I am Krishna, sir.
हाँ बोलो Krishna. I am Balram.
Can you once again explain that the delay one, sir?
Okay. Sorry about my jokes, guys. Jokes. Okay, so the delay, every interface is like, if my bandwidth is more, I will get a less delay, right? So just understand, if you have a big road and if you are driving your car, you can reach your home very fast, right? So the delay will be very less. But if you are in Bangalore, if you are going but there is too much traffic, then you will reach home late, right? So the delay is more. So it means whenever the bandwidth is high, you will get a less delay. The same for packets. The same is for packets. So when we have 1 Gbps links, the delay is only 10 microsecond according to the interface. Okay. If we do not have too much band traffic on this, if the link is 1 GB, the delay is 10. But if you use 1 GB link, suppose this is 1 GB, so maybe the delay is 100 microsecond. So delay totally depends on the bandwidth. So whenever you have high bandwidth links, so you get less delay. Clear, Krishna? Okay, good.
Yeah, clear, sir.
Okay. Okay, so tell me delay. Suppose this is interview going on, and if I'm asking you delay, so what is delay, Krishna? Tell me.
Delay is depends upon bandwidth, sir. It is if bandwidth is more, less delay will be there.
And if the bandwidth is choking, even the link is good, so you will experience more delay, or you will have the good the same delay.
We'll have
suppose you have too much traffic on this link, the interface is showing you that you will get 10 microsecond here. Okay, but suppose this link is highly utilized, maybe somebody is downloading data, so you will have this delay, or your delay will vary.
Delay will vary, sir.
Very good. Yeah, delay will vary according to the traffic. Yes, Vikas Yadav.
Hello, good evening,
yes.
sir.
Yes.
So in first router we have FD value 131072, and that is RD value which is our neighbor value, no?
Yes, correct.
But in second router, which neighbor value it is shown? Is it
because this is showing from this router to loopback. If you check on R4, it is also giving you one value, but it will only give you. Can you see that FD is one? It is not giving RD because this is the last router.
Right.
So it is giving you the value here. This is my FD. This is my FD value. So if FD value for this router, this is my RD.
Right.
Got it now?
Yes, sir. Thank you.
So you can see here, like this value and this value is same, and this value is same.
Yes.
Sir, if one side there is 1 gigaport and other side is FA port, then will they come? Yes, Tejinder, it will communicate. अगर एक side 1 GB है, दूसरी side fast Ethernet. Okay, if you have different interfaces, they will communicate on the throughput of 100 Mbps. Lower will be considered. ठीक है जी, clear हो गया. So now we got to know what is FD. Okay, so this is called FD, which is known as a feasible distance. Okay, and what is a reported distance or AD? So the metric from my neighbor to the destination is called RD value. Very simple. Okay, so two concept is clear. Now we need to understand what is a successor. So this link is my best path. So this will be called as successor. And you can see the lower link is also my best path. So this will be also known as successor. So it means to reach this destination, how many successor means primary path. Okay, best path. So tell me for this destination, how many successors we have? If you go and check R1, अगर आप R1 पे जाओ, if you go and check on R1, show IP EIGRP topology. So can you see that it is giving me two successor? it's written over here to successor. Why? Because both the links are my primary path. दोनों लिंक मेरे प्राइमरी पाथ है. Both links are my best path, right? Both links are primary path. So this is why we are getting two successor, right? Because both are having same bandwidth. Okay, both are having same bandwidth. We have two successors. Okay, let's go back to our notes. Let's. तो यहाँ क्या लिखा है? Feasible distance, guys. The total distance from source to destination. Reported distance means the distance from your neighbor to destination. Okay, and what is successor? The primary link is known as successor. Okay. Suppose if this link is not the same value. Okay, maybe if you consider this is all 1 GB, this is also 1 GB, this is also 1 GB. Suppose we are using here 100 Mbps. So router will have two successors now. क्या router दोनों रास्ते use करेगा? Router will use both path? No. So then this path will be my primary path, which will be called successor. Primary path is known as successor. And if this path will become my backup path, this will be called feasible successor. Thoda tricky hai. This is little tricky. The name is so big. Feasible successor means this can be my successor if my successor fails. Feasible successor. हो सकता है ये मेरा successor बने. Feasible successor. This is valid backup path. Valid backup path. Feasible successor. Okay. So successor means primary path. Backup path is known as a feasible successor. Backup path will be known as a feasible successor. यहां तक क्लियर हो गया सभी को? Yes, 4 steps, guys. Right? Okay, but there is a condition. Okay, Arun, I'll take your question. Just hold on. So there is a condition. EIGRP only consider backup path. There is a condition in EIGRP that is called feasibility condition. This is from where you will get interview questions. Explain EIGRP feasibility condition. So the feasibility condition, if EIGRP matches this condition, it means the backup path is valid. If it is not matching, the path is not valid. So how you will understand? Because both the links are primary. How we will do this practical? Because both the links are primary. Yes or no? Either we can change the link. या तो हम इसका link का okay, maybe we can use the gigaport. Okay, maybe we can use fast Ethernet. Okay, so what we can do right now, if we do not have a fast Ethernet port in this router, so we can give this path, maybe we can reduce the bandwidth like 100 Mbps. Okay, instead of 1 Gbps, we can make it half. Okay, we can give 500 Mbps. How to give? So we will go to this interface. You can see I'm going under router 3 GI001. This is just to understand the concept. Interface GIG001. I can use bandwidth and you can give like 500, 3 times 0, 500 Mbps. 500,000 means 500 Mbps. Okay, the same bandwidth, you can copy this. You can give on GI01 another side. तो मैं क्यों दे रहा हूं? Because I really wanted to see what will happen if my bandwidth is lower. तो क्या होगा अगर मेरा bandwidth कम हो जाएगा? Okay, you can see the bandwidth is lower now, and if you check show interface GI001. Okay, so show interface GI001. So it is giving me the bandwidth lower bandwidth, but there is no impact on delay because this is a manual process. Okay, still my interface is gigaport, but I am this command only limit the interface. इस command से क्या होगा? This will only limit the interface. This interface will not send more than 500 Mbps of traffic. You can use this command whenever, like ISP also give this command whenever they give connections to clients. They can put the bandwidth and customers can't use more than bandwidth whatever they have paid for. Okay. Yes, we should reduce both sides to get the proper result. So we reduced 500 Mbps and all the links are 1 Gbps. So if we check the EIGRP topology, so you can see we have two successor, but now let's see what will happen. So can you see that it is now showing me one successor? Can you see that it is only giving me one path? So it means the routing table will also have one path now. मेरे routing table में भी एक ही रास्ता रह गया. I have only one path from 12.1.2, means this will become my successor, but this path is not in my topology table. If this path is not visible in my topology table, so you can see the lower path is not visible in my topology table. क्या आपको दिख रहा है? So are you going to like do you see that traffic is coming from 13 also? 13.1.2? No. Earlier you were getting path from 13 also, 12 also. 13 inside this router 3, we reduce the bandwidth, and you can see this path is not even showing in the topology, because topology will show you all the links. We will understand topology, don't worry. Okay, so you can see the AS number is 1. We will see what is passive, active and all. So focus here. So you can see we can only see the only primary path. तो हमें सिर्फ ऊपर वाला रास्ता दिख रहा है. We can only see the successor. We can't see the feasible successor. Why? So how we will check now? So we can go and check here. If you check the show IP EIGRP topology, so here we can see both the paths. On router 3, it is giving me both paths. Can you see that? So what is the FD value? FD value is this, right? So this will be FD. So it means for my backup path, so this will be my RD. Okay, maybe FD कुछ भी हो सकता है. For my backup path, this is for primary, right? For backup path, I do not know my FD, but I know my RD values 131, because the distance from neighbor to destination, this will be my RD value 131328. I do not know about my FD value. So what I'm trying to say, why it is not showing you, because there is a condition that primary path FD value should be greater than the secondary RD value. So what is my primary path? What is my primary path? This will be my primary path, right? So primary FD value means this value should be greater than this value. So tell me, is this bigger or not? So this value is greater or not? क्या ये this is bigger? Is this bigger than this? The condition is matching. If condition is not matching, we will not use backup path. समझ आ रहा है? If condition is not matching, so you can see the condition is not matching. So this is why. So let me show you again. इसको time लगेगा, I know. So understand the concept again. Okay, so my primary path FD value is 131072, which we solved, right? सभी को पता है solve किया था हमने. right? And if we check, if we reduce the 500 Mbps here, so what happened? So whenever we change the bandwidth, the FD value from here to here is 131328. So remember, whatever FD value I got, that will be my RD value. So this will be RD value for my primary path. And if this is my backup path, this will be my value for backup path. This will be 131328 will be RD value for backup path. So what is the feasibility condition? कि जो primary की FD है, so whatever primary FD is, it should be greater than this value, and which is not matching. This condition is not matching. My primary FD value is 131072. It is not greater than my RD value. From here I got my RD value, right? And this value is not bigger than this value. So it means we are failing to achieve the condition. तो हमारी condition match ही नहीं हो रही. Which condition? The condition is not matching, which is called feasibility condition. Okay, let's so let's change the bandwidth. This time I will change, instead of 500 Mbps, let's try to add maybe 800 Mbps. Okay, so go to interface, let's change the bandwidth now. Let's check 800 Mbps. तो मैं अब क्या कर रहा हूँ, bandwidth को 800 कर रहा हूँ. So I'm doing, instead of 500, I'm taking now 800. Okay, so I have taken the 800 now, and let's see what is the topology. So you can see 13.131328 something. Still it is not matching, right? Still it is not taking. So let's see. Still it is not receiving. Let's change it to 900. Okay, this is router 3. I'm doing changes on router 3. So interface. So let's try to give more different bandwidth, like 500, 900 Mbps देके देखते हैं. So let's give 900 Mbps. 8 पे भी काम नहीं कर रहा है. So let's give 900. Okay, let's check topology. Yeah, it is giving me now 13102. 13. It is giving me this value now. So can you see that it is same value now? Exact same value aa raha hai. We got it 131072. Okay, तो ये देखो मुझे ये आ रहा है exactly 13102 something. So I got this value 131072, and if we check here, it is still not taking because this condition should be bigger, not equal. तो bigger होगा तभी चलेगा. So let's change again. Let's change again to 950. Okay, तो 950 देते हैं. So maybe this time, can you see that? Whenever we change bandwidth, the FD-AD value is changing. Okay, so maybe this time, hopefully, we will close this. So 130816. Yes, this condition is almost now matching. Are we close now? अब condition match हो रहा है. देखो 130816. This is lower now. Can you see that? Can you see that? This is lower now. If we compare now this with this ID, so the primary FD value is greater than this value 131072. Yes, this is bigger now. The condition is matching, and let's go and check the topology table. कि topology में दिख रहा है? I'm so excited. Are you? Let's check the second one. Boom. Can you see that? Both the path now. It is giving me exact value now. Okay, the condition is matching. because it is giving me with 950, it is coming almost that close. दिख रहा है? तो यहाँ ये सेम हो गया. Okay, so it got, so you can check 950 here, you can put down 950. So, but you can see the condition matches, but still this is saying us 2 successor. Okay, so normally we should get, if we change this also, I think, if we change 950 Mbps on this link also, maybe at that time, okay, we 950. Okay, so we will change this side also to get the exact output maybe. Output मुझे ना exact चाहिए, so I need exact output. So bandwidth 950, sorry 950. Okay, so let's check if we are getting the exact output now. So yeah, it is still giving me successor value. Okay, but see, this is how it works. You can try it 930, 920, then it can give you the output. Okay, so I'm lowering the bandwidth so that we can understand the FD-AD value concept. So not every time EIGRP calculate the backup path. Remember this rule. Not every time EIGRP calculate. So let's try 920 something. 920 देके देखते हैं. So let's give 920 something. All links I'm giving 920 Mbps. It is still giving me, I think EIGRP has some problem that is called EIGRP cost reference. Just hold on. In real time, this is possible. Yes, of course. Why not? Okay, so if you want to calculate the exact path, you can use fast Ethernet and serial links also, if you want to check. Okay, so guys, let's take the questions now. It's been a long time now. So let me take your questions. So yeah, Hans, what's your doubt? Abhinte?
Yeah, thank you. First of all, I don't know how, because I'm not able to interact with you like others.
Actually, I was in session, so I have like unmuted people so that I do not listen the background noise. So
Yes,
whenever
then
you
how
have
I
a doubt, you can raise hand. Yeah, tell
Then
me.
I always raise my hand. I always go to reaction. Then I
okay.
click on raise hand. You don't. Then I go to chat. Sometimes
Okay, I maybe missed them. Maybe so you can ask now. Tell me.
Okay. Okay. Anyway, I was trying to ask you about the let's go back. Can we go back to
the topology?
The topology, yes.
Okay, just give me 1 minute. Yeah, here you go. Tell me.
Okay, so like the link from router. Okay, my first question was this. Let's say from router 2 to router 4, right?
Mm-hmm.
So it shows that the FD will be the same as the ROD.
Mm-hmm.
If we look at it, because the FD, because the FD will be the.
So you are saying
router
this
2?
value, and this value is same, right?
Yes.
Of course, because this is FD is the total distance from here to here, and this
Yes.
RD is from here to here. And if you check on
Okay.
this router, this value for this router, this value is FD. For this router, if we checking on R2, for this router, this value is RFD, right? But if we check on this router, this value will be RD. The total metric is FD and the neighbor to destination metric is called RD.
Correct.
So when we see from here, it is showing us the total metric till here is 131072. But if you check from this router 12.1.2, this is the IP we have. So if we check from here, the metric from here to here is 13080816, and the same thing router is showing, R2 is showing you the same thing, that my FD is this. Okay, so the my neighbor FD is this, so that will be my RD, because RD means neighbor metric, and here router is saying this is my 130816. So let's take let me give you one example. Okay, suppose you are booking a flight ticket for this destination. This is a destination. Okay, so when you take a flight from Delhi, okay, so if, this is a transit Dubai. Okay, so this is a transit. So this is Delhi, this is Dubai, and maybe this is your New York. Okay, so what we are getting, if we book a flight from Delhi, it is showing us the total cost from Delhi to New York is 131072 if we book flight directly from Delhi to New York.
Yes.
Okay, but when we book separately, we go by some different way to Dubai. But if we book the same ticket from Dubai to New York, the cost is 130186, right?
Yeah.
Right. So now if you reach on Dubai, or maybe your friend is taking the flight from Dubai, so he's also saying the same thing. Yes, the cost from Dubai is 130816.
Oh yeah. Okay. Yeah. Got you. I understand.
Got it now?
I understand. Yeah.
Thanks.
So okay.
Any other question? Okay. So yes, Arun, what's your doubt?
Hi, good evening, sir.
Good evening. Tell
Actually,
me.
yeah, the doubt is that actually we have taken a 10 the power of 7, okay, and the when we will divide into the bandwidth. So bandwidth we will use the lower bandwidth. Am I right?
Yes, lower minimum bandwidth,
Minimum.
bandwidth.
Yeah, that is my only concern. Thank you, sir.
Okay, so whenever you feel like your question is resolved, you can lower your hand. Yeah, Bikash Nerula.
Hi, sir.
Yes,
sir,
hi.
I have one doubt. Every companies are using EIGRP, sir?
Every company is using?
EIGRP, sir?
No. It totally depends. 80% of the companies are using OSPF, but 20% companies. So just understand where we use EIGRP. So do you know this? Okay, if you do not know, let me tell you. EIGRP was Cisco proprietary. Okay, now they have made it open standard, but up to like till 2013 approx, 13 I think. So it was only Cisco proprietary, means only Cisco devices support EIGRP. Even today is 2021. Okay, still most of the EIGRP is supported by Cisco only, because Cisco made this protocol. So if you want to run EIGRP, in short, you need which devices?
Cisco.
Okay, and many companies, they do not use all Cisco devices in industry. Many companies use Cisco, Juniper, Huawei, Nokia, Alcatel, right? So they use mix of devices. So this is why some companies do not able to run EIGRP, but very big brands, those, because Cisco is costly. Yes, everyone agree?
Yes, sir.
Like Cisco is most costly devices in the market right now because they have very good support. Cisco do not charge for their device. They actually charge for their services. Okay. Cisco itself says that we are not a hardware company. We are a software and technical support. We are charging for contracts. We are charging for support. Okay. So what I'm trying to say here, only big brands, most of the big brands, like I have seen EIGRP in Apple. Okay, almost their 40% of their branch offices are running EIGRP. I have seen EIGRP in I think Saudi Arabia Telecom somewhere. So the companies which actually do not use multi-vendor, if they can buy the Cisco devices, definitely EIGRP has a faster convergence. EIGRP is faster than OSPF. You can say that. You can make OSPF more faster by using some tricks, but still EIGRP is better because OSPF is a very big. OSPF uses a link state database. It store the complete information. OSPF में अगर 100 राउटर हैं एक ही एरिया में, suppose you have 100 routers within the one area, so each router will have information about all 100 routers. Okay, suppose you run OSPF in this area. Okay, so this router will have the complete information about this network, but EIGRP only knows about its neighbor. EIGRP को सिर्फ अपने नेबर के बारे में पता होता है. EIGRP knows only its directly connected neighbors. Okay, so EIGRP is a distance vector. This is dependent on neighbors. Distance vector protocols. Who is distance vector? EIGRP. Some you can say that RIP also, but they distance vector protocols like EIGRP, they are dependent on neighbors. Dependent on neighbors. Okay, they do not have the complete information. इनको पूरे नेटवर्क के बारे में नहीं पता. They are completely dependent on their neighbors. So whatever neighbor, see here my neighbor is telling me my FD is F13086. This is same I am getting from my neighbor, right? So we are dependent on neighbors. But in case of OSPF and all, these are link state protocol. They are not dependent. They have full picture of the topology. उनको सारा ज्ञान पहले से ही है. They already have all the information with them से. And this is the reason OSPF is highly CPU intensive. OSPF को ज़्यादा CPU चाहिए. OSPF needs more CPU, more RAM because it stores the complete database in the router. And whenever it process, whenever router get reset or if link is down, OSPF again runs the algorithm which is called SPF algorithm. We will learn these things in OSPF, but here in EIGRP, like they are only dependent on neighbors. Okay, they are only dependent on neighbors. So you can understand now. See, EIGRP is better protocol in somewhat reasons, but only reasons many companies are not using is because they can't afford Cisco everywhere. Clear now?
Yes. Thank you.
Yes, Vikas. Sorry, Vijay.
हेलो
Yeah,
या है सर. सर एक्चुअली मेरा जो क्वेरी था ये था कि एक्चुअली अगर अभी हमने जो ये टोपोलॉजी में देखा है कि 1 Mbps एंड 2 राउटर में 8 Mbps हमने यूज किया, राइट? अगर इन केस ऑफ हमने चारों राउटर में 1 Mbps यूज किया तो उसका RD वैल्यू सेम रहेगा या डिफरेंट होगा?
RD value, okay, got it. So see, if you use 1 GB, 2 GB, 1 GB, so if link is same, so obviously the RD value be different because FD is the total distance. Remember, I have given one example. This is the total cost. You can understand. We never use cost word in EIGRP. We call this metric. We call this feasible distance, but I'm just giving example. So this is the total cost. This is called FD, and the cost from here to here is called RD. Okay, even if you have a link 1 GB here or 1 Mbps, obviously with 1 MB link also, the total cost of this path is different, and the cost from this path to this path is different. Okay, you can calculate it by giving the bandwidth 1 Mbps and calculate it. Okay, kahan gaya Vijay? Okay, Vijay, clear? I think you joined with 2 names. I don't know why.
Yes sir, actually मेरा speaker नहीं चल रहा ना laptop में, इसके लिए
अच्छा अच्छा ठीक है okay. Yes, Puneet Singh.
Hi sir. So my question is sir, so जो ये R2 है router, so for the R2 the FD value is 130816. So what will be the RD path sir for R2?
RD is this one 128256. That because router is considering this loop back. Okay, so the loop back also as a different network. So you can see show IP EIGRP topology. So here we are getting some FD value. Can you see that?
Yes sir.
So from my router to my loop back, the FD is 1286. We do not have RD here, right? Because this network is directly connected to me. So this FD will become my RD for R2.
So if there any, so in that case, sir, if R4 has any kind of fast Ethernet port, so the RD value of the fast Ethernet, the value of the fast Ethernet port will become the RD of R2.
Yes, correct.
Okay,
correct. If you have a LAN network here, and whatever FD value we are getting for our LAN network, that will be RD for this.
Thank you, sir.
You can do the same topology by using a switch, guys, if anybody is confused. Okay.
Thank you, sir.
Welcome. Yes, Abhijit.
Sir, while calculating delay, we have to add the delay of all links, right? And what is that 5,000 in that?
I didn't get you.
While calculating delay, by using delay formula, we use delay that is 10 plus 10, right? And after that, you add 5,000 in that. So what is?
Yeah, that 5,000 is actually because as I told you, actually I think today I have done one mistake. I have taken loopback because many people are getting confused. See, loopback has their own properties, right? So if you check the loopback properties here, loopback is showing us 800 or 800 Gbps something speed, but this is not actual, right? But this is a virtual. And here also we are getting a lot of delay 5,000. So what I recommend, if you want to get the proper result, you can use a LAN network. You will not have 5,000 delay here. समझ रहे हो?
Yes, sir.
If you use a LAN network here, I can't use it. Okay, because in packet tracer, when you use this Apple MacBook, so in packet tracer, I don't know, like I'm not able to add the modules. Remember in CCNA we used to add the modules. है ना, तो यहाँ पे वो मॉड्यूल ऐड नहीं हो रहे हैं, कुछ प्रॉब्लम आ रहा है. सो दिस इज द रीजन. तो मैंने लूप बैक लिया है, नहीं तो मैं तुम्हें वही दिखा देता. ओके हरप्रीत, यस श्योर. टुमारो आई विल शेयर हरप्रीत. ठीक है, तो और किसी का डाउट है? सो एनीवन? सी नुसरत. हाय नुसरत, any doubt?
Sir, my question is little different than the EIGRP. If you want me to ask, I can ask. If not, then I can ask it later.
It's not related to EIGRP.
It is related to EIGRP, but I'm thinking if those 4 routers are at a different location, if we suppose those are like Delhi, Mumbai.
Yeah, we always suppose. It's not suppose. In actual, in real industry, these R1s, R1, R2, normally in companies, they are different locations only. Okay. So let me change the names. Okay, it was Dubai in my one example. So let's take this is New York. Okay, or maybe this is my Okay, so this is maybe Abu Dhabi. Yeah, tell me now.
यही मेरा दिमाग थोड़ा खराब हो रहा है. So this here, like, you know, usually we run like private addresses in our private in our internal network. And now we are connected to different location through ISP and MPLS, all those things.
Yeah, correct.
But like, how do we, like, you know, advertise our private network from branch to different branch, like one branch to another branch?
Okay. So it is very simple. If you understand very simple topics like GRE, okay, so or maybe IPsec. So first of all, you need to understand there are two types of WAN, right? This is you already know. I'm sure, right, Nusrat? I think आप unmute कर रहे हो तो मुझे unmute करना पड़ रहा है बार-बार. Clear? Hello.
जी सर. जी
Okay.
सर.
So see, एक चीज दिखाता हूं मैं तुम्हें. Okay, so let me add one picture. This is little old, but still it is going to help you. So we need to understand WAN, and WAN has many types, right? So first you see there are two types of WAN, which is private and public. So normally let's make it very simple. The internet is called public WAN, where we use broadband, where we use the leased lines and all these things. Okay. So and additionally, we have private connections. Like suppose you want to connect from Delhi to Dubai. Okay. So maybe you want to connect Delhi to Dubai. So you can contact any service provider for international connectivity and you will pay for the leased line. But this will be very costly, right? This will be very costly and maybe in sometimes it is not feasible also. You can connect between Delhi to Gurgaon, Delhi to Noida, because Delhi Gurgaon has around 50-kilometer distance, 100-kilometer distance. You can use your dedicated leased line connections. Okay. But most of the, because this is very costly, this dedicated means costly, right? This is a switched network where we used to, this is earlier days where we used to configure public switch telephone networks like landline phones, like AT&T phones, BSNL phones, integrated service digital network, but we do not use nowadays because the speed is very low. So we use packet switch network nowadays. So where we have technologies like Metro Ethernet, MPLS, frame relay is obsolete, ATM somewhere we use, but normally MPLS, Metro Ethernet, these services are in the market, so that ISP will give you create your connectivity from Delhi to maybe Dubai. Okay, so you can go to any service provider which provide global MPLS, okay, global MPLS providers, and you can connect to your locations. This will be like, let me show you one concept. Okay, so एक इमेज डाल रहा हूं तुम्हें यहाँ पे समझाने को. These all things are important, guys. We can't say this is not important. I'm sure some people will be going to crack interviews. Yeah. So can you see that this is MPLS? So maybe at headquarters you have taken fiber connection. Maybe at your regional office you have taken Ethernet cable. Maybe in data center you have taken Ethernet cable but over fiber, Ethernet over fiber, which is like fiber connectivity, but you are using Ethernet. Here you are using IPsec, which is VPN. Here you are using DSL, which is a broadband connection. Here you are using a T1 line. Okay, this is a dedicated line. You can use any type of connection, but what is happening, like ISP, everywhere you are using same ISP and it is connecting all your locations together. It is connecting your locations worldwide. Okay, so this is called MPLS network, where you can connect your multiple locations. Okay, so let me show you one more thing so that you can relate this. Okay, give me 1 minute. Okay, so this is leading ISP in India. Okay, so you can check your country ISP. So you can see Airtel Business. So you can see Conquer Africa with Airtel. Can you see that? Okay, so all the images you can see here. So they are already providing these type of connectivities, and I think this is for their Africa region, right? So you can check in the solutions Airtel Global Business, and you can connect to your multiple locations like global dedicated internet, global private line. Okay, so in the global private line, you can connect to your global locations also, but they are going to, suppose Airtel is not available in Dubai, suppose, okay, but you have asked for the quotation. So what they can do, suppose Airtel ISP is not available in Dubai, maybe they are available in Abu Dhabi. So what they can do, Airtel will give you the connection here, and here it will ask his partner, maybe AT&T's partner of Airtel, and they can connect the Airtel and AT&T together, because they have already, some ISPs are in collaborations. Okay, I have seen this, like AT&T in India is actually I think maintained by some another service, I think with Airtel and AT&T has a collaboration. So whenever you connect your US branch office with India, so you can't alone connect Airtel to New York. Somewhere you need different ISP like AT&T and Airtel. Okay, maybe here in India you are getting the connection from Airtel, but in USA you are getting the connection from AT&T, and they will do the configuration from their end, and you as a customer is paying to both the vendors, because you want connectivity. It does not matter. So when they have collaboration, then only we can do this. Okay, so you can check with the ISPs and just check. You can call them also, like I'm general manager or I'm just an engineer, I'm just checking if we can provide, I need to share that details with my manager. You just keep taking the details from the ISP, keep calling them. This is what I used to do. This is why I have that information with me. मैं तो घुमा देता था भैया कॉल, बताओ मुझे पैसे थोड़ी लग रहे हैं. It is nowadays it's unlimited calling. Keep doing calling. Just pretend you are a customer and you are looking for a solution. You want to connect to your USA branch. How cool. Right, got it now, Nusrat?
Yeah, okay, sir. So like internally we are running EIGRP, IGP protocols.
Internal you can run EIGRP, OSP, because we are connected, right?
Yeah, but like, so, in order to bring that network on the internet, we run like BGP again and redistribute EIGRP, right?
See, no. When you do MPLS, so I have to show you now MPLS configuration, which will be more complex. But if you have curiosity to understand this concept, I recommend you, like, please watch my GRE session. Let me send a link with you all.
No, I already watch your MPLS, like, MPLS, I know provider edge and provider like routers only run MPLS.
Have you done the configuration by yourself?
No. I just watch your video.
So you have to do the configuration, then only you will understand.
Okay.
Okay. Yes, Mohammad Ishaq. Ishaq, any doubts?
सर हाँ, गुड इवनिंग सर.
हाँ.
एक्चुअली सर वो मैं पूछना चाह रहा था कि जैसे कि OSPF में नेबर रिलेशनशिप में कीप लाइव मैसेजेस जाते हैं, ठीक है, तो EIGRP में भी, और EIGRP में कितने राउटर्स लिमिटेड मतलब कनेक्ट कर सकते हैं, मतलब 255?
We can go up to 255 routers, and we have not started packets right now. Like, we will learn tomorrow this. Hello, update, query, reply, acknowledgement.
Okay.
Yeah.
That's why I'm asking.
Thank you. Yes, Mr. Raju. Any doubt? Mahfouz, you need to raise hand, whatever you have doubt.
Yeah, sir.
Yes, Raju, tell me.
Sir, actually, my doubt is when we are in the working as a network industry, yeah, we are working on sir. Which VPN can use our district?
Sorry, I didn't get you, Raju. So can you be bit loud?
Sir, my doubt is when we are working from the home, sir.
Working from home, okay.
Yeah, actually working from means we can be directly connect to the what are the types of VPNs can be used by the industries? Sir?
Okay, so there are two types of VPNs normally in industry. Okay, so whenever we connect a head office with branch office, these are called site-to-site VPNs. Okay, this is called site-to-site VPN. There are many VPNs like GRE, like IPsec and all, right? So whenever we connect from our home office, okay, so that when you connect in the office, that is called remote site VPN. Remote site VPN, and there are some VPNs like L2TP, PPTP. So there are some, these are different VPNs, these are different VPNs. They are to connect the locations together, and this is to get the access from your home inside the office.
Okay.
Okay, yeah.
Yes. Yes, sir. Thanks.
You can just Google it, site-to-site VPN versus remote site. You will get some idea. Yes, Abu Saeed.
Hi, sir. So my question is that instead of MPLS, why don't we use just a IPsec tunnel between two sites?
Very good question. Every question is good now. Okay, because MPLS gives you reliability. When you have big applications and the data transfer is too much, you need reliable connectivity. You can't depend on internet, because when you use IPsec, it adds a lot of headers. Like IPsec adds a lot of information like encapsulation, security, payload. Then it adds another header which is called authentication header. Okay, then it adds encrypt the data. So whenever we send data with IPsec, it adds a lot more information which will waste bandwidth and which can actually reduce the connectivity, which will reduce the performance also. But when you use MPLS, you get a rocket machine. You just, whatever you pay for, you will get that speed. Okay, so MPLS is reliable. This is why people go for MPLS connectivity. Abu.
All right, thank you so much, sir. That's
okay, great.
Thank you.
Does remote site using client VPN? Yeah, client VPN is a software. Client VPNs are software like Cisco client VPN. So client VPN is, you can say that it is a software where you can connect a remote site. Okay, where you can connect a remote site. Yes, Anirudh, any doubt?
Yeah, sir. Yeah, actually, there's a doubt in one scenario. Like we have a data center in Bangalore. Suppose we have a data center in Bangalore, and there are some office sites in like Delhi, Kolkata, like that. So all the locations are connected through point-to-point link from Bangalore. So it is running with EIGRP. So if you see the neighbors in Bangalore router, you will see all the sites neighbors. And in the individual site, you will see that the Bangalore router as the neighbor IP. So in between there are ISP routers, right? So how it will, in the lab scenario, they are directly connected.
Means they are directly connected. Okay.
But in
so
real scenario, how it will be?
In real scenario, this is called VPLS. Okay. Or sometimes we call this L2 VPN also. Okay. So in whenever you take this type of connectivity, okay. So guys, I know many students are CCNA here. So this is a little advanced, but just understand. Okay, so whenever you use a VPLS or L2 VPN type of connectivity, so ISP will give you that technology where you will see the devices are in same network, which is also okay. Got it?
Yeah.
So whenever you use this type, so you can see 10, 12, 12, 1. This is 12, 12, 3. Can you see that?
Yeah.
But between this is a technology which we call VPLS, Virtual Private LAN Service, where router is going to create VRF tables, and with virtual circuit, it is going to connect multiple locations. And then as a customer, you will feel like you are actually connected with the customer.
Okay.
This will be purely like you are connecting the like dedicated link, but it is not dedicated link. Your traffic is going in a packet, okay, where the another router is also, means it is all encapsulation.
Okay, so EIGRP will detect the neighbor using CDP, right? So
EIGRP detect neighbor with
like with CDP protocol, right?
You can disable CDP and still EIGRP will come up, bro.
Okay.
Who told you? Or you studied somewhere?
Yeah, I heard some.
Okay, do it. Maybe I may be wrong. Just disable CDP and check.
Okay.
Okay, you can run no CDP run. Even this is new for me because normally we do not run EIGRP too much in companies. So you can give this no CDP run command.
Okay.
Okay, this is the command to disable CDP. So my neighbor is not going down. Okay, maybe I'm wrong also. Good question. So let me check. I never thought this. Yeah, so can you see that hold down is not decreasing? So CDP is not related to EIGRP. So hence proved, sir.
Okay, got it.
Okay, CDP is to detect the neighbor. I was literally just what we call. I was thinking I never got this type of question. Yeah, so CDP is not related to EIGRP. So your hello packet is there. Okay. So if we do not send hello to another router, they will not become neighbors. In EIGRP, all routers send hello to each other.
Okay. Yeah.
Okay.
Yeah. Thanks.
और किसी का डाउट रह गया है? महफूज, where are you? I can't see you. SD-WAN can be used instead of, see, SD-WAN is a different technology. SD-WAN still uses MPLS. Guys, I don't know, many people think that because I've seen somewhere from one training center, they are highlighting, okay, forget MPLS, learn SD-WAN. What is this? SD-WAN is a technology, but it is still working on MPLS and internet. SD-WAN is not actually eliminating MPLS. SD-WAN MPLS को खत्म नहीं कर रहा है, ये पता नहीं कौन गधा था. Okay, so you can see we can connect SD-WAN. SD-WAN is nothing. This is just a connectivity which can be operated from software, which is called vManager in Cisco Viptela. Okay, if you want to know about SD-WAN, you can just watch some SD-WAN videos in our YouTube. And if you feel like you want to join SD-WAN, you can join. So maybe we took a session this one, so you can check this link in free time. ठीक है, तो पहले ये पढ़ो तो थोड़ा आइडिया लगेगा. Okay, so any other question, guys, or we can close the class for today? Yeah, Shakil.
Hello, good evening, sir.
Yes.
Sir, question तो बहुत थे पर भूल गया.
लिख लिया करो ना. So if I am taking a lot of time to answer your questions, you can note down, and whenever I come to you, you can ask me that time.
सर और एक सर मेरे को ये बता दो सर, मैंने ना अपने लैपटॉप में 12 GB रैम कर दिया, तो उसमें EVNG फाइल कैसे डाउनलोड करना है?
ये मैं आपको सिखा दूंगा बहुत जल्दी.
Thank you, sir.
Okay, I'll explain you. So you can install EVNG. So like just 2-3 days back, I did a session. यहाँ तक कर लो, उसके बाद आगे का मैं बताऊंगा. Okay, the images and all. You just watch this video, live EVNG installation. Let me share link with you all. And the notes, everything will be updated into your portal.
Yes, sir. Thank you.
Ajay is asking, sir, which laptop is good for CCNP, Intel Core i7 or Ryzen 7? I love Ryzen. Okay, because it is little cheap and it gives better performance. So, but still, because you are going to do virtualization and all, so still I recommend Intel. I recommend Intel because virtualization में कुछ problem आता है AMD में. Great, Harpreet. See, you guys who will be joining with us, they will be getting the lab access. Okay, don't worry. You can do your labs in the server. आपके पास 4 GB के लैपटॉप भी हैं तो भी पूरा लैब कर पाओगे. No worries. Okay, you can still do these labs. Okay, like MPLS and all, OSPF and all. तो यहाँ पे बहुत सारे लैब हमने बना रखे हैं. You can see routing has a lot of labs. Can you see that? तो ये सारे labs आप यहाँ से देख के कर सकते हो. You just open the device and just do your configurations. Like there are many types of scenarios. So you can just modify your scenario and do the labs here. Means you, okay, so this is last thing for today. So guys, I hope you will be getting the lab access soon if you do not get it, or maybe you already got it. So just log in with your username and password. Okay, maybe you get different port number here. So once you log in the lab, so you can see multiple folders here. Okay, so like routing, switching and all, IPv6, automation, virtualization, some topics. Okay, suppose I'm doing a lab. Okay, maybe we can start with the, suppose this EIGRP route map. This is a very small lab with 3 routers. Okay, you can open this lab from here. Okay, so you can start the devices by going to more action. It is powered by EVNG only, but we have customized our EVNG. Okay, so you can see the devices are power on and it is showing us the colors. So it means they are on. Just click on the devices. Those who are very new here, so just click on the all devices and you will get all the console access. ठीक है, तो पूरा console access आ गया आपके पास. Okay, so you can just take out these tabs. आप यहाँ से tabs निकाल लो. So you can see here we got the lab now. Okay, so you can do your practical like this. So OSPF, okay. So I hope everyone have done OSPF in their CCNA. Okay, so OSPF, obviously, let me give you a basic overview. OSPF stands for Open Shortest Path First. Okay, and this protocol works on one algorithm which is called SPF algorithm. Okay, do you know, like there are many protocols what we have learned earlier, like RIP, or maybe you have learned EIGRP, or these are the main. So RIP works on Bellman-Ford algorithm. Bellman-Ford algorithm, and EIGRP works on Cisco dual algorithm. Okay, diffusing update algorithm. Just to add, because when you compare, you learn better. So this works on SPF, and this also known as the Dijkstra algorithm. So open shortest path first, and this protocol is known as link state protocol. What do you mean by link state protocol? So OSPF, when we are going to configure OSPF, so OSPF makes a database which is called link state database. OSPF makes 3 tables. That is, first is neighbor table, second is database table, and third is routing table. Okay, so this database table, like so in OSPF, whenever you connect 2 routers, they become neighbor to each other. Okay, when you connect these OSPF, so they are going to send one packet which is called hello. We will discuss about that also. So but OSPF makes one table which is called database, and it is also known as link state database. So if all 4 routers, they are going to make one table which is called LSDB, and in link state database, all the routers will have exact information, information. Okay, I'm considering all the 4 routers we are going to have in one area. Okay, so let me make it more simple. I'll not go deep dive right now because I'll consider you as a fresher also. So this is called link state protocol. We are going to store all the links. Means if one router is having 2 links, we are going to store both links information in the database table. If this router is connected, this is also having 2 links. So this router is going to add these 2 links. So in total, how many links we got? Almost. So this will be considered one link. This will be another. This will be another. So almost 3 links information will be stored into the link state database. Aman, I don't know why you are raising hand again and again and again. So I'll take your doubt. Okay, so don't worry. And you, Yeah. Okay, so we will discuss about all the links, how OSPF make database table and all. And this topic of what I am delivering now, it's according to the interviews also, not just with the knowledge. So OSPF is also known as classless, means it supports subnetting and all. So if any router has a LAN network with /27, so this router is going to update another router with /27 only. So this is what we call classless. So there are few classful protocols like RIP version 1. So if you send 27, another router will get 24 by default. Okay, in case if it is a class C. So classless means it supports the subnets. Okay, classless means it supports subnets. Additionally, OSPF in Cisco, the AD value for OSPF is 110. Correct? Yes, guys? Okay. So I'll not stick to only okay. So in if so the most popular after Cisco, there is one company, Juniper Networks, right? If you talk about Juniper, so OSPF internal route for OSPF is AD value. This is called route preference. This is 10. Okay. So in Juniper OSPF route preference value is 10. Okay. So if you try to configure OSPF in Juniper, OSPF routes will show you then 10 route preference number. So AD value is only in Cisco, not in other vendors. And there is a Huawei, Nokia, there are all other vendors. So they might have different values according to their routing table. But this, when we talk about AD value, this is only specific to Cisco. Okay, so like I have given you one very good example, like in Juniper, we have AD value. This is called route preference in Juniper. Okay. And if we talk about further OSPF information, so OSPF has a hello protocol. So OSPF send hello to all its neighbor, and the timer for hello is 10 seconds. And there is a timer which is called a dead timer in OSPF, that is 40 seconds. Okay. So if you configure router OSPF in this router and also in this router, so what happens, the router is going to send hello packet to this router, and this router is also going to send hello to this router. So it means once they send hello to each other, they become neighbors. Okay. So they become neighbors. And if you send hello, but if this router do not reply in 40 seconds, it means they will not form neighborship, or if they already have, they will close the neighborship. Okay. So router यहाँ से एक hello भेजता है, and this router has to reply in 40 seconds. ये 40 seconds में अगर reply नहीं करेगा, if this router will not send hello back in 40 seconds, we will consider this router, or they will not become neighbors, or if they already have, they will remove the neighborship. Clear? No. Okay, so let's go further. Okay, so now you know what is an OSPF has one concept which is called router ID. Okay, so OSPF, so I'll explain that also. So let's move further. Okay, so what is the OSPF protocol number? So OSPF works on one protocol number which works under directly IP. Okay, so OSPF works on IP protocol number 89. So just to make sure, EIGRP works on 88 and OSPF works on 89. Okay, so there is a big protocol IP, and under this IP we have many protocols like ICMP, TCP, UDP. Okay, and we have OSPF here also under direct IP, EIGRP also. So all they have protocol number, like ICMP has 1, TCP has a 6 number, UDP has 17, OSPF has 89, and the same EIGRP has 88. So you can note down this. It will be helpful for you. So these numbers are called protocol numbers. Guys, is my voice is cracking or like breaking? Okay, Shiv, I think you need to check your internet connection. Most of them are saying everything is okay. तो सभी को आ रहा है मेरा आवाज. Neeraj, you also need to check from your end because 95% are saying no. Means everything is okay. Viren, I have never seen this debate. Please share me the link if you have seen somewhere. Okay, OSPF supports equal cost load balance. So OSPF, whenever router wants to go somewhere, OSPF makes all their routing selection with the help of cost. So OSPF has a metric. OSPF has a metric which is known as cost. And how to get the cost? So there is a formula 10 to the power of 8 divided by bandwidth. Okay, suppose you have 100 Mbps connection. Okay, so you have 10 Mbps connection, and let's take you have 5 Mbps connection. So what will be the cost for these links? So in OSPF, whenever you calculate cost, OSPF has a metric which is called cost, and the formula is 10 to the power of 8 divided by bandwidth. Okay, so suppose if you want to get the cost of this, so you will write 1, 2, 3, 4, 5, 6, 7, 8. Okay, and for 100 Mbps, you will write in bytes. So 100 Mbps, so you will add 1000 and additional 30 as you have to mention in bytes. Okay, Viren, can we discuss this later on, or you can? Because it's too much big paragraphs you are sending, right? Okay, so remember, so you have 100 Mbps, so the cost will be 100 Mbps 3 zeros, and again 1 MB into bytes. Okay, 1 MB into bytes is almost 1000 kilobytes approx. So if you divide, you will get for 100 Mbps, the cost will be 1. If you calculate for 10 Mbps, you will remove 1 0 from here, and the answer would be the cost for a 10 Mbps link is obviously the cost will be cost for 10 Mbps cost will be 10, and if you calculate it for 5, so I think the cost will be approx 20. Okay, so this is how OSPF calculate the cost. And suppose if you have 100 further, so the cost is 1 here, and for again if this is 10, so the cost will be for 10 Mbps 10, and for 5 Mbps the cost will be 20. So if your destination is here, so which route the router will take? Tell me. A route, B route, or C route? Yes. Why it is C? OSPF always take the lowest cost. Highest cost nahi le raha hai. OSPF always take the lowest cost path. So we are going to follow one only two. We are getting only 2 cost from this path. But if you go from this side, you are getting cost 10 plus 10, 20. So tell me which is lower, 10, 2 or 20 or 40? Obviously 2. Okay. So the lowest cost is preferred in OSPF. Clear? So this is what we are going to see in the practical also. But as of now, I'm just giving you the basic overview how OSPF works. Clear? You guys need to write clear yes, anything in the chat so that I can go ahead. Okay, good. Okay, so if your links are almost similar, if your all the links are similar, what will happen? OSPF is going to load balance that. Okay, suppose your routers have similar path, like this is also 100 Mbps, this is also 100 Mbps, this is also 100 Mbps. So the cost for all the links is 111. So for destination, all the links A, B, C are giving you the same cost. So this is what we call equal cost load balancing. So this is what we call equal cost load balancing. And the router is going to load balance the traffic automatically. Okay. So means if you will send some packets, so router will send first packet from this side. Okay. And second packet from this side, third packet from this side. So it is going to use all three links. So this is what we call equal cost load balancing. So what is the maximum number of links you can use? So generally it is between 6 to 8, depends on the iOS number. So you can use up to 6, or sometimes like if it's a latest iOS or something, so it can go between 6 to 8 links in total. Okay. So how many links we can load balance? Up to 6 to 8. Okay. So guys, there is one, so I'll discuss about auto cost reference bandwidth. Okay, because nowadays every link is like 1 Gbps, 10 Gbps. But if you calculate the cost according to this, so you will not get that much value. Means for 1 GB, for 100 Mbps, you are getting cost 1. For 1 GB also you will get 1. For 10 Gbps, you will also get 1. If any cost, any speed, if it is more than 100 Mbps, OSPF will give you the same cost 111 always. So we need to fix this issue. There is a concept called auto cost reference. Okay, we will discuss in further classes. Okay, ठीक है. तो अगर आप 100 Mbps लोगे, 1 GB लोगे, 10 GB लोगे, सबका cost 1 ही आता है. So that is because OSPF is a very old protocol. Earlier days, like the formula was 100 Mbps divided by bandwidth, but nowadays 100 Mbps is very less. 1 GB, 10 GB is common in industry. Okay, so we'll discuss that. Yes, Shivinder. Okay, so remember guys, in OSPF, okay, so suppose these are 3 routers. Okay, let me ask you one interview question, because this is how you will get trained for. So tell me, if I run OSPF on R1 and OSPF on R3, can I make neighbor from R1 to R3? Normal, okay, don't try to check with the VPNs and all. Normal behavior I'm asking. Okay, so remember, OSPF packets are exchanged. OSPF packets are exchanged only between neighbors. Only between neighbors. Okay, so to make the OSPF neighbor, you should be in same network. Okay, normally if this is 1.1.1, this is 1.1.2, this is 2.1.1, and this is 2.1.2. So you can see these 2 routers are in different subnet. So there is very less chance to make them neighbors, because in OSPF, if you want to make neighbor, you should be in same network. Okay, so OSPF needs directly connected information, means OSPF packets are only exchanged between only neighbors, and we can't make neighbors which is little hop away. Okay, sir, I have one doubt after completing. Dilip, these things you can ask me in LinkedIn. Okay, so can you please make me focused in my class? Yeah, so in terms of BGP, this is possible. If you try to use BGP, some of you are not aware of BGP technology, but yes, in BGP we can make BGP neighbors. Okay, so we'll discuss these things, but if anybody is asking you, they are expecting you to answer BGP. Okay, but let's leave right now because you are not familiar with BGP, and we will discuss in BGP also. But yes, we can make neighbor between different subnet in BGP. Okay, border gateway protocol. Yeah. Okay, clear? Yes. So they should only exchange between directly connected. Okay, so tell me another interview question. So what will be the TTL value? What will be the TTL value? So OSPF uses multicast address. Everyone knows in CCNA, some of you have gone through. So there are two multicast address, 224.0.0.0.5 and there is 224.0.0.0.6. We will discuss why we have two multicast address, but this is multicast OSPF addresses, right? So what is multicast? Whenever I send hello, I will not send hello to 1.1.1.2. I will send hello to 224.0.0.5. Okay. So when I send hello to this address, so whenever we send a hello packet with the multicast address, so whenever OSPF sends multicast, it always have TTL value. What will be that value? Another interview question. What will be the TTL value for multicast packets in OSPF? Okay, some are saying 255, some are saying 1. Okay, so tell me, just use your brain. So I told you router makes neighbor with directly connected. So now understand, if router makes neighborship with the directly connected, what should be the TTL value now? Ankit Gupta, I'm asking TTL value, not dead timer. TTL value is in numbers between 1 to 255. So either it is 1, either 255 or any number. No. So OSPF has a TTL value 1. So please guys, make sure you understand this. So whenever OSPF send any multicast packet, it uses a TTL value of 1. Okay. Ranjit, that static 1 or you are talking about static route or what? That is AD value, bro. TTL, what is TTL value? अब मुझे ये भी बताना पड़ेगा तुम्हें. What is TTL value? So TTL value is time to live. Okay. So why we have TTL value? So generally TTL value is in IP packets. Okay. Whatever technology works on IP, they have TTL value. Normally you will not see in Ethernet frames, in layer 2 packets or layer 2 frames, you will not see TTL value. You will never see TTL value. And why we use TTL value? To avoid the loops. How we avoid loops? Oh. Okay, so suppose if somebody asks you what is TTL value, normally what you guys will say, please put down in the chat. If anybody will ask you why we use TTL value, what you will say? To avoid loopback in L3? What do you mean by loopback, Deep? To check if a host is alive in the network, how long the packet can travel. Yes, Anuj is correct. Very good, Anuj. So suppose this is your laptop, guys. Okay, whenever you send any packet to google.com, so whenever you send any traffic, also if it is a web traffic, if you do ping anything, so there is a router, and further in ISP networks you also have routers, and on the internet also there are many routers. Correct? Yes or no? So internet is nothing, network of networks, and you may have like thousands of millions of routers, not millions, basically thousands of routers. So there are so many networks or routers in your network or on internet, right? So you suppose you want to go google.com and by mistake you type some different IP. Okay, suppose you want to go to one IP address which is not available in internet. Suppose you try to ping to 73.1.1.1. So if this server is not available on internet, what will happen? Router will keep searching where is the packet, right? So this TTL value actually gives some it's like expiry date. Okay, so if I send ping 73.1 with the TTL value 64, so routers will forward the packet till 64 routers, because whenever you send packet, the router decrements value by 1. So the first 63, if you forward further 62, 61, 60, 59, and then reach. So now you can see we can reach to google.com. But if you try to ping any wrong IP which is not in our network, so we have expiry date of this packet. So once the routers keep searching for this information, if it is not available on internet, once the TTL value 0, because one day this value will be like obviously 0, and once our TTL value becomes 0, the packet will be discarded. Okay, so TTL value is to avoid the loops. तो अगर ये TTL value नहीं होगी ना, तो पूरे इंटरनेट में loops हो जाएंगे. So in every packet, whenever you send outside from your network, any IP packet has a TTL value, so that you will not have loop in internet or in your IP networks. Okay, so this is why in Ethernet, let's talk about Ethernet, normal Ethernet. So when we connect switches, okay, when we connect switches, so what happens? Whenever you send any L3 packet, this layer 2 device will only understand a layer 2 frame. So it will broadcast, okay, and whenever it sends information, so frame does not have TTL value. Frame does not have TTL value. Frame जो होते हैं ना, उसमें TTL value नहीं होता है. So this is why the packet is keep rotating and rotating, and this is why spanning tree protocol developed. समझ रहे हो? Because we don't have TTL value in Ethernet frame, this is why spanning tree protocol discovered. Clear? समझ आ रहा है? Yes, everyone. Now you got it? Why we only have TTL in IP packet, not in Ethernet frame? And what is solution for spanning tree protocol? What solution, Rajesh? Spanning tree is a by default protocol which is running in devices. It will block one port. If you have multiple links, it will block one port. Because loop only happens when you have multiple links, right? Yeah, for layer 2 loops, Anuj. Yeah, Manoj, spanning tree protocol is auto enable on Cisco devices. Mostly all devices. Only transfer maximum router 2.5. Yeah, Parth, correct. So yeah, guys, so OSPF makes how many tables? So OSPF makes 3 tables. Okay, the first one I told you, it's a neighbor table. Okay, where all the directly connected information will be stored. All the directly connected router information. Directly connected router information will be stored into this table. Okay, so let's take an example. If R1 send a hello to connect to R2 and R2 also, so they become neighbor. So what will happen? So once they become neighbor, okay, then they are going to share. Suppose R1 has a 10 networks information, they have LAN networks. Okay, R2 has many networks. Okay, so R2 have maybe 20 networks. So they are going to, R1 is going to share the 10 networks to R2, and R2 is going to share his 20 networks to R1. So all the links, all the information will be stored into the database table. So database table will consist of, it's a full picture of the topology. So I'll say in a simple language, full picture of the topology. So let's take an example like Google Map. Suppose you want to go from one source to one destination. So Google Map always give you the best path. Okay, maybe you have multiple paths, but Google Map will give you the one particular shortest or one best path. So the same way, OSPF knows all the information about the connectivity. So if you have only one route, two routers information. So if you have many routers in OSPF, okay, OSPF knows there is A path and there is B path, okay, to reach the destination. So A and path, both links will be stored into the database table. And whatever best route. So suppose if A has a cost of 2 and B has a cost of 20, so which has the lowest cost? A path. So the best path will be stored into the routing table. So please always remember, routing table always have best paths. Or routing table always have best path. We will not store all the paths in the routing table. तो हमारे पास सारे path नहीं होते हैं. If router has multiple ways, maybe it has 4 paths, 5 paths, 10 paths. So only the best path will go to the routing table. So it is a step-by-step procedure. Neighbor table, we will make the neighbor first. Then neighbors will send the links to each other. We will store in the database. And from those database table, we will select the best path. Okay. So all 3 tables are interlinked with each other. They are not separate. So once we became the neighbor, once we make the neighbors share their information and we will store in the database table. So once database table is created, the SPF algorithm, I told you which algorithm OSPF runs, SPF algorithm, and SPF algorithm selects the best path in the routing table. Okay, I'll show you something. Okay, so I'll show you some PPT. I usually don't. Okay, so see this PPT. Yeah, so I hope everyone can see this. Okay, so please check this. So this is a topology. This is what we call topology, right? So this is a router 1. Oh shit, just hold on. I need to have small screen, then only I can write. ठीक है, तो मैं इतना बड़ा screen कर देता हूँ. Just hold on. Yeah, I hope it is visible. Please confirm. Okay, thanks. Yeah, so now you guys can see R1, R2, R3, R4. Right. So all the links are here. So once R1 is going to check the routing table, the database table. So all the OSPF router, consider them, they are like the root of, or they are the top of the tree. So SPF is an algorithm which works like a tree. So if R1 will check its routing table, R1 will see that R1 is on top of the tree and R2, R3, R4, all are their branches. So this is why router selects the path. Okay, this path is 20. R1 to R3, we have cost 20. Okay, so this is what we call shortest path tree. Shortest path tree. So whenever, so which protocol we use is SPF algorithm. So this SPF algorithm makes shortest path tree, and all the routers is going to make the trees. Like R1 is going to make. Now if we check about R4, just hold on guys. Yeah, so if we check the R4 router, yeah, so if we check about from the R1, R4 is also considering that R4 is the top of the tree. It's like a root of the tree. Okay, it's always that root top of the tree, and R4 is saying, okay, if I want to go R1, I'll choose this path. And R1 is saying, if I want to go to R4, I'll choose this path. Okay, so this is what we call shortest path tree. So whenever we make OSPF topology, all the OSPF routers runs SPF algorithm, and SPF algorithm makes shortest path tree, and from that tree router OSPF protocol makes decisions. I hope it is more clear to you. और कुछ लोगों के लिए तो पहली बार था शायद. अच्छा ऐसा भी था क्या कुछ? So now let's discuss about OSPF areas. Okay, so the first question everyone knows, okay, there is a OSPF area and then we need to connect all the OSPF areas with this area 0. Everyone knows this, right? But why we have OSPF area? There are many questions which you will be asked in interviews. Okay, that why we have areas in OSPF. Mostly my students can definitely they can answer, and mostly if they are any one who are good in OSPF. Okay, so now you can see these routers are in my OSPF area 0, and these router may be in area 5, area 6, area 7. Okay, so if you want to connect area 5 to area 6, then it is mandatory to have area 0. Everyone have heard this. ये बहुत बार सुना होगा आपने. So it's like you have heard this many times. In OSPF, area 0 is mandatory, right? This is the first term you may have heard, and another term you may have heard is that all areas should connect to 0. सभी को सुना है ना ये? Yes. Okay, so there is another thing. One interface can belong to only one area. So please, you can note down this also. All n interface, कोई भी एक interface जो होता है, if any interface, suppose this router has one interface, one cable or interface port, whatever you want to say. So this is interface. So this interface is going towards this router. So I can add this interface in only one area. I can't add one interface in different areas. So an interface can belong to one area. Okay, maybe this is again. Okay, so koi bhi ek interface, all the interfaces are in, like you can have, or like if this router, if has, you can put this area 1. So this area, maybe you will add in area 0. Okay, so you can add your interfaces in different areas, but you can't add this interfaces in area 1 with area 2. So एक ही interface को, if it is FA00, you can only add either in 1 or either in 2. So you can't add in 2 areas. And some of you are confused, sir, how to add interface in area. Okay, don't worry. Just to inform you all, whenever you give the network command, okay, so you do not send any routes basically. So in CCNA, might be you have heard this. Whenever we give router OSPF to, then after that you give the network command, most of you all think that we are actually sending our network information to other routers. Okay, that we are advertising. So in general, when we give network commands, it activates that protocol on that interface. So we will discuss this thing. So as of now, just hold on. So we will discuss this later on. तो थोड़ा रुको अभी इसको, ठीक है? So we are discussing areas. So let's stick to this only. So as you all know, OSPF is a very big protocol. Like you can have unlimited hops, means you can add as many routers you want. तो आप अनलिमिटेड राउटर भी लगा सकते हो इसमें. But what happens if you do not have areas? So I'm covering your interview question that why we have areas. Okay, so to understand why we have areas, let's consider all the routers are in one area. तो एरिया क्यों बनाए जाते हैं आपको उससे समझने से पहले आप समझो. Okay, so why we have areas? So consider all these routers are in one area. If we will consider these routers are in one area, what will happen? So as OSPF area grows in size, when the OSPF network increases or area grows in size, when area grows, what will happen? The network links will grow, right? You will have lot of network links. You have more number of routers. Your number of routers will increase, obviously. This is obviously right. अगर आपका नेटवर्क बड़ा हो रहा है तो उसमें राउटर और उसके लिंक भी बढ़ रहे हैं. So if you increase the area, obviously the routers, the links are increasing, correct? So what will happen? What are the issues we are going to face then? So just understand, whenever if one link is flap, there are n number of reasons why link flaps. Maybe due to less Ethernet cable is not correct, or maybe fiber cable have problem, or maybe anything. Okay, so flap has many reasons. Okay, so if link flaps, do you know what will happen? Do you want to know? Say yes in the chat. Do you want what will happen if one link will flap? What will happen? Update to all routers. LSU is triggered. Database sync, collision, flooding. There are many messages I am getting right now. So in short, the first thing will happen is whenever anything change, we are going to do the again SPT. What we discussed, spanning tree calculation again. तो जब भी कुछ ऐसा होगा, whenever anything happens, the SPT calculation runs whenever a link flaps within the area. And due to this, what will happen? The link state database will increase. Obviously, let me write here. The link state database size will increase. Link state database, LSDB, means if you have many number of routers, many number of links, then LSDB LSDB table will also increase and becomes unmanageable, correct? Because it will be too big to manage. And when the link state database increases, there is another problem that consumes more memory, correct? So consumes more memory. And if it is consuming more memory, what will happen? There is a delay in SPF computation. What will happen? There is an algorithm SPF. I told you SPT calculation will have issues, right? SPT calculation will happen whenever there is a flap, and whenever SPT calculation will happen, the routers are going to consume their memory, correct? Yes or no? And whenever it is going to consume more memory, SPF computation, yani SPF algorithm will again calculate and calculate again and again. Yeah, Hassan, you can ask in chat. As of now, it's like webinar. So this is why I can't unmute, but from tomorrow, definitely. Okay, so this is the problem. Like whenever consumes more memory, SPF algorithm will run again and again, obviously, and then it is going to be what we call LSA flooding. What is LSA? So whenever any problem happens in your network, routers are going to send one message which is called LSA. Consider this. If you do not understand what LSA is, consider whenever anything happens wrong, routers are going to send update to all the neighbors. And what will happen? All their respective neighbors, they are going to send update to all their neighbors. Their neighbors will send update to all their neighbors. And what will happen in short while, like you will have a big LSA flooding in your network. So this will cause more CPU resources, SPF will have issues, the tree will take time, and then your network becomes unmanageable. And it is very like you will be getting too much flaps, or maybe the routers will not actually work. So there could be n number of problems you will have. Ehsan, I am not teaching ISP connectivity right now. I am teaching OSPF here. ISP का तो मैंने बात ही नहीं की है अभी. So these are the issues. Let me repeat again. So if you do not have areas, what will happen? Like area grows, network links will grow, number of routers will increase, and link state database will increase. And with this problem, like the routers are going to consume more memory, and it is going to affect your SPF algorithm calculations also. Okay, and it becomes unmanageable. Okay, so what would be the solution, guys? Tell me. So there are so much problems if you do not have areas. What is the one solution? Yes. So we need to have proper areas. So if we divide this network into areas, okay. Okay, so if we are going to have areas, how to write? Just hold on. So we can have areas, or let me write again on another screen, guys. It will be more clear. Okay, so if we have areas, like few routers are in this area. Yes. How to manage in EIGRP without area? We will discuss this, okay? In EIGRP do not do SPF calculations and all. EIGRP works on feasible distance, advertised distance. That is a completely different thing. Okay, we do not ask neighbors again. And so that is basically query and reply, EIGRP stub. There are other things in EIGRP. It's a completely different protocol. It's not like OSPF. Yes, hello everyone. Okay, so when we have areas, what will happen if there is a flap or anything happens in one area, it will only be in your area. We will not send LSA flooding, or there will be no LSA flooding whenever it happens. Okay, we can have area 0 in between also. Okay, so if you do not want, so let me add. Okay, so this is area 0. And you can have around 100 routers in one area, but according to Cisco blogs, if you read, or Cisco books, so Cisco recommends we can have around 40 to 50 routers in one area. Okay, but usually we have seen there are 100 plus routers in one area. It totally depends on your design. Okay, but normally we can have a limit. Okay, and you can connect one link or either two links to one area to another, because if one link goes down, your area will not be separated. If both the links will be down, so this is what we call in OSP partitioned area. So it is not going to use, and we can't use the things which are related to area 0 or something. Okay. So in short, if we have OSPF area, so you will reduce the LSA flooding. We can't eliminate the LSA flooding because obviously we need to update all the routers. So it will reduce LSA flooding. Means if you have any problem, you will only update to your neighbors. Okay, OSPF neighbor. We will not flood to different area. And due to this OSPF, we are going to manage the OSPF properly. Clear? Yeah, so yes, reduce LSA flooding. Another is like a reduce resource utilization. Yes. Resource utilization. Like if you have areas, your routers will not have too much CPU, or you will not have like high memory and all. So why we have OSPF 0? Why we need area 0? Okay. So why we need area 0? See, if a router, if this router, when we add this interface in area 1, okay, suppose this is going inside area 1 routers. Okay, let's consider there are many routers and it's coming, it's this interface going in area 1 and this interface may be going in area 0. So whenever you have any router with multi areas, what we call this router? Area border router. In OSPF, we will call this area border router. Not ASBR, Manoj, it's ABR, area border router. ABR stands for area border router. Correct? So when we have OSPF, these routers are in area 1 and area 0. So this ABR, whenever we have any interface in area 0, then only we will have ABR. If you do not have area 1, or suppose you have area 2 here, so in OSPF, according to OSPF design, this is not ABR. Okay. If you have area 1, area 2 this side, so this router will not be ABR anymore. So according to OSPF design, when we have any single area, whenever we have any interface in area 0, so our router becomes ABR. And when we have ABR, then only we can share routes from one router to another area. Okay, if you do not have ABR, you can't send area 1 routes to different area routers. Got it? So if you want to send routes from area 1 to area 0 or maybe any different area, so you can only send routes from area 1 to different area or area 0 if you have ABR. If you do not have ABR, the router is not going to forward the information, because only the ABR router send one special type of message which is called LSA3. We will discuss this later on. Okay, this is a special type of message or update that one area routes will go to another area routes with the help of LSA3, and ABR is responsible for LSA3. So tell me, if we have area, we do not have area 0, we have area 2 here, what will happen? The router will not become ABR, and if the router will not become ABR, it will not generate LSA3. And if you see, if you do not generate LSA3, you can't send routes from one area to another area. Clear now? Yes, everyone? Yes, Manthan. So in short, if you want to have a proper connectivity, then area 0 is better to have, because once you make area 0 in your network, when you introduce area 0 in your network, the router becomes ABR. If you do not have ABRs in your network, then there is a problem in sharing the information. Okay, so there is a concept called virtual link. So if you are an advanced learner, maybe some of you are not agree with me, that you might be thinking there is a concept called virtual link, right? Suppose this is area 0 here. Okay, so guys, I am just giving you overview. There is a exception which is called virtual link. Okay, suppose these router in area 1. Okay, this router in area 2. So tell me if we can, so these routes we can share from area 1 to area 2. So can we share from area 1 to area 2? Area 0 in different direction. So let's talk about this area only. So can we send routes from area 1 to area 2? अरे नहीं कर सकते ना. You need to, so there is a concept called virtual link. We are going to learn this, but even virtual link is also in area 0. Okay, what happens, this is a special concept where what we are going to do, we are going to make one virtual link between these two routers, and this virtual link is nothing. Virtual link is basically to get the area 0. So virtual link, whenever you create a virtual link by default, you actually get from this router, because this router has area 0 in this interface. So you connect a virtual link and you put this area. By default, this link is in area 0. So tell me if this router got area 0 link. So tell me now router become what? Yes, the router becomes ABR. And once the router becomes ABR, tell me, can we share the routes from area 1 to area 2 now? Got the concept of virtual link? So we are going to learn this. We are going to configure the virtual links. Okay, but virtual link concept is also the same. We are taking area 0. Without area 0, you can't make ABR. Even virtual links are in area 0. Yes, only ABR router can share one routes to one area to another route area. Viren, I don't think so. You can try. Okay, GRE is basically, there is a concept GRE that is basically a VPN. We generally use for when we want to connect our head office with branch. You can't add anything in OSPF to just make tricks, okay, or to play with the tricks. In between, we create area 0. No, you can't create many area 0s. Okay, so there is a concept, guys, also. Okay, so we will discuss this. That is called area 0 virtual link. So normally, okay, suppose this is the concept. This whole network is area 1. Okay, now you see here we have area 0 and here we also have area 0. So what we are going to do, so now this is called OSPF area 0 partitioned area, or you can call this. So you can see you have two area 0, and this problem also resolved from one concept, which is again virtual link. But this time we are going to create a virtual link from this router to this router. So what will happen when we add a virtual link between these two routers? So this area is connected with this area. Isn't it cool? Got it? So this is called virtual link for area 0. This is also a concept in OSPF. This is called area 0 virtual link. So there are two ways, like if you want to connect different areas and all. So ये भी हम पढ़ेंगे. So we are going to discuss this thing also. You can have as many hops, I think. Viren. Rajesh, this is a part of OSPF BGP MPLS. Okay, it means you are learning up to CCNP or more knowledge. Okay, so I'm not delivering only NP knowledge. So some topics are even more than CCNP. So to join this batch OSPF BGP MPLS, at least I recommend you should have CCN knowledge. Okay. Even if you have not learned anything in CCNA, still you can join. But yes, you need to revise some concept of CCNA. Guys, area 0 is also known as what? Obviously, area 0 is known as backbone. It is called backbone. Okay. And let's talk about the network. So after that, I'll give you 10 minutes break. So this is area 0 and you have many routers. Let's consider 4 routers. Okay. And I'll put these routers on the border. Okay. So these routers are on. Okay. So this is area 0. This is area 0. Okay. And you have few routers here. And this is connected to this router. And this is called like area 5. And you may have a few routers here. This is another area. And let's connect this also. This is area 7. So obviously this network will work from area 5 to 7 because between this area 0 is coming. But these routers are called internal routers. So there are few routers in OSP, internal routers. If any router is member of one area, so this concept is called one area, member of one area, right? So this is, guys, the first free session. Obviously, after this, we are going to deliver almost OSP BGP MPLS is around 30 to 35 hours. Okay. So obviously, this is the first free session only. And after that, you guys need to enroll because this course comes with the lab access also. Okay. It is not just training. You'll be getting lab access as well. We will discuss about the course curriculum and all. Okay. But as of now, let's focus here. So internal routers. So internal routers is member of one area. And these routers, which are, you can see this link and this link, both links are in area 0. So this is called backbone router. So when member of area 0 links, but these links, you can see this is 0, this is 5. So this is called ABR, area border router, which is member of multiple areas. Member of multiple areas. Member of area 0. Okay, let's repeat again. Internal routers are those routers which are part of one area only. Okay, nobody will ask you, I hope this in interview, but if you try to give any CCNP exam, definitely it may have, okay, or maybe in CCNA also. So internal routers is nothing. Member of one area is called internal router. And when the routers complete all interface in area 0, so that is backbone router. And when any router is having multiple areas with area 0, you can see this is area 5, this is 0, and this router is also in 0 and 7. So this is also ABR. And all these three routers are which routers, guys? Internal routers. Okay, so there is a special router in OSPF. Like if you try to connect sometime my pen got stuck. Yeah. So I was saying when any router, suppose in both the routers I'm running EIGRP. Okay, so now you can see this router is having EIGRP on this interface, and on these interface you have OSPF. Here OSPF, here also OSPF, OSPF. So even if it is a single interface in different routing protocol, this is what we call ASBR. So any router which is member of multiple routing protocols, so that is called ASBR, Autonomous System Boundary Router. Okay, the autonomous system boundary router. Okay, if you know about what is redistribution, if you do redistribution in OSPF, that also considered as ASBR. तो अगर आपने रिडिस्ट्रीब्यूशन पढ़ा है, अगर आप उसमें रिडिस्ट्रीब्यूशन भी कर दोगे तो भी वो राउटर ASBR बन जाता है. So if you are new to this concept about ASBR, it's very simple. If you run any protocol, like if you run RIP here, so which router will be ASBR? This router, because it is also having OSPF in this direction. So this router will not become ASBR because it is only running RIP. So, but when any router is running different protocol, that is called ASBR. ASBR can be internal router too. See, that internal router will become ASBR, na? Yes, wherein any router out of these routers can be ASBR. It's not mandatory that you should have ASBR in area 0. Any router in OSPF can become ASBR. Except a stub, so that we will discuss. Yeah, so let's discuss about OSPF packets. Okay, so before going for the packets, so let me show you something, a basic lab, okay? So that you will understand about basic configuration of OSPF. Okay, so guys, this is the lab I've created. Obviously, we are going to add few more devices in it, but this is like a first introduction topology for you all. So you can see, like I have created one area 1 on the top. So with 3 routers in it. Okay, so this top layer, this is area 1. So in between you have 4 routers in area 0. Okay, and we have area 2 also. So with 3 routers almost approx, yeah, 2 routers, and there is a service provider network, okay, with 4 routers. So this is a normal topology. We are going to create the normal to advanced things also, okay? But as of now, so we want to configure OSPF. So let me take this subnet, okay? So I'm going to configure OSPF in this network, okay? So you can see R4, R5, and R6. Okay, so let me turn on the devices. So those who will be joining for this session, so they will get the lab access and they can run these labs in our systems. I'll give you overview also about that. So let me click on R5. So just hold on. I need to. So guys, maybe you also feel. Just hold on. Let me show you from the basic. So once you'll be getting the lab access, you need to log in your portal. Okay. And after that, there are many labs here. You can see. So we have created for CCNP and OSPF BGP MPLS batch. So you can see OSPF multi-area. Okay, so I think this is the lab we created. Yeah, so this is the lab. So let me enable the devices R4, right click start. Very simple. And let me connect the labs. Okay, so this is R4. And the lab experience will be very fast. If you try to install the devices in your lab computer, it will be a little slow because of these are with SSD drives. If you have SSD drive, definitely the process will be little better. But normally the bigger labs need high RAM also. So you can see R1, R4, R5, R6. So what is the topology? So these three routers I'm going to configure. So you can see R4, R5, R6. Yeah. Okay. So these are the routers R4, R5, and R6. Okay. Yes, Kalyan. So can you see my console, or I need to increase the font size? Please confirm. All good, or you want me to increase the size? Okay, so let me increase. $120 is better. Okay, so that now it's visible. Okay, good. Thanks. But okay, so those who are new to this OSPF, still they will understand also. Okay, so now you can see R4, and this R4, if you try to go to enable, okay, obviously, and you can give the name host name R4, and I'm going to give IP FA1/0, and which subnet we are going to use 192.168.45. Okay, so IP address 192.168.45. So this is the router 4. I will give .4. Okay, this is the nomenclature I follow. तो आप ये router 4 को .4 IP दे सकते हो. No shutdown, obviously. And let's go to R5. Interface FA00. IP address 192.168.45.5. Okay, let's go to R6. Host name R6. Interface FA00. IP address 192.168.45.6. Okay, very simple configuration. I hope everyone knows this, right? But how to configure OSPF? So there are multiple ways. Okay, if you go to router OSPF, so this is a number which called process ID. So what is process ID? So process ID means whenever you configure OSPF in your router runs a separate application, or not application, runs a separate task which has a process ID. So if you try to see your computer also with the task manager, okay, so let me show you. I'm using this. How to check? Just hold on. What we call this activity monitor. So you can check in Windows, it is known as End Task Manager. So if you go to your memory or any CPU, so you will see for every task you have a process ID. Okay, you can see this PID means process ID. For all applications, there is a separate PID. Okay, So it means whenever I turn on this router OSPF1, what will happen? My router is starting a separate process. How to check? How to check if any process is going on? So you can close this, you can run show processes CPU, okay, and just use this pipe include OSPF. So you can see there are two OSPF process which is running under show process CPU. So if you try to capture show process CPU, so you will see a lot many big list, all processes in OSPF in this router is having a process ID. So in short, whenever I check the process OSPF, it is giving me one number that my process ID is 169192. But this OSPF one is for your reference. But for a router, this could be any number. Okay, I hope it is clear to you all. Even in CCNA or any certification, you got confused about process ID. Clear? Okay. So now let's go to router OSPF 1. So the best command I would say for OSPF is this command, show IP OSPF interface brief. Please note down this command. Okay, so this command is going to help you a lot. This is my favorite OSPF command. It will give you all instructions of OSPF. So on 3 routers, I'm going to configure OSPF in 3 ways. Okay, so there are 3 methods to configure OSPF. You want me to teach only network command or you want to see all 3 methods? Okay, good. So let's start from OSPF. What normally you guys have seen, most of you have configured OSPF with this method, router OSPF 1, and then you give network command with 192.168.45.0, and then you give the opposite of subnet mask, which is called wildcard mask, right? So I hope everyone knows how to get the wildcard mask. It is very simple. If your subnet mask is 255.0.0.0, it will be opposite of subnet mask. Okay, very simple. If you have 255, make it 0, and where you have 0, make it 255. Opposite of subnet mask is called wildcard mask. Okay, but if you have any number which is like 255.128.0.0, what will be the wildcard mask? So you can just minus from all 255. You will get your wildcard mask. Okay, what will be the value? 0.127.255.255. So this will be the wildcard mask for 255.128.0. Okay, so tell me what will be the wildcard mask for /27. What will be the wildcard mask for this 255.255.224? So the wildcard mask for this will be, you can minus from 255, it will be 0.0.0.31. Yes, very good. So I hope now you got the point. Okay, so what we have to do now, so we need to configure OSPF. Okay, so we under router OSPF 1. So whenever we give this command, so router displays you config.router. It means you are in routing protocol mode. Okay, router OSPF 1, and then you give network 192.168.45.0.0.0.255 because this is class C, and you have to use this. And area, this is area 2, so I'll say area 2. So what will happen when you give this command, this router activates OSPF in it. So you can see show IP OSPF interface brief. So this command is telling you that I have activated OSPF on FA1/0. Even I have not given the interface name, router is picking up the interface name automatically by checking which interface has 192 IP, and router knows 192 IP, this 192.168.45 IP belongs to FA1/0, and this interface is activated with area 2. Can you see that? right? So this is one normal mode. Let's go to router 5. Okay, so under router OSPF 1, instead of giving network 192.168.45.0, I'll be very specific. What is my IP? 45.5. So 45.5, and I'll put wildcard mask 0000. So this is called specific network advertise. You will advertise only the interface, not the network. Okay, and put an area too. And what will happen? If you check show IP OSPF interface brief, it is giving you the same information what I got in R4. Only the difference is, like, you give the full network in the first router, and in router 5 you are giving the exact IP address with the exact wildcard mask 000. This is what we call exact interface advertise. Okay, please change the host name. Okay, sorry for that. So host name R5. Okay, so now you see on R4 what I have given. I have given the full network with 45.0.0.0. So whenever you give network command, guys, router activates the protocol on interface. Clear? Very simple thing. Whenever you give any network command, even if it is 44.5.0, even it is 45.45 direct, so both the things are going to both are actually activating OSPF on the interface. So means both commands are doing same work. दोनों कमांड एक जैसे ही काम कर रही हैं. There is no difference. Only difference in R4, you are completely advertising your network. But in R5, you are actually only advertising your correct information, because you need to activate the OSPF on this interface. Why you are giving the full network information, right? And the third, my best one, and every industry uses this technique, which is called direct OSPF interface mode. So this is my favorite, router OSPF 1. You just configure OSPF 1, exit, and go to the interface and just type IP OSPF 1 area 2. That's it. This command also is going to give you the same output. You can see all three things are giving you the same output. It means all three things are activating OSPF on interface. So this is the interview question. Whenever you give the network command, whenever you give the interface command, what is the difference? So there is no difference. Both the commands activate OSPF on the interface. All commands in OSPF, whenever we give network command, interface command, anything, OSPF activates on interface. Please remember this. We never advertise anything. We actually activate the OSPF on that particular interface, and any network router 4 is going to advertise by default, because OSPF this link or any link. So it means I activate the OSPF on this link and please advertise. Clear? If you learned something new today, I want you to write wow in the chat. Great. So this is only just to give me boost up. Okay, it's not for you. This is for me. Okay, thanks. Thanks all. I almost got 50-60 wows. Thanks. And trust me, I'm not giving a branded advertisement to wow brand. Jokes apart. Okay. Okay, so this is what we call OSPF to configure in 3 ways. And most of them, like with my 12 years experience in industry, I have seen that mostly configure on interface level. Either it will be a GUI with some network management software, or either if it is a CLI, it is purely based with the CLI, this command. And there is 4th way, which is called OSPF version 3. Okay, we will discuss that. So there is a OSPF different also router. If you go router OSPF, okay, this router does not have that image. There is a latest iOS image I need to upload in this. So that latest image will show you some OSPF version 3 like this. Okay. So in that also you will be able to configure the OSPF with some address families. ओके ठीक है, तो यहाँ पे अभी समझ आ गया होगा सभी को. लाइक you can use any method, it's totally up to you. Okay, but the best one I would recommend you to go with the interface mode. Okay, mostly we know the iOS and iOS XR commands are almost same. Process ID matter, path process ID does not matter. Rahul, because you give exactly what you want. Why we recommend OSPF interface mode? Because first of all, it is easy. You do not have to take out the network IDs and that you have to calculate. You just give the interface thing inside OSPF and that's all. Okay, the best thing guys, like if you okay, my next interview question, this is the interview question like Juniper Networks asked me, but it will not be for you because you are a beginner now, but they will ask or maybe any company. So tell me, so R4, R5, R6 will have the same database or there is some variation? So if you try to check show IP OSPF neighbor, okay, there are few commands. We will discuss about DR, BDR, all the things. Don't worry. You will get all information here. So if you check the show IP OSPF database, this is a link state database and it is giving you some information that you are running OSPF with this process ID 1 and you see some router, these type of things. Okay, if you try, let me take out this window R4 from it and let's check on R5. Show IP OSPF database and check everything is same. Can you see that? Only don't see the age, rest all the things. Age means when the router link state database got this entry. Age means how much time before this entry got in my table. So maybe there is some difference between the tables, but rest all the things if you compare like 45.4, 45.4, I'm getting this from 45.4. So there is a sequence number. Okay, so you can see even the sequence number and the checksum value is same. Can you see that? And there is a link count also that is same. There is a 3 numbers, 1, 2, 3. There is another number like 1, 2, 3. There is another. Everything is same. Ditto. Only the age is having difference. Rest all your database is completely same. So now you understand if we put 50 routers or 100 routers in same area, what will happen? They will have same database. And whenever anything happens, any flap happens, you will calculate all your spanning tree protocol SPF tree again. Yeah, Akshay. So as of now, you can see these all are links. Like 45.4, where we have given this IP. Tell me where we have given this IP. On FA1/0, right? 45.5, where we have given this IP to router 5. 45.6, where we have given this IP to router 6. It means router is storing all your link information. This is why this is called link states. So these are links, and whenever you check this command, ये कौन सा command है? Show IP OSPF neighbor, and it will give you the states also. Show IP OSPF. Okay, so you can see these are state. So links and states. So this is why it is called a link state. Okay, because you actually maintain all the link states. So which link is up, which link is down, and all these things. Okay, so the best thing you will be learning today is OSPF packets now. Okay, so please focus here, and some theory part is coming here to you. OSPF packets. So tell me how many packets we have in OSPF, or messages. We can say messages also. Okay, both are same thing. Don't get confused. Okay, the first message is hello. Second is DBD. Third is LSR. Fourth is LSU. And fifth is LSAC. Okay, and there are some states you need to learn both at the same time because both are linked with each other. तो दोनों को एक साथ पढ़ना जरूरी है. So the first state we call down, init, two-way, xstart, exchange, loading, full. Surinder, try to reconnect again. Okay, good. Hello, DVD, LSR, LSAC. You, Anisul, you forget LSU. Okay, so hello is to discover the neighbors. You can note down some basic information, discover the neighbors. How to identify who are my neighbors? Because I send hello and whosoever replies with the hello, it means they are my neighbor. So DBD is a database descriptor or description, whatever you want, descriptor. Database description. Or some call this database descriptor also. Okay, that is summary of database. We will discuss about. So as of now, you can write down summary of database. Okay, LSR is link state request. Okay, other is link state update. And third is link state acknowledgement. Link state acknowledgement. Okay. And so these are the states, so which we are going to understand. So what happens? So let's discuss states after some time. But before that, we need to understand how packets works. So let me give you example. Like suppose we have R4 and suppose we have R5. So what is the first thing routers will do? Yeah, Surinder, it's working. What will happen? The router is going to send hello. Okay. And router 5 is also going to send hello. Okay. So once they send hello to each other, and if hello parameters are matched, sometimes what happen? They do not match hello parameters. And we will discuss about hello parameters also. Okay. This is also an interview question. Tell me about hello parameters. So what are hello parameters? That their area ID should match, their authentication should match, stub area flag, their MTU size match. There are few things about hello parameters. But normally, if hello parameters are matched, means everything is fine. दोनों ने hello भेजा और hello से ये दोस्त बन गए. So once they send hello, they become neighbors. Right? So once they become neighbors, then once they become neighbor, they both have their database table. Suppose R4 has the 10 networks, R5 has an information about 20 networks, right? Maybe R5 has a LAN networks, or maybe R5 is getting from somewhere. तो R4 के पास 10 नेटवर्क है, R5 के पास 20 नेटवर्क है. Okay, so R4 has 10 networks, R5 has 20 networks. R4 is going to send one packet which is not the complete detail. Like I have shown you that database table looks like with complete information, but we are not going to send complete information. We are going to send only the summary. We are going to send the DBD packet with the summary. So DBD contains the summary that I am sending you 10 networks. So R4 will send that I am sending a summary of 10 networks. Please compare with your database table that all these networks you want or you already have. तो R4 अपने 10 नेटवर्क R5 को देगा, ओके, और R5 कंपेयर करेगा क्या ये नेटवर्क मेरे पास है या नहीं. So R4 is going to send these 10 networks and R5 is going to compare these 10 networks into the R5 table that R5 has these routes or not. So if R5 do not have these routes in his database table, so now R5 is going to send which table? R5 is going to send which message? Link state request. And link state request for what? That please send me those 10 networks. Please send those 10 networks information. Please send I'm not able to write all detail. Please send info for 10 networks. And what will happen? R4 is going to send those 10 network information with which packet? Link state update. Please, here is the information. Okay. Correct? And once you get all these 10 networks, you update in the table and you make it 30, because 10 is added into 20 and it becomes 30. And once that is added, you send confirmation. I have updated my database. And now the same process, you have only 10, the same, it is also going to send you DBD from this side with the 20 networks. Okay. It is going to send LSR in this direction that yes, please send me 20 networks. You will send a link state update for 20 networks. So both will send each other DBD packets, LSR packet, LSU packet, and both will make their networks 30-30. And this is what we call database is synchronized. Clear everyone? मजा ही आ गया होगा तुम्हें तो कुछ लोगों को. Okay. Okay, so now we are going to now understand states, because that is more important. And don't cram everything in networking. Is almost have logic. Mostly few things are exception, but most of the things like OSPF have 5 packets, 7 states. So they are linked with each other. Don't cram, okay? Because in interviews, if you cram, nobody, if someone will ask you some type of question, okay, okay, if you tell me, if we are not able to send DBD from R4 to R5, will they share routes with each other? Tell me technically. अगर मेरा DBD पैकेट नहीं जा रहा है, if my DBD packet got lost, will the router will send info routes, or the database same link will be, or database table will be same? No, right? So this is how we ask questions in interview. This is I'm telling you, because we will obviously either we can ask him, okay, what are the topics? They can easily anyone cram and say these things in interview. Hello DBD, LSR, LSU, like ASEC. Like they have eaten up something or some energy drink. They speak like that already they have crammed. But when we ask, okay, if you know all these 3-5 packets, tell me if DBD packet got lost, will they become neighbor? Okay, and we can also ask, so what is LSR? Obviously, anyone knows link state request, but for what OSPF request for? What OSPF request for? Tell me. Why we send LSR? It request for the routes which he doesn't have in the database table. It request basically for the links. Correct? LSR is used to ask for the links which is not in his database table. Yeah, to know the link information, not routes. Do not say routes. Here I am talking about link states, links. Because database table is all about links, not the routing table or routing routes. Obviously, it is related to routes, but the technical word would be link. Okay, so this is how we ask questions. I am just telling you for your knowledge. If you think that, so there many people say me in the call, sir, I have done CCNA, I have done CCNP. Now tell me what to do. So if you have done or you know, that is two different things. करेक्ट? अगर आपने कोर्स किया है और तुम्हें आता है, उसमें दो डिफरेंस है. इफ यू हैव कंप्लीटेड एनीथिंग फ्रॉम एनी वेयर, लाइक मे बी फ्रॉम एनी ट्रेनिंग सेंटर और फ्रॉम एनीवेयर, सो देयर इज अ डिफरेंस बिटवीन you completed the course or what you know. So please focus what you know. Don't give false promises to you that you already completed the course and now you become the expert. ठीक है, तो यहाँ गलती करते हैं बच्चे. उनको लगता है कोर्स खत्म, आगे चलो. They think that if they completed NP, let's go to firewalls, let's go to SD-WAN, let's go to further. So yes, definitely you can go, but don't forget you need to keep learning these technologies. You can't skip this, because whenever you are going to give an interview, they will not ask you direct SD-WAN question. They will ask you some OSPF question. They will ask you BGP question, because all this SD-WAN technology is on the technologies. SD-WAN is a different technology, but OSPF, BGP, MPLS is still in the market. SD-WAN is not actually like replacing MPLS, not replacing BGP, OSPF. SD-WAN is just a advanced technology on top of OSPF, BGP, MPLS technology. Okay, so you can't skip OSPF, BGP, MPLS. That is the core. Okay, so now let's talk about the states. Okay, so I'm removing this and let's understand the states. So what is states? Don't try to write Punjab, Haryana, Jalandhar, Punjab, जो जितने भी हैं. Okay. So I am talking about OSPF states. OSPF states. So I told you, when two routers become neighbor, obviously they send hello. So when we send hello from one side is called init state. So whenever the router has seen that we are receiving any hello or we are sending, like you can simply say it's one side hello is called init state. Before that, you have a state called down. It means OSPF is not configured. So when you send hello, the first state is init. So when you get another hello from another side, it becomes two-way state, because both the sides you got hello. So the second state is two-way. It means both side hellos, bidirectional hellos. Okay, bidirectional hello. So now what will happen? You are going to send, obviously remember the last example, 10 networks, you have 20. So what you are going to send after hello? You send DBD packets. So when your DBD packets are going, when the DBD packets are going to each other, this is called X start. So X start is a state where we send DBD packets. So where we send DBD packets. Okay. So when we send DBD packets, so this is called X state. And there is some master slave election going on. Who will send DBD? The highest router ID will send DBD. We will see this later on. So, but you can ignore right now. Okay. And once the DBD process completed, because you will not only send one DBD first of all, guys. If you have many routes, if you have 100 routes, you may send multiple DBDs also. So there is a DBD sequence number in OSPF also. So again, that is a little advanced. We will discuss. But as of now, you can consider when we send DBDs, this is X start. But once the DBD process completes, this is called exchange. So when the DBD process gets completed, the DBD process once the DBD process completed, this is called exchange state. OMG, right? And tell me which once we compare the DBD packet, which packet routers will send to each other? Tell me which packet after DBD we will send to each other. Okay, yes, we are going to send link state request. And after link state request, which packet another router will send? Yes, link state update. And tell me after that what you will receive? Yes, acknowledgement. So all these packets are in one state, which is called all the packets of link state request, update, acknowledgement. This is what we call loading state. So whenever you play a game, it gives you a screen where the information gets loaded. So this is where all the routers are loading all the information to each other. This is why it is called loading. Link state request, link state update, bhar do routers are. Okay, so it has 10 routes, 20 routes, share with each other. And once the database have same, when the database is same, so what we call that? Full state. So this loading means you send which packets? You send your all request packets, your update packets, your acknowledgement packets mostly. All it comes under loading state. And once all the database is synchronized, the database is same. This is called in networking database synchronized. Database is sync. That is called full state. Okay, there is another interview question which is asked normally. What is the difference between neighborship and adjacency? Now you will come to know. I think this would be your best OSPF class ever. Yes or no? What do you think? Okay, so what is the difference between neighborship and adjacency? So guys, remember, when we send hello to each other, we became neighbor. This is neighbor. Anyone can become neighbor when hello packets are exchanged. When you are in two-way, you are also neighbor. But when you are in two-way state, you are a neighbor. When we send a hello to each other. But what is adjacency? It means when the database is full, when the database is synchronized, that is adjacency. It means that router belongs to my area and it is fully adjacent. Fully adjacent means me and another router have same database. That is adjacency. Adjacency means that we have same database table. Neighborship means we only exchange the hello. This is the difference between neighborship and adjacency. Yes, all the database is synchronized is called adjacency, correct. When the database is synchronized, we call adjacency. When we are in two-way state, this is called neighborship. Okay, so this is our lab for OSPF. Okay, so to make you understand, we have 3 different areas. So this is area 0, and we have R1, R2, R3, R4. And these routers are in area 1. These routers are in area 2, and all these 4 routers are in area 0. Okay, so you can see this router is also connected with internet, and this router is also ASBR. Okay, let me unmute you guys so that you can ask questions. So the lab design is understandable. Like, do you have any confusion? Let me know.
No, sir.
No, sir.
Still no confusion, sir.
Clear, sir.
No, sir.
Okay. Okay, so this is our lab, and this lab is actually, so when you check the CCNA 200-301, the exam content, okay, and when you see the exam topics of CCNA, so normally Cisco has removed the multi-area in CCNA. But why we are doing that? Because when you go for the interviews, they will ask you. Okay, so you can see configure and verify which area only. Can you see that?
Single area.
And
Single area.
which lab we are doing here? Multi-area.
Multi-area.
Okay, because in your CCNA syllabus right now, you have to only understand one area. Okay, but when you go for interviews, they will ask you, okay, what is ABR? They will ask you what is ASBR, and maybe they will definitely ask you about DR, BDR election. Okay, and you should be well aware of all these things. So this is why, and you understand OSPF in a better way when you do multi-area labs. Okay, clear? So let's jump into, and what other things we need to understand. Neighbor agencies. Okay, point-to-point, broadcast, DR, BDR, and router ID. So let's start with the configuration. I'll write the configuration here. Okay, I already have the configuration. So you can see all the configuration I have copy pasted here. Okay, clear? So that you will be going to use this lab. So just remember what you have to do. You need to open this website racks.nwkings.com and turn on all the devices, and that's it. You can open from anywhere, even you are in office or even at your home. You do not have to install things into your system. Okay, so let's start. So I'll do the configuration from this side R1. Okay. So directly I'm going to configure. I'm not going to copy paste today. So please focus here one by one. Okay. So I'll start with the R1 first. Okay. So R1 enable. Can you see my screen properly?
Yeah. Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is R1, and we will give the name host name R1. Okay, so you can consider this R1 as any location. Okay, so interface FA00, IP address 192.168.12.1, because this is router 1. So last subnet I'm going to use .1 here, 3 times 255. Okay, and no shutdown. Clear?
Yes, sir.
Yeah.
Yeah.
So interface FA0/1. IP address 192.168.13.1. Yes, good. Okay, yahan tak clear? All good. So now, like, because you do not know what is loopback, so right now R1 is having 2 physical interfaces. So suppose this is your Delhi location. So just imagine this is your Delhi location, or okay. So now maybe you have a LAN network here, yes or no?
Yes.
Yeah. So you may have servers here, maybe some there are some Wi-Fi devices which is connecting your Wi-Fi devices at your Delhi office, right? So there is a proper LAN network here, right? Yes or no?
Yes, sir.
Okay, but we are focused on in which topic today? OSPF. So obviously I'm not going to create VLANs and all that. We can do in the big labs. Yeah, Shubham, this is me only. Okay, so OSPF. So we cannot create a LAN network here because our topic for today is
OSPF.
So we should focus on OSPF, or should I make the LAN network properly with VLAN, InterVLAN and all? That we will also do. That is called real labs. Okay. So that we will do in the later stages of CCNA. But right now, what I'll do, I'll imagine this LAN network here. How to imagine? When you do lab, we can create loopbacks. Okay. So what we will do, interface loopback. Okay. So you can create millions of loopbacks. So loopback is a virtual interface because we are testing here. Right now, I do not have a LAN network, but if I want to pretend there is a LAN network, अगर आपको imagine करना है यहाँ पे एक LAN network है, so what you can do here?
Here loopback.
Yeah, so you will create a loopback interface. Okay, so you can create a loopback from 0 to 214783647. Okay, you do not have to remember that number, but it is a very big number. So it means you can create thousands of loopbacks also for testing. Yeah. समझ आ रहा है?
Yes.
Yes, sir. Any confusion?
No, sir.
On one router, sir, we can use this number.
Yeah, you can create on all router. This is not a special router. Okay.
This for testing purpose only, sir, right? Not for.
So in real production networks, somewhere in real things also loopbacks are being used, but slowly you will understand, like for management traffic, for telnet. So we use loopbacks in real networks also. It is not only for imagination. Okay.
Okay.
But here we are using for pretending there is a LAN network. Okay. Okay.
Sorry, is this mandatory?
No, this is not mandatory.
Okay. Thank you.
So this is just you need to understand. Okay. Because when you understand loopbacks, so because in any topic, if you learn CCNA or CCNP, in most of the topics, when you will do labs after this program, because we are also giving you labs, but maybe somewhere down the line, you want to do labs on internet. Okay. Or maybe you want to explore more things. But in some practical, in Cisco lab guides, it is written over here that you need to create loopback. So you should be well aware of loopback, right?
Yes.
Means yes, it's mandatory for you to understand what is loopback, but it's not mandatory to create a loopback in labs. Clear now?
Yes.
Okay. So interface loopback. So I can start with 0. Okay. So I do not have a LAN network here. Okay. So I can imagine. So when you have a LAN network normally, suppose there is a LAN network here, which is there is a switch here, which is going connected here. So normally you assign IP address here, right? So maybe 192.168.1.1. Yes or no? Yes. So to these PCs, then you assign who is my gateway? 192.168.1.1, right?
Right.
So right now I do not have LAN network. So what I can do here, I can create a loopback. And remember, loopback should not be like, we do not have to give no shutdown, because these are virtual interfaces. When you create loopback, automatically they become, the state become up.
But for loopback interface, it's ID only, not the entire IP one.
Yeah, we are going to enter IP now. IP address 192.168.1.1. The same way you assign IP. So now you can add a command here, a description. Okay, so just LAN network test. Clear?
Yes.
Okay, now you got it. Why we created a loopback?
For
Yes.
Okay, so we created a LAN network test because we will connect a LAN network. We have ordered Cisco devices, and maybe in after 15 days, my Cisco devices will come. But before that, you need to build your. So what we are doing here, we are creating a WAN network, because LAN network अभी बनेगा बाद में 10 दिन बाद 15 दिन बाद. तो अभी के लिए मैं क्या कर सकता हूँ, LAN network को imagine कर सकता हूँ. Yes.
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 Clear? So now when you see show interfaces a description, this is very important command in real production networks, so that you will get an idea. Okay, this is my LAN interface. Okay, so this R2, suppose this R2 is your maybe Mumbai. Okay, so you can go to this interface also and type here description Delhi to Mumbai, Delhi Mumbai link. Okay. So this is 50 MB suppose. So 50 MB. So this connection is actually given by ISP. Clear? And there is another network, maybe this is FA01, this is maybe Delhi, Mumbai, this is maybe any other location, maybe this is Chandigarh. So Delhi, Chandigarh link, this is also 50 MB or 60 MB. Okay, so now the best part of this command is in the real production network. So when you see, you will get to know which links are important. Can you see that?
Yes, sir.
Yes.
So FA00 is between Delhi and Mumbai, which is 50 MB connection. And then FA01 is the link between Delhi Chandigarh link. This is 60 MB. And we created a loopback right now for testing. But when we will have a LAN network, we will remove this loopback and we will set up the physical IP. Maybe we will connect to the LAN network or this interface. So when you have a LAN devices, you will connect the switch cable on this port. And then after that, you can remove the loopback. Make sense?
Yes.
Yes, sir.
Loopbacks are just it's an imagination in place of LAN network.
Yeah, you can say that right now, but in real networks also we use a loopback. So suppose a loopback we created and we can configure telnet. Okay, so I'll cover that later on. Just right now in this lab, we created loopback so that you understand this is just a imagine, like we are considering this is just a virtual or a test network for me. Okay, yes, and loopbacks never go down, right? So now tell me if R1 is configured, IPs are configured. So you can check show IP interface brief. So all three links are up, yes or no?
Yes.
Yes, sir.
So let's jump to R2. Okay, so let's jump to R2. I'll configure with little high, more speed now. तो मैं थोड़ा जल्दी configure करूँगा. Okay, so this is R2, this is R3, this is R4. Okay, so let's go to R2. Okay, so just always remember when you turn on the devices, just make sure you press this no. So what is this? This is auto system dialog. What we call this? System setup, right?
Yes.
ये शुरू में थोड़ा सा टाइम लेते हैं. Okay, so now let's jump to R2. So R2 enable configure terminal host name R2, right? Interface FA00, IP address 192.168.12.2.
2, yes, sir.
Yes, sir. Yes, sir.
Okay, so interface FA01, IP address 192.168.24.2. 2.
Yes,
This is router 2, na? So I'm taking
Yes,
the
sir.
last subnets 2.
Yes.
So interface FA1/0, this one. So this is going in 27 network. So here I am going to configure IP address 192.168.27.2. Okay, so in short, we have configured the IPs. Okay, show IP interface brief. So you can see. So here I have given 12.2. Here I have configured 24.2. Here I have given 27.2. Clear?
Yes, sir. Yes, sir. Yes, sir.
Yes.
ठीक है, all good?
Yes, sir.
Yes, sir.
Okay, good. So let's jump to R3, which is R3. This is the R3. Enable config T, hostname R3. Okay, so interface FA01, IP address 192.168.13.3.
3. Yes, sir.
अरे राउटर का जो नाम है वो नहीं याद रह रहा क्या तुम्हें? 34.3. Okay, so it's easy for you to remember. Okay,
Yes,
and
sir.
I'll tell you what is the logic why I have done this. Because in terms of troubleshooting, you will understand how the packet is coming or how the traffic is coming. So this is R4, right? Interface FA00, IP address 192.168.
24.4.
24.4. Interface FA01, IP address 192.168. 34.4. Clear? And there is one interface FA1/0 IP address 192.168.45.4. तुम्हारी भी इतनी स्पीड है ना?
नहीं सर.
Okay, so one interface is left to shut down FA01, no shutdown. So do practice like that, you will actually type like me, right?
कमांड याद रहेंगे तो स्पीड होगा सर. कमांड करना जल्दी.
वो गजनी की तरह टैटू बनवा ले हर कमांड के. शो IP OSPF neighbor on the left hand. Okay, so all 4 routers are connected. So now tell me, if I go to R1, okay, so obviously we have not configured OSPF. Okay, so I'll give you very easy way to configure OSPF. Okay, but I think we should configure all the routers with IP. What do you think? Should we complete the IP address configuration?
Yes, sir.
Okay, so ये area इधर है. So I'll drag this group here. Okay, so this is R7, R8, R9. So R7 has only one interface. Enable is already done. Config T, hostname R7. Okay, tell me which interface. FA00, IP address 192.168.27. Okay, so there is some problem here.
And these come out.
Why it is okay. So I am using a lot shortcuts.
Sir, my question, Eric. Just
yes, ask.
Just like we are giving R for the router IP address 192.168.45.7, right? Since the 192.168.45.0 is the network ID, why we are not giving a 1? Like,
yeah, because I just want to use this easy nomenclature, because you do not forget, okay, what IP you have to give here.
Okay, that's fine.
You can give 1, 2, 3 also.
Yeah, that's fine.
I'm just using for easy remember. 7 is 7, 9 is 9, because all we are using is 24. So /24 gives you 254 IP.
254, yeah.
Router number.
Okay, so it does not matter here because you are doing a lab.
Yeah, that's
got it. It is good for you to understand the concept. This is R8, hostname R8, interface FA00, IP address 192.168.27.2 also you can assign. But here I am typing 8 because when the day you see this network, you understand this is coming from 8. So this is last, I think this is a host name R9. Which work on MAC address. Yes, obviously MAC address don't understand the different subnet address. What is use of loopback address? Okay, already we are covering here. Okay, so FA00 IP is 27.9. Okay, so R8 also done. So we have only 5th and 6th router left, which is area
2.
Which is area 2, right?
Yes, sir.
चलो जी इसको भी खत्म करेंगे. So let's do R6. So this is R6, host name R6. So interface FA00, IP address
192.168.45.46. Sir. 46.
45.6.
45.6.
Okay.
तो यही दिया है ना?
Right.
Right, sir.
So this is R5, interface FA00, IP address 192.168.45.5. Okay, समझ आया क्यों easy है method?
Yes, sir. Router का numbering के ऊपर.
You do not get confused 1 or 2 stuff.
Yes.
Okay, all the IPs are configured properly. And now let's jump on to OSPF. Okay, the OSPF starts now.
Bit slow, sir. No.
Sir,
okay,
can we ping right now any router?
No, you cannot ping because you do not have routes, na?
Okay, yes,
So when you check show IP route, can you see 45 network in the table?
No, sir.
No.
No, sir.
So can you ping 192, maybe router 5 IP? Or let's go to R5. So tell me, can I ping the loopback IP of R1 which I created 1.1, right? So suppose I go to R6 and I say ping 192.168. This is the LAN network of Delhi. This router.
Yes, sir.
Yes, sir.
Ping the LAN network of Delhi. No. Why? Because we do not have the routes.
Yes, sir.
And this is why we are configuring OSPF. And OSPF is a link state routing protocol which will exchange information with each other. Yeah. So this is what we all have, what we all covered, right? So we have dynamic routing, IGP, EGP. So in IGP, we have OSPF, right? Remember all the things what we covered?
Yes, sir.
Yeah. So what is the flow? What happens when OSPF runs? Can anybody tell me? Just wanted to see. Like suppose this is interview going on. I'll ask you how OSPF works. Can anybody tell me for practice? कौन बोलेगा? जल्दी बोलो.
Yes, sir. I will tell. First step is neighbor addition, sir. It can.
Yeah. Just hold on, Rahul. You speak.
Okay, sir. Sir, I will just first exchange neighbor information, sir. And then it will build a link state database, sir. Then it will third step is
it will make the algorithm.
SPF algorithm. It will run.
Extra
algorithm to link state protocol.
Yes, and then
do
it will
one
find
thing.
the
Go to the Government of India office and change your Aadhaar card and have your name Rahul.
Yes.
Rahul, continue.
Yes, sir. First step is it will advertise, sir, neighbor advertise. And then second
This
step
is how you will speak in interviews.
Sir, mic issue, sir. Hello. Now it's clear, sir.
किसका issue नहीं है वो बोले फिर रुको राहुल तुम.
Yes, sir.
Now who will say now? Amjad.
Sanjeev.
Okay, Imran Newtel.
Sir, first of all, we will check the neighbors to exchanging LSA, and then we will router will create the LSDB. That is a link state database table, and then router runs on algorithm, that is SPF, and then it will find the best path that is stored in a routing table.
Okay, so my question from you is from interview perspective. So if we configure OSPF on all 4 routers, so only one router will run the SPF algorithm, or all 4 routers will run
All,
SPF
sir.
algorithm?
All, sir.
But all they are part of one area now. If they
Yes, sir.
belong to one area, so one router will run all SPF algorithm, or all 4 routers will run SPF algorithm?
All, sir, all.
Okay. And from SPF algorithm, what it will build? It will build which tree?
Path first.
It will build which tree?
SPF tree.
So SPF tree, suppose if R1 is building, so tell me the tree here. If R1 is building tree, so R1 will have how many branches? So if
2 branches.
R1 building a tree, R1 will
It has
say
2 branches.
R1 has how many branches?
2 branches.
3 and R3.
R2 and
R2 and R3,
R3.
1 2 branches.
2 branches.
yes. So R2 will have now how many branches?
R1 and R4.
1 branches.
R4
R4 and
it will have
R4 and
R1.
R7.
R7, R9 and
R9, 8 and 9. R8.
R8.
Got it? How it builds SPF tree?
Yes.
So R7 is connected with internet. So if R1 wants to go internet, which SPF tree will follow which path? So this best path will be stored into my
Routing table.
Okay, so R1, R2, R3, R4. So now let's configure OSPF. Okay. So what to do? Like I'll tell you the very easy method in OSPF. Like I'll go to the config T. Okay. So R1 router OSPF 1. So this router ID command is not mandatory. But if you give this mandatory command, then which will be preferred? Like if you configure router ID, so tell me what is the first preference? How OSPF select router ID? Tell me. First, it will check the manual configuration.
Manual, then the highest IP address, loopback, and
Then
So
highest
if
equal
I
highest
give router ID, if I do not give router ID, so tell me which IP is the highest IP here in my router. Just let me show you.
Loopback, sir. Loopback will be highest.
highest loopback.
Yeah, so even this IP is lower, even IP address दिखने में छोटा है यहाँ पे loopback, but फिर भी यही बनेगा क्या router ID. So this IP is even lower, but still it will become the loopback. Loopback will become my router ID because loopback interfaces always beat physical interfaces. So what is the line? Loopback interfaces always beat physical interfaces.
So, sir,
Yeah.
sir, as you said that loopback interface always beat physical interface, but when we will use proper LAN network, then sir the highest
Yeah, so if this is a real LAN network ना, loopback की जगह अगर ये मान लो this IP suppose यहाँ पर होती, suppose this IP on FA10, so then 13.1 will become router ID.
Okay, so तब हम highest ले लेंगे इसमें से.
Yes, so if you do not have loopback, so if this is my physical IP, so out of all three physical IP, the highest will become router ID. Okay.
Yes, sir.
So what I'll do, I will just go to which interfaces I want to activate OSPF. So I'll give you my best OSPF command to you right now. So the command is show IP OSPF interface brief. Okay, what is this command? Show IP interface brief. So between IP and interface, what you have to add? OSPF. So show IP OSPF interface brief. Clear?
Yes.
So when you enter this command, do you see anything here?
No, sir.
No.
Okay, so now I'm going to activate OSPF. So what I'll do, which interfaces I want to activate OSPF? Interface, interface range, FA00. Remember in switches also we use a VLAN. So FA00 and FA01.
102.
Right, comma, which loopback? Loopback 0.
0.
Okay, you can type here loopback 0 also. Okay, so just hold on. FA00 and 1. Let's set up this. So what I have to say? IP OSPF. So which process ID I have used here? OSPF 1. So just you need to enter this command. Even you do not enter this command automatically, just directly you can also give this command IP OSPF 1 area 0. And also inside my loopback, I will give this command IP OSPF 1 area 0. So now let's come back to this command show IP OSPF interface brief. So now you can see OSPF is activated on all three interfaces. Clear?
What is the state here? Wait.
What?
Sir, the state is showing wait. Just asking what is there.
Where is wait? अच्छा,
In
वो अभी आया नहीं है नेबर है ना, दूसरी साइड से नेबर अपनी आया. Okay. So this is why. Okay, so right now you can see the cost of this link. This is maybe a 100 MB link. Okay, so when you see this FA01, what is the cost here? 10. Okay, what is the formula of OSPF?
Cost
10 into 8
bandwidth.
So you can check your cost, show interface FA00, and you can see the bandwidth here, guys. You can see 10,000. Can you see that? kbps. Yeah?
Yes,
yes, sir. Yes. तो ये लिंक मेरे 10 MB पे चल रहे हैं. वैसे दिख FA0 रहा है, but these because this is a EVNG platform, so it is showing you around 10,000 KB, so around 10 MB. So what is the formula to calculate the cost? 10 to the power of 8. So 40, so 8 zeros, and you this is in 10,000. This is MB, right? And you type 3 more zeros because it is written in KB. So you remove 7 zeros from the top. What cost you will get?
10.
This is the same cost I'm getting.
Yes, sir.
So ISC show IP OSPF interface brief, and you can see on all the FH01, FH00, the cost is 10 and 10. Loopback cost is always 1. Clear yahan tak?
Loopback cost by default 1, sir.
Yeah. By default, this is a formula. Now OSPF will calculate at the back end this formula.
Okay.
ठीक है, यहाँ तक clear है? All good?
Yes, sir. Now clear.
Okay, so this is R2. So R2, like two interfaces, FH00 and FH01, in which area? FH00 and FH01, IP OSPF1 area?
1.
0.
0, sir.
0. IP OSPF1 area 0. And you can see the neighborship came up. There is a neighbor up. Okay, and this FA1/0. So what do you have to enter here? IP OSPF1 area?
Area 1.
Yes, very good. So now what is the best command? Show IP OSPF interface brief. So you can see both the interfaces are in which area? 0. And the third interface I have added into which area? Area
1.
Clear?
Yes, sir.
Now let's jump to R3. इतना easy हो गया, अब तो तुम ही बताओगे configuration सारी. Enable config T, tell me. Yes, Deepak बताएगा. Deepak, tell me. Dinesh.
So interface 0/0.
FH00/1.
1. Then
IP OSPF on
area
0.
Area 0.
Very good, very good.
192.168.
हो अब ये 192 को देना है. 192 तो IP होता है ना. Already we have given those IPs.
Yes, sir.
ध्यान का है?
सर इसमें IP देते नहीं, इसलिए डायनामिक बोलते क्या? इसमें तो IP हम रूट कहाँ पे भी कॉन्फ़िगर किया नहीं हमने.
Yes, we do not configure static route. Automatically all routers are sending LSA.
Just interface is configuring, and then we have to enable routing protocol.
Yeah, once we enable OSPF, all routers start sending LSA. Which LSA packets? Inside the LSA, all the routes are coming from one router to another.
Oh,
okay.
Okay. Got it.
So you can show here. Let me show you here. Debug IP OSPF. Can you see that?
Yes.
So if I say debug IP OSPF, or maybe let's say LSA generation, can you see that? So debug commands are basically used to check at what is going on at the back end. So if I want to see all the LSA, I can see LSA generation. Okay, you can also track OSPF packets also. Debug IP OSPF packet is also very good command. But I want to see LSA generation and all. Okay, then I'll go, or even I want to see the SPF, because all OSPF will get what we call all database, and from database it will run SPF algorithm, right? So आप जितना भी OSPF काम करता है, all you can see from here. So I'm using just one variable here, debug IP OSPF, LSA generation. Even I can track debug IP OSPF packet. Okay, so just see here what I'll do now. Interface range FA00 and -1 IP OSPF1 area
0.
अभी देखना कितने मैसेज आएंगे.
Loading
Can you see that?
full होगा.
What is happening here?
Sending LSA packet.
OSPF is getting LSAs. OSPF is sending messages to each other, right? It is also
sir.
sending the router ID. What is the router ID? So this router has picked which router ID? 34.3. Okay, so you can see a lot of things. And how to stop all these messages? You go to the config mode, undebug all. Undebug. Sorry, ये privilege mode पे चलता है. Undebug all. Okay, so if you want to track maybe another packets like debug OSPF, okay, you want to see hello. So there is a packet in OSPF which is called hello packet. After every 10 seconds, all router are saying hello to each other. दिख रहा है hello packet?
Yes.
So router 4 has how many neighbors? Tell me R2 and R3 right
R2,
now because
R3.
we,
R2, R3.
yeah, so we have not activated OSPF here.
R5 and R6.
Yes.
Yeah, we अभी हमने configure नहीं किया. So right now I have only two neighbor R2 and R3. So I'm sending hello packet to R3 and R2. Yes or no? I'm sending hello packets on which multicast address? 22400
22405.
5. Okay, so you can stop here and debug all. Okay, so undebug all. Say messages. So you can use a debug IP OSPF and type any command what you want to. So this is your homework. Try to do all this stuff and try to see what is going inside the packets. And after that, if you want to stop, you can just to stop any packet is undebug all. Okay?
Yes.
So right now R1, R2, R3, R4 is configured, but only one interface is pending. FA 1/0 IP OSPF 1 area 2. So now tell me R1, R2, R3, 4 are in which area?
Area 0.
Area 0. So when you check show IP OSPF neighbor, so R1 can show you how many neighbors? 2.
2, sir. R3 and R2.
Okay, so they are in full neighborship. What is this full? There is a full neighborship. Okay, full neighborship means they are ready to exchange their information with each other. Okay, and now after this, there is a command show IP OSPF database. So database, in database, you can see a lot of stuff here. Can you see that?
Yes, sir.
दिख रहा है? So right now, how many routers are participating in area 0?
4 routers. 4 routers.
1, 2, 3, 4. So all 4 routers are sending their router IDs to each other. Okay. And all routers are sending their router IDs information. And this information is called router LSA. Which LSA?
Router LSA.
So now if 4 routers are connected in one area, how many router LSA you will have? 4. And in the router LSA, what you will have? Router ID. Okay? All good?
Yes.
Yes, sir.
So you can see this is the router ID of my router 1. So this is router 2 ID. This is, now you understand 1, 2, 3, 4, why I did that?
Yes,
So
sir.
ये router 1 है, 2 है, router 3, router 4. So all 4 router IDs you can see here.
Yes, sir.
Yeah.
Yes.
Okay. And right now in OSPF, there are 2 types of network you need to understand. Whenever you configure router with some old type of cables, like in CCNA, somewhere in packet tracer, you see this cable serial. So this is a very old cable. Even some technologies are still there. And whenever you connect these type of old technologies, or these are called point to point, which point to point network, which network?
Point to point.
Point to point. But when you connect OSPF with Ethernet cable, because this is FA00, FA full form is?
Fast Ethernet.
Yeah. So whenever you use Ethernet, so what happens? One router become DR, one become BDR. I'll explain this thing. What is a DR, BDR? So now in this, every segment, one router is becoming DR, other is becoming BDR. Here also one is becoming DR, here also one becoming BDR. और इन दोनों के बीच में भी एक राउटर DR बन रहा होगा और एक BDR बन रहा होगा. Okay, so who becomes DR, who becomes BDR? So the router with highest IP address or priority, first it will check the priority. So let me show you neighbor. So tell me, I'm checking on R1. So R1 is saying 34.3. This router is what? BDR. Yes. So opposite side, it means this router itself is DR. तो जब सामने वाला राउटर दिख रहा है BDR है, तो इसका मतलब क्या? यही राउटर हमारा DR है. And in this side also you see BDR. 27.2 is also BDR. So in this side also I'm DR. So this router is DR for how many networks?
2 networks.
Yes?
Yes.
Clear?
27 तो हमारा एरिया 1 में है ना.
27 router ID आई है ना, इसकी router ID. This is name of router.
Okay, got it.
So it can pick any name from any area. So this is just a name. Router ID is name of router. समझ आ रहा है?
Yes sir, आ रहा है.
तुम्हें CCNA में होके बहुत कुछ समझ आ रहा है, नजर ना लगे तुम्हें. मम्मी को बोल के नजर उतरवा लेना आज.
Okay sir.
Okay, so R 34.3 27.2 BDR. Okay, ये समझ आया. अभी DR BDR एक्चुअल में क्यों होता है वो हम बाद में पढ़ेंगे. So right now just focus here. This is what is happening. And first I have shown you like all 4 routers are sharing info, their router IDs, and this is called the first set of group is called router LSC. Can you see that? दिख रहा है या नहीं दिख रहा है?
कहाँ पे सर?
अरे ये
दिख रहा
टेबल
है,
में ना. ये एक सेकंड.
थोड़ा सा स्क्रॉल करके ऊपर.
हाँ, ये देखो सबसे ऊपर देखो क्या दिख रहा है. So
Router
this is
lane
the
state.
first set which is called LSA router LSA1. Okay. So now you see the network LSA, which is like any router who is becoming DR. Okay, any router in this area 0. How many DRs are there? 4. 4. How many router IDs you see here?
4.
So how many DRs we have here?
4.
Okay, so we have 4 DRs here. Okay, and how many ABRs we have in network?
2.
तो कितने दिख रहे हैं यहाँ पे? 27.2, 45.4 is ABR. So this is my LSA1, which is called router LSA, which is actually router IDs. Router LSA में क्या होते हैं? Router ID. So in the network LSA, this is LSA2, which is called network link states, network LSA, router LSA, and summary LSA. So this contains router ID, this contains DRs, and this contains ABRs. I'm sure nobody have covered this in CCNA at least. Clear? Got the idea?
Yes sir.
सर
याद रहेगा सभी को?
रिपीट कीजिए ना सर.
DR BDR हम अलग से पढ़ेंगे. अभी सिर्फ like right now what you have to remember, the first set of group is called router IDs. Okay, you will maintain all your router IDs here. Okay, and in the second block, so let me write here OSPF LSAs. So first is LSAs, router LSA, which contains the router IDs. Second is network LSA, which contains the DR router IDs. Okay, and in the third you have summary LSA, which is ABR router IDs. Okay, and also in simple words, this LSA is generated by all OSPF routers. एक बच्चा YouTube में पूछ रहा है कि CCNA करना है, कहां से करूं? हलवाई के पास जाके पूछ रहा है मिठाई कहां मिलेगी? Okay, so you can connect with the, so those who want to join. So actually we are YouTube live today. So those who don't know. So any feedback you guys want to give? कैसा लग रहा है बैच?
बहुत बढ़िया सर. बहुत अच्छा सर.
बहुत अच्छा सर.
बहुत अच्छा
Very
good
sir.
Outstanding. Awesome.
Awesome.
We will never get anywhere in this world. Right?
In this world, na?
Yeah,
So,
in this world.
it's a unique
In this
actually.
universe.
Universe. Yeah.
Okay.
This actually.
The way of
Very
teaching
clear,
is very
crystal
different,
clear presentation.
and that is attract every time to us.
Please
Thanks,
like,
Bhavesh.
subscribe, and comment. Networking.
ये तो मैंने भी नहीं बोला आज तक. Okay, so network LSA DR router ID. So this is actually who generated by all OSPF routers within the area. Okay, तो कि कौन, ये इंटरव्यू क्वेश्चन है कि राउटर LSA कौन जनरेट करता है. इट इज जनरेटेड बाय ऑल OSPF routers within the area. Okay, and who generate this DR? DR obviously this LSA is generated, or who create this? Generated by DR routers. And this is generated by ABR.
ABR routers.
ABR routers. Okay, तो अभी आप इतना ही पढ़ो. And further we have 4 or 5 more LSAs which we will cover in CCNP. Okay.
Yes sir. Sorry sir. एक बार एक output एक बार explain कीजिए ना sir.
हाँ, output is like all 4 routers are here, right? And all 4 routers, right now you can see the first set, all routers are sharing their neighbor IDs because they send which packets to each other? Hello. Okay, they are sending hello. After that they become neighbor. Okay, they become neighbor, everything happens. After sharing all the information, they build which table? Database table.
LSD.
So in the database table, the first set, what we do, we save all the router IDs. And where we save all router IDs are called LSA 1. Okay, after that, all the DRs, suppose you have 4 routers or maybe 10 routers, all the routers who are DR, designated router. DR, I will explain in another topic. But all the DRs in your network are called LSA 2. So who is generating these? So you can see this router is a DR for 2, yes or no?
Yes, sir.
Yes, sir. So this is why, who is the advertising router 1.1 2 times, yeah? So for 12.1 link and for this is 13. Yeah. So 13.1, both IPs, who is the DR? 1.1. This is the router ID. So can you see 12.1 and 13.1 jo link hai hamare? 12.1 and 13.1 link is, the DR is 192.168.1.1.
Yes, sir.
Got it?
This is loopback.
Huh?
1.1 is loopback.
Yeah, this is router ID, yaar. Okay, forget about loopback. This is router. All these, these advertising router, these are router IDs. Okay, and these are all your physical or link IPs. Okay, these IPs like 12.1, 13.1. So here you see all the router IDs. Okay, got it? So let's jump on which routers are left for OSPF configuration. R7, R9, R this one. Yes. So what single command you have to enter here? Interface FA00 IP OSPF 1 area 1.
Area 1, yes.
R8. So this is R8. R8 is enable config T interface FA00 IP OSPF 1 area 1. So we have 9th router. Enable config T interface FA00 IP OSPF 1 area
1.
ठीक है जी, clear है?
Yes, sir.
So 5 and 6 FA00. So please make sure the links are okay. Yeah. IP OSPF 1 area 2. R6 is in which area? This is also in
area 2.
IP OSPF 1 area
1 area 2.
ठीक है, यहां तक समझ आ गया सभी को? Okay, so what do you think now? R5. So R5 should be getting all the routes or not? So let's check. R5 is here. Okay. So I'm checking on R5, show IP route. and you see all the OSPF routes. Can you see all the routes now? Automatically they are getting now.
Yes, sir.
Okay, so yeah, so with the O, you can see some IA also. So OIA is OSPF and IA stand for inter area. So it means these routes are coming from different area. So tell me, R5 participating in which area, guys?
Area 2.
And all these routes are coming from area 0 or area 1. So for this router, all these different area routes are called OIA. तो जब भी कोई दूसरे एरिया के रूट्स आपके एरिया में आएंगे, टेबल में आएंगे, तो उनको क्या बोला जाएगा? OIA.
OIA.
घर वाले ना जूते मारेंगे तेरे. ये तुम्हें पता है, एक बार तुषार कपूर ने OSPF की क्लास मुझसे ज्यादा ले ली थी, तब से वो OIA बोलता है.
सर
सारा मूवी में उसका OIA बोलता है.
हाँ, OIA. Okay, so now let's come back to R1, and when we check show IP route, so you can see here, you can see O also, but O single O also. So because 24.0, just track where is 24.0 between R2 and R4.
R2 and R4, yes, sir.
So this interface is in which area?
Area
0.
So when this area 0 route will come to this R1, so R1 is saying single O.
Okay.
Because whenever so these links are called single O links are called intra area. So there are two types of route. One is O. One is OIA. Okay, there is OE1, there is OE2, which is for the advanced stages like ASBR and all. But right now, O means your area routes. Okay, and OIA means different area routes. So now tell me, if one route is coming, so suppose that this any network which is coming from O and also coming from OIA, so router is going to prefer O or OIA? Interview question.
OIA.
O.
Oh, sir.
Yes, sir.
Lossless.
This is or it's
Yes,
already
because this is
in
my
0.
area, so I will prefer my area routes rather than different area. Okay, so whenever somebody asks you in interview, like you are getting a route with O or OIA, which route will be preferred? O. O means my area routes. OIA means different area routes.
Different area.
This is why, because we choose the shortest path, correct?
Yeah.
Okay, sir.
Hi, Rolex. How are you?
Sir, I saw you some previous videos where you can use some wildcard mask.
Yeah, you can watch that videos, but nowadays wildcard mask, like I would prefer you can go for this method, which is easy for you to understand. You can use a network commands also. जैसे एक पुराना मेथड यूज होता है इंडस्ट्री में, कभी कभी देखा जाता है. So in this there is another method to configure OSPF. Router OSPF, guys mic off रखो. Okay, so router OSPF, मेरी रिकॉर्डिंग खराब कर दी तूने. Okay, so router OSPF. So instead of FA00, I have given a command here. This is in area 2. So I have given the command earlier. This was the command I have given.
Yes, sir.
So I say no IP OSPF 1 area 2. So once I remove this from interface, how I will configure the OSPF? There is an old method which is called a network command. So I'll go to router OSPF 1 and I say network. So which network ID? 45.0 and wildcard. So subnet mask is this. So what is wildcard mask? This opposite of subnet mask is a wildcard.
Yes.
Instead of
3.0.0.255.
Yeah, so instead of 3255, I will use 3 zeros, and instead of 0, I will use 1 single 255. And this area is area 2. So now this command is also activating OSPF on the interface. So if you check show IP OSPF interface brief, so the command is similar. The network command is also doing the same thing. It is also activating the OSPF on the interface. So now it's your choice. You want to give all the network commands, or it's you take the simple one with this method, interface FA00 IP OSPF 1 area 2.
This one is better.
Yes, sir. This one is I also tried that one.
Yeah, network command is good, but I worked in industry for almost 11 years with very big companies. Like I worked with Vodafone UK. I worked with Vodacom South Africa. I worked in JTAC also. Juniper routers are mostly interface level. So mostly everywhere I have seen the interface commands. Because it's easy and also you do not make mistakes. Because when you put network command, there is a high chance you put a wrong wildcard mask. Yeah?
Yes, sir.
Yes, yes, sir.
Yes, sir.
So go with the interface method. Even there is a new method. Okay. So there is a new method, router OSPF version 3 like that. Even this method, mostly you do all interface methods. Okay. So we'll see later on. So, but now tell me, can I ping the R1 IP? So R1 has an IP here, 192.168.1.1. Can I ping all way from R5?
Yes.
Yes, sir. You can.
Yes, we got the connectivity, guys.
Yes, sir.
Yeah. So can I ping from R6, the same network?
Yes, sir.
Ping 192.168.1.1. Yeah.
Yes, sir.
So we got the full connectivity. Yes.
Yes.
All the branch offices are connected. So we have taken internet connection here. So how you will activate internet in my lab, in this networking lab? So very simple. You go to R7. Okay. But today you are not actually going to use properly because you have not covered the topic NAT. So IP address DHCP. So on this FS01, when you will get the lab access, obviously you already have. So when you open this lab on FS01, you have to give IP address DHCP. Okay, no shutdown. Okay. Okay, so can you see that we got the IP? So automatically, this is my office router where we have configured, we have servers. So this office internet connection is connected to this R7 router and we got the internet here. So you can see show IP route. And in the last, we automatically got a default route. Can you see that?
Yes.
Yes, sir.
Okay, and when I try to ping google.com, this is the real internet. Okay, so you can see I'm getting a Google ping from google.com. Can you see?
Yes.
So I got the internet. So how all my branches, Delhi, Mumbai, Chandigarh, all these branches all over the India or any country, how they will get the internet access? Very simple. This R7 having an internet connection, yes or no?
Yes.
Yes. This router already have a default route, yes or no?
Yes, sir. Yes.
तो ये देखो डिफॉल्ट रूट है. अब मुझे ये डिफॉल्ट रूट सभी को भेजना. आई हैव टू शेयर दिस डिफॉल्ट रूट विद ऑल द राउटर्स इन माय OSPF. This is how actually OSPF works in real industry. You will not take internet connection in all branches. Maybe you have internet at one location, maybe at two location. So on those routers where you have internet connection, you go under router OSPF 1 just to simply add default
information
originate. Please remember this command. This command is used only on those router which is connected to internet. And when you have a default route, you forward that default route to all the company routers. Now tell me if I go and check R1, when I go and check R1 should be getting the default route automatically.
Yes.
Because this OSPF is a which protocol? Dynamic routing protocol. Automatically we get the update. So let's see, we got it. Yes, we got it. Can you see OE2?
Yes.
This is E2 means external route. E1 and E2 are used for external route. And when you see R7, And there is a very important command, show IP protocols, and this router automatically become
ASP.
So what is the command to check? Show IP protocol. So this is autonomous system boundary router. Automatically, when you give this command, automatically this becomes my ASBR router. Clear?
Yes, sir.
Okay, now if I run on R2 the same command, what you will see, ASBR or ABR? R2.
ABR.
Yes, so this is an area border router. And this R4 is also
ABR.
तो ये वाला command भी क्या है? Area border router. So all way in all the branches we got the default route, guys. So how cool. Just we took one internet connection. It may be my one head office and I'm sending all the internet to all my branches. So what if, so now just tell me if this internet goes down, from where you will get the internet. So it means you should have at least one more connection somewhere. Yeah.
Yes,
Because
yes,
if
sir.
this internet goes down, automatically this router will share the default route to all the OSPF, all your company branches.
Yes.
Got it?
Yes.
Got it, na?
Yes. Got it, sir. Yes,
So just understand from now what we have done. Let me show you something. So there is a Visio tool here. Thoda relate karo. Try to relate with industry network. Okay. Will you?
Yes, sir. Will try.
Yes, sir.
Okay. So we'll try. Okay. Yeah. Try karo. So this is all branch offices. Suppose this is a Delhi. Okay. So in Delhi, how many routers on the top? 2. So they all connected with a private WAN. Yeah. So right now, according to my topology, so what all connections you see here, all these connections are private WAN, 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 private WAN. Yeah. So all these are private connections. Yes or no?
Yes, sir.
Yes, sir.
So all these connections could be MPLS. So these connections are given by which vendor or which organization? ISPs. Yeah. So all these connections are sending my traffic to one location, and all these locations are like, just imagine now all these locations are connected private WAN, and private WAN further you can see all the branches are connected here. Can you see that all circles, all these are your branch offices? So all these branches like Delhi, Mumbai, all they are connected with private WANs, right? They all are getting connected with ISP. ISP, this is suppose Airtel or maybe any company. They all giving you connections, and indirectly, directly you are connected all your branches with each other. Yes or no?
Yes, yes.
Yes.
And further, so now just understand, now this private WAN or maybe your head office have an internet here. Can you see that?
Yes,
we
sir.
have internet here. So it means all my branches here. So all my branches, how they are accessing internet? So from these routers, right? So these routers are connected with internet. Yes or no?
Yes, sir.
So all these branches, like 200 plus locations, all they are getting default route from here. Yeah. So where we have to put the default information originate command? On these 4 routers. So automatically these routers will get what? All these branches will get what?
Default.
Default.
Yeah. So it means suppose this is a branch here maybe Goa. So this Goa branch wants to access internet. What is the packet flow? You will go to the data center side where you have the main. So maybe it could be head offices also. Okay. It's not mandatory that all your internet connection is connected with the data center. So most of the time, suppose these are head offices. So already you are calling ISP. Hey ISP. So this is ISP. Okay. This is ISP. So you are calling any ISP and say that I want to connect to my head office with all my branch offices. Can you give me the quote? So every city has a connection. Yes or no?
Yes, sir.
तो सारी छोटे छोटे ब्रांच ऑफिसेज हेड ऑफिस सभी में क्या होगा? इंटरनेट नहीं यार,
डिफॉल्ट
प्राइवेट कनेक्शन, प्राइवेट वैन. Okay, so simple, you can say this MPLS link. Okay, private connection is called MPLS link. I'm sure those who are working, they have seen they have MPLS link in their offices.
Yes, sir.
Yes, sir.
है या नहीं है?
Yes, sir. Yes,
हाँ
sir.
जी.
वो MPLS क्या है? वो बेसिकली ISP आपको और आपके हेड ऑफिसेस और सारी ब्रांचेस को आपस में कनेक्ट करा रहा है. So ISP is helping you to connect your head offices, branch offices together, and ISP is giving just private connections. So this is not internet connection. So this is just to connect you, your branch offices and your head offices with each other. That's called private WAN. Clear?
Yes, sir.
Okay. Now, if you want internet access, that is public WAN. That is public WAN. So now if I want to access my internet, so how my traffic will go? I will forward my all internet traffic from MPLS link, and then I will forward the traffic from head office to here.
Public way.
Got it?
Sir, as you said that if this links goes down, then every branch should have its own.
Yeah. So because every company is a delegated, what we call, we need multiple connections. So this is why every company will have 2 routers, and there are 2 private connections also. Like we will not rely on one service provider. So maybe this is AT&T, this is CenturyLink. Okay, so these are the logos I remember for this company. Okay, AT&T and CenturyLink, maybe this is Tata and this is Airtel. So if Tata connection goes down because of fiber issue, so that your traffic will move to another ISP.
Yes.
Clear, everyone?
Yes, sir.
Yes, sir.
Okay, got it?
Yes, sir.
Sir,
Okay,
in
so
the
let's
topology,
take
private,
5-10 minutes break, and then we will have DR, BDR, okay?
sir, last question, sir. In private WAN, we are using MPLS link. In network side, which link we can use?
In
Network side.
so means you want to connect your branch offices on internet.
Yeah, in public WAN side, sir.
Yeah, if you want to connect your connection on public WAN, so you can use IPsec tunnels, GRE tunnels. There are a lot of features.
Okay.
Okay. Got it? But big companies, all they are using, like they are all using private connectivity, and this is very costly. This is why if you heard about SD-WAN, na, so वो technology बहुत famous हो रही है. वो मैं बताऊंगा. I'll take SD-WAN class also. I'll give you idea and CCNA only. So those who are watching this on YouTube, they must be thinking what's going on. This is CCNA. इनको लग रहा होगा NA में इतना कुछ है क्या?
Right.
Okay, yeah, it depends. It's there. It depends on the like who is training, right? Simply.
Right, sir, right.
Okay, starting with today's topic, which is InterVLAN routing. Here is using InterVLAN routing in your network, right? But the packet flow of packet flow of InterVLAN routing really clears your doubts, or the way how exactly the packet forwards. Okay, this is like, you know, InterVLAN routing. Now, what exactly is InterVLAN routing is nothing but a switch on which this is, let's assume, is my PC1 and this is my PC2. Okay, and this is part of 192.168.1.0 network /24, and this is 192.168.2.0/24. right? Now in this case, if this switch is acting as an L2, will they be able to talk to each other?
No.
Correct. Because with respect to two different subnets, we will end up configuring them in a different VLAN. Let's assume this is VLAN 10 and here we have configured it to be VLAN 20. Even if we configure them in a same VLAN, let's say even if I have configured it to be in a same subnet, same VLAN, still because they belongs to different subnet, the communication won't occur. This is a reason we need this specific concept of inter-VLAN routing. Now, a question to you is that what if I make this switch as an L3 switch? Will they communicate to each other?
Yes.
Is there any so now when I say I use these two specific terms here, one is L2 switch and one is L3 switch, right? Now what is the difference between the two?
L2 has routing part, but L2 doesn't have the routing.
Exactly. L2 only works on frame forwarding, right? Whereas L3 would work on routing of packets plus switching of packets, right?
Yes.
So L3 switch is capable to do routing as well as switching at same point of time. Clear till now?
Yes.
Okay. So now a very simple question that if I create this specific topology, okay, this is PC1, this is PC2, this is switch 1, this is switch 2, okay, we have trunk in between. Here we have these two PCs which are part of same subnet, which is 192.168.1.0/24. Both belongs to same subnet, okay?
Okay.
Here I have configured this, both PC1 and PC2 are part of VLAN 10, okay? And this switch is also acting as a L3 switch, okay? This is not L2 switch. Here also this is a VLAN 10 interface. Now my question to you is, when a frame will traverse or when a packet will traverse from PC1 to switch 1 and it is trying to communicate to PC2, will this switch do the routing of the packet or switching of the packet?
Switching of the packet.
Switching.
Okay, exactly. Because Vishal, you're on mute, so I'm specifically asking. This is clear that this would do the switching?
Yes.
Perfect. Now let's assume I connected one more PC here, which is PC3, and here PC4. Okay. And I configured them in VLAN 20. And here also I configured them in VLAN 20. Now, PC, and here let's assume the subnet for VLAN 20 is 192.168.20.0. Now, when PC1 will try to communicate to PC4 or PC3, okay, either it is this communication or it is this communication, will switch 1 do the routing of that packet or switching of the packet or switching of the frame, I would say?
Same. It will be on switching.
No, it will be routing.
Here is a confusing part. You know, whenever we are communicating between two different subnets, the packet ideally is routed. You know why? Because it will refer the routing table to find out how to reach out to the specific destination.
Yes, but yes, it's need to identify the VLAN in this case. Identify the VLAN with the IP address as a gateway.
Yeah, absolutely. There is a gateway. This is acting as a gateway. So switch 1 will have SVI for 10. Switch 1 will have SVI for 20 also. That's not a problem. So from that perspective, whenever we ideally communicate between two different subnets, okay, the packet is routed, and whenever we communicate between different same subnet, the packet is switched. This is the biggest difference. Now, you understood what is the difference between an L2 switch and an L3 switch?
Yes.
Clear till now?
Yeah.
Okay.
Yeah, because there is not much theory in this. All we will be doing is lab, and then eventually at the lab, I will show you everything. Okay?
Okay.
Let's move to lab. Okay, and regarding yesterday's topic, what I already had told to Ajay, Vishal, Mustafa, you are not there. What we were talking about yesterday, it works. I had given you a homework to check from VTP perspective. We will be talking about that at the last of today's session. Okay.
Okay.
Okay, so we will keep the topology simple. I will add 3 switches. Yeah. We will consider, we will work on 2 different topologies. Okay. This is from L3 as well as L2 forwarding perspective. And then we will eventually, if we have enough of time, we will also check the internet connectivity. Okay. Another thing, what we need to consider here is, what is the purpose? What is the use case of InterVLAN? Can anyone tell me?
To communicate between 2 VLANs.
Exactly. Yeah. So
2 or more VLANs.
2 or more VLANs. Now, why we need to do that is,
So VLAN radius the broadcast. That's why we are.
no, why? What is the purpose of having a communication between different VLANs? In what scenarios do you do that?
To local communication.
Yeah. So let's assume that I have this specific requirement of this is, let's assume this is my database server, and this is my web application server, right?
Yes.
And they both needs to communicate to each other, right? So in that case, ideally the InterVLAN routing is what we use. So you can say, if we consider this as a directions, if you read any of the documents, you would see they talk about east-west communication or south-north communication, right? If you haven't, let me tell you what is east-west and what is north-south communication. Any traffic which is going from down to up or up to down is considered as a north-south or south-north traffic. Okay. Clear?
Okay.
And like you are going towards internet, let's assume this is your internet connectivity sitting outside in the public cloud or internet, and you are trying to access it from your Windows 7 machine, that would be north-south traffic. But whenever you are trying to communicate between 2 different data centers, that is a east-west traffic. So whenever you will read something about east-west or north-south, this is the basic concept behind that. Okay.
Oh, good one.
Make sense?
Yes, yes.
Now, in this case, with respect to InterVLAN routing, packet flow is most important. Okay. And that is why I'm going to cover 2 different scenarios here, which ideally, I could do it in one, but I wanted to give you more and more and more. And I just want to make sure that you know in depth about InterVLAN routing, because this is one of my most favorite question to find out about candidate, how much clear understanding he do have or she do have about packet forwarding. Okay.
Okay.
So here, my switch 1 is going to act as a L3 switch, or you can say multi-layer switch, where we will have L3 gateways. This one. Okay. and my switch 2 and switch 3 is going to be acting as a layer 2 switch. So my Windows 4 and Windows 6 machine would be part of VLAN 10, and Windows 5 and Windows 7 would be part of VLAN 20. Do you want me to make any kind of changes in this?
It's okay.
Okay, there is some chat. Which topic we will cover today? It is InterVLAN routing, Vishal.
Okay, sir.
And from today, I will try to create the configs in Notepad so that you can keep them handy with you. Okay, regarding the subnets, the IP scheme what we will use is first IP would be always on the gateway, okay, of the subnet. Okay, this is there. Let's power on these devices. Okay, so we have 3 switches here, right? What would happen in this case? Any other routing protocol, any other protocol would work from layer 2 perspective?
STP, I think.
Yeah, so if STP is going to be there, there would be a root bridge, right?
Yes.
So let's assume it would totally depend on the priority and all those things, but let's assume switch 1 is my root bridge, and then eventually one of the link between switch 2 and switch 3 would end up into the blocking state. Okay. we will start from downstream. We will configure the IPs on the Windows machine, or let's do it other way. Okay. Okay, on switch 1, what exactly we will configure? First thing is we expect to configure VLANs, right? Or I would say VLAN 10 is name is ma sales, and VLAN 20 is accounts. Clear till now? Oh.
Yes, yes.
Okay, with the help of range command, I will configure this ports as trunk. Anything? Tell me.
Why it is trunk? This is not no.
Sorry.
Zero switch. Oh, yeah, okay.
It is on switch 1.
Okay.
Okay. This is switch 1 configuration, what we will paste here on switch 1. I'm making it on Notepad so that I can, pass it to you later on. Best option is to give switch 1 name. Okay. And all I have to do is, I don't know if I can really copy paste in this. If not, it would be a problem. Okay. I really think I have to, type everything, but it's fine. VLAN 10. name sales, VLAN 20, name accounts, interface range Ethernet 0/0-1, switch port, trunk, encapsulation .1q, switch port mode, trunk. Everything clear till now?
Yes.
Okay. Now I will create SVIs here, which would be acting as a gateways for the Windows machines. Okay. So interface VLAN 10, IP address 10.1.1.1, 255.255.255.0. And this would be no shut. Same way I will create interface VLAN 20, IP address 20.1.1.1, 255.255.255.0, no shut. All good till now?
Yes.
Okay, I can't. Interface VLAN 10, IP address 10.1.1.1, 255.255.0, no shut. Is VLAN 20, IP address 20.1.1.1, 255.255.255.0, no shut. Okay, so a good engineer, one of the important tip is whenever you create any kind of configuration, make sure it is verified and it is up the way we expect it to be. It could be anything. So we made it as a trunk. Let's check that if trunk is up, though we haven't configured on the remote side, but it has become up. Okay, this is good. Everything is there. We have VLANs created. So till now we are absolutely fine. There is no issue. Any other config do you think we really need on this device?
You need to sub interface, no?
Sub interface is required whenever we have a router.
I think we need to enable the IP routing.
It totally depends on older switches. IP routing used to be manually required. In newer switches, you really don't need it. Okay.
Okay.
So if I do show run all IP routing. Okay. Okay. Do you see this?
IP routing.
So by default on the newer switches, newer versions, because no one keeps the switch as a pure L2 or hardly, even on the pure L2 switch, we have a by default IP routing enabled. So from that perspective, it is enabled now. We don't have to worry about it. Okay. All clear till this?
Okay.
Okay. There are some important things what you have to consider from show IP route perspective. Now, what is C and what is L? Can anyone tell me the difference?
C is connected. C.
Yeah, C is connected and L is local. Now, what is the difference between connected and local? Okay.
C is the network and L is the interface IP.
Yeah, exactly. So C is basically the network what you have configured, whereas L is the local IP what you have configured. Clear?
Okay.
Okay, yes. we are moving further. These are the configs what we need on switch 1. Now I am moving to switch 2. If we check our topology, switch 2 is here, right? Yeah. Now all we have to do is create VLANs, right? What is another way what we can configure that we don't have to configure the VLANs on every single device? Yesterday we learned about it.
Sorry, come again?
Yeah. What is another option that we can play with so that we don't have to manually configure VLANs on every single switch?
VTP.
Exactly. I want everyone to, be interactive. Or everyone here must have worked today. So everyone would be a bit tired. So let's make it more interactive, okay? Okay. Do I need to do anything else apart from creating the VLANs on switch 2?
Trunk.
Okay, let's make it as a trunk.
For security purpose, we need to allow specific VLAN.
Let's do it. Switch port trunk allowed VLAN 20, 10, 20. This is good?
Yes.
Switch port mode trunk. Anything else apart from that?
Access VLAN.
Access VLAN, exactly. Switch port mode access. Switch port access VLAN 10. Interface Ethernet 0/0. Switch port mode access. Switch port access VLAN 20. Okay, all good till now? All the configs we have created?
Yes.
I don't know, I can't copy them. So all I have to do is write down the things on my own. Host name, switch to, I am creating the VLAN. What was the name of sales and accounts? Name sales, VLAN 20, name accounts, interface range Ethernet 0/2-3, switch port trunk encapsulation.
20.
Okay, what if I by mistakenly added a single VLAN which is not required? We have to remove it, right? Now to remove it,
Remove.
exactly. Okay, this is the command what you have to use. If you try to remove this specific command, the whole command, there would be a blunder. And if you just do switch port trunk, yeah, allowed is the only command. And then you have to, if you just do 10 and 20, there would be a problem. So what we have to do is just remove allowed VLAN, remove 30. Okay, clear? And we have done all that. So all we have to do is now to configure interface Ethernet 0/1, no shut, switch port mode access, switch port access VLAN 10, interface Ethernet 0/ is it 0/2 or 0/0? Okay, 0/0. Switch port mode access, switch port access VLAN 20. Everything is done, right? So we created VLAN. So this is the first confirmation command that our VLANs are created. We created trunk. This is our confirmation that our configuration is absolutely fine with respect to interface Ethernet 0/3. Okay, hold on. 0/3 is going towards upstream. Let's verify if we have made the required configurations on 0/2. Here on 0/. Okay, everything is good till now. Any doubts?
One command is missing. This is switch port mode trunk.
Yeah, we forgot that. Switch port mode trunk. Let's see if we see it now or it is by default on. It is on now. Okay, show interface trunk. The mode has changed to on. The trunking, everything is good till now. Any kind of doubts? Okay, can we use same commands on switch 3? Do we need to make any kind of changes for switch 3? in terms of configurations, or these are good?
Yes.
These are good, sir.
Okay. Let's go to switch 3. I will configure host name first. Interface, I will create VLAN. Okay, this is good, right? All we have to just configure the ports now, which is in interface Ethernet 0/1 and 0/0. So this specific configuration can be used on switch 3 and switch 2. Let's go to switch 3 and interface Ethernet 0/1. Let me verify. 0/1 is going towards VLAN 10.
Zero by zero, I think.
Hello. Yeah. You know, you have to be vigilant. Good one. And for security purpose, I should be only allowing 10, 20. Okay. All good till now?
You have to configure 0 by 0.
I have to configure 0 by 0. Switch port mode access, switch port access. Okay. I believe I have configured everything on all the 3 devices. All we have to do is just configure this last 4 machines. But before that, I have a question for you. Okay. Here, show interface trunk. Okay. No, that's fine. That's fine. I was just thinking something else. So this is my Windows 4 machine. We will configure it in VLAN 10 and then go on rest of the devices. Okay, I am going to configure this as 4 because my machine's number is 4, Windows 4. Okay. Now, what should be the default gateway here?
1.
Okay, this is 1, right? This is good till now. Now, my simple question to you is, if I ping 20.1.1. Let's assume 100, there is this network. How exactly a packet would be created? If you were in my earlier session of trunk and access, we had discussed about this. How exactly a packet would be created from L3 perspective and then L2 perspective? Any idea?
Let's just host PM destination IP.
Exactly. So I will be doing that. Let me just this flow is important to understand. Okay, so let's assume here on my my source IP here would be 10.1.1.4. My destination IP would be 20.1.1.100, I would say for now. What would be my source MAC and what would be my destination MAC? This is most important. Let's assume the source MAC of this device is 4444. What would be my destination MAC?
The IP address of the gateway. Come on.
You mean to say the MAC address of the gateway?
Yes.
Yeah, and exactly why that happens, because ARP is responsible to send a request in its own gateway, right? So from that perspective, the moment we configure default gateway, if you observe my default gateway and my IP address of the machine belongs to same subnet. This is the logic behind routing. So it will try to send the ARP request for my default gateway. Let's check out if I do have the details of my default gateway already present on the device. Okay, 10.1.1.1. Do you see this?
Yes.
AABB CC. So AABB CC is what I, or let's assume 8019 is what I will give you, give here. So it would be 8019. This is how packet will go. Now, when it will reach to switch to, this specific packet will reach to switch to, what switch to will do?
It will add the MAC, source MAC and destination MAC.
Okay. It
look in the MAC address table.
Exactly, because this is acting as a L2 switch, right? So it really won't know about the details. Now it will check the source MAC address. It will check the destination MAC address. If the source MAC address entry exists in the switch CAM table or the MAC table, it will reset its timer. If the entry is not present, it will do the addition of it. Now, with respect to destination, if I do have MAC entry present, it will forward the packet, or it will forward the frame, because this is layer 2 switch, towards that specific MAC address, right? If it does, if it doesn't have that specific MAC address, it will do the broadcast of this specific frame. All clear till now?
Yes.
Perfect. Let's move. I am going to configure. I have already configured the things here. Let's give it a pub work network and close. Now, can I ping to my default gateway from here? Can I test it?
Yes.
Yes.
This is a verification, a short but sweet verification, I would say. Whenever you make any kind of changes, just do basic checks, so that you know when you want, when at the end of your project, it would be migration, it would be any kind of activity, you would know from where to where connectivity is through. Ping is working, right? Everything is good from Windows 4 machines perspective. Now I will land on Windows 5. Okay, how many of you really know about GARP? This is an additional thing what I try to tell. How many of you really know about GARP? Gratuitous ARP. Anyone? Can you guys hear me?
Yes, but I don't know.
Hey, it's fine if you don't know, just say no, you don't know it. Okay, so you know, GARP is nothing but a proactive information that is provided by your machine to the default gateway or to the rest of the network. Have you ever heard about GARP, or like this is totally new for you? It's totally new, sir. Okay, don't you wonder that we just configured IP address of this specific machine on Windows 5 or Windows 4, and how did it already have the default gateway's MAC address? What do you think? Find out about it. We didn't send any kind of packet to it, right? Okay. Windows 5 is good. Everything is good now. I will configure Windows 6 and then last one. Okay, all we are doing is just doing the verification of the network test towards your default gateways. Now, can I test the connectivity between Windows 6 and Windows 4 from here to here? Can I test the connectivity?
Yes, you can.
Okay, and if the next question is how exactly the packet will flow or the frame will flow. Will it flow like this or will it flow like this?
It is not south.
Flow like switch 1, switch 2 and switch 3.
Okay, and why you think it would flow like this?
Like I think it's in same VLAN.
Absolutely, they are in same VLAN. I totally agree, but you are forgetting one important thing. What would STP do? It would put one of the port in blocking state, right? Hello?
Yeah, yes, sir.
So what does STP would do? It would put one of the port in blocking state out of this three switch topology, right?
Mm-hmm.
So from that perspective, let's assume that my switch 1 is acting as a root bridge. This port would be in blocking state, right?
Okay.
And traffic would really flow from here, or traffic would go all the way from switch 1 to switch 3, switch 2, and then towards the machine. We can verify. I'll be verifying that, but this was the reason I wanted to show you that how exactly the things are quite different than how exactly we assume. Okay, so we will verify who is the root bridge, and then we will check rest of the things. Okay, only last part is left, and then we are good to do all again the topics. Okay, here I go to properties. 20.1.1.7. Okay, another question. If I keep the subnet mask as 255.0.0.0, will my communication work?
Work, sir.
Okay, because
still work.
Yeah, it will still work because it covers your major network. You know, I'm just giving you a refresher about the smaller things. Ping 20.1.1.1. Okay, we are good with the network connectivity end to end. Now let's talk about a flow. I will do a trace. I will do initiate a ping from local machine. Let's assume on Windows 6. The packet will land on switch 3, and then we will check how exactly we are learning the MAC address of my Windows 4 machine. Okay, clear till now?
Yes.
Clear.
Okay. I know what is a MAC address of 504 of Windows 4 machine, which is 04 here. Okay, so all I will do is 10.1.1.4 Okay, I have started the ping. It would be constant ping. There is no doubt about it. The frame or the packet which is prepared from here would have source IP as .6, destination IP as .4, source MAC as, let's assume, 6666, and Windows 4 is 4444. Now this frame will travel on this device, and switch 3 will eventually check where exactly and how exactly I'm learning the MAC address. Now here is where the root bridge or the STP comes into picture, which port is into blocking state. Okay. This is a MAC address of Ethernet 0 by, this is a MAC address of Windows 4 machine, right?
Yes.
And it is learning, it is being learned on which one?
3.
0 by 3. Now, if we go on topology, where exactly is 0 by 3?
Connect to switch 1.
Connect to switch 1. So from here, my packet is going towards in which direction? Right? Because it don't know, it only knows that I have to forward a frame totally depending on the MAC address entries. Now, if you would think that why I don't have an entry present from here, right? It is all because of STP. STP is blocking the port. That is the reason MAC address learning won't also be done on that. And let's verify this specific theory, what we are saying. On my switch 3, I will check. Now we are talking about which VLAN? VLAN 10, right? Ethernet 0 by 2. Do you see it is in blocking state?
Yes.
This is the reason your traffic is forwarding from here to here and then here to here. Clear till now? Any doubts? Because Mustafa, I'm going slow. Yeah, now I would be landing on, InterVLAN routing and all those stuff.
Yes.
Okay. I hope this is easy till now.
Yes, sir.
Yes.
Now I will initiate a ping, let's say from Windows 4, and then we will do a packet walk. Okay. So from Windows 4, I will ping to machine 20.1.1. First, I will ping Windows 5, which is connected locally, and then I will eventually ping Windows 7. So the IP here is .5. The ping is working, right?
Yes.
So how exactly the packet would be prepared now? On my this machine, source IP would be 10.1.1.4. Destination IP would be 20.1.1.7. Source MAC would be machine's MAC address, which is, let's assume, 4444. And destination MAC would be, what would be the destination MAC?
Router gateway.
Gateway's MAC address. So gateway's MAC address would be whatever is a MAC address. It would be, let's say, switch 1's MAC address. This frame will travel from here, switch to, because it is a layer 2 switch, it will only check MAC address, and then it will forward the frame towards which one? Switch 1, right?
Yes.
Now, what exactly will happen on switch 1? Switch 1 will try to check out what is the destination IP address, right? And it will find out that my destination IP address is 20.1.1.7, which is directly connected to me, right? If it is directly connected to me, I should know its entry from our perspective, correct? Everyone is following me?
Yes.
So because I will go on switch 1 now, and I will check ARP entry for my connected route. So in this case, 20.1.1.7 is what I will check. And do you see, because they belong to same subnet, I have an SVI here. I have a directly connected subnet. I know what is its MAC address, right?
Yes.
What this switch will do, it will check that it will forward, it will basically change the destination MAC address. So let's assume this is your whole packet which is received on switch 1. My source IP will be 10.1.1.4. My destination IP will be 20.1.1.7. My source MAC address would be what it would be 4444, right? And my destination MAC would be the gateway's MAC address as it is received. So switch 1's gateway MAC address. When this packet will be rewritten means whatever changes are required, those are done on switch 1. Switch 1 will create a new frame or new packet, you can say, in which it will have source IP as 10.1.1.4, right? Destination IP as 20.1.1.7. Now, what would be my source MAC and destination MAC? This is very important. Tell me, what would be my source MAC?
Yeah, 20.
Switch on gateway MAC.
Yeah, exactly. But there are two gateways MAC, two gateway MACs, VLAN 10 and VLAN 20, right?
Yes.
Which one it would take?
VLAN 20.
Exactly.
Yes.
It would take a source MAC address of SVI of VLAN 20. And destination MAC would be the MAC address of Windows
5.
Windows 5. If you are able, if you can explain a packet flow to anyone, something like this, you know, this shows that your basics are too clear. This is why for me InterVLAN routing is too important. All clear till now?
Yes, sir.
Any doubts? Feel free to ask. I can repeat. I don't have any problem. Okay, I would consider that as no. This topic now, same thing. What exactly will happen? So this specific frame or packet would get received over here again, right? Why? Because on switch 1, it have to check. First, we check the ARP request, ARP entry. I know what is a MAC address now. Now, after that, I will refer the MAC address table to check out how exactly I'm learning the specific MAC address from which interface. What is the interface it is showing? Interface Ethernet 0/1, right? Which is, it is learning from here. Okay, am I checking the right one? Okay, I have to ping I have to check .5, my bad. Let me go again and do on switch 1. I have to check IP address of .5, that is local, show MAC address. Because we are talking about .5, it is getting learned on Ethernet 0/0, which is via your this interface. It is learning from here. It will forward the frame to this specific switch to switch 2, and then switch 2 will check the destination MAC address and it will forward it towards this switch, right?
Yes.
All clear? Now, what would happen on return? So did you understood this important aspect here, that on connected routes, okay, on connected or on whenever you have a directly connected subnet, what would be the first thing checked? Routing table, right? Then it would check your ARP table. You can write this down. Pick MAC address from ARP table. And then last step would be to check MAC address table. These are the important steps from routing perspective whenever you have a directly connected route. This is applicable everywhere. Even if you have this internet connectivity and a user is trying to access something on your servers, when a packet will come from outside and land on this specific switch one will follow the whole same process, because the destination IP is directly connected to me, or in this case to switch one. All clear? Any doubts till now? Everyone.
No, thank you.
Yeah, okay. Now, how exactly the return packet would be prepared? It would be prepared from Windows 5 perspective. Switch. Hold on. Source IP would be Windows 5 machines IP. Destination IP would be Windows 4. Source MAC would be, what would be the source MAC now? Windows 5 MAC address.
Yes.
And what would be the destination MAC address?
Switch on gateway.
Gateway for which VLAN?
20.
VLAN 20. Clear till now? This is how the return flow will be there. Now, the only difference is that when this is how the communication would work from here to here whenever you are trying to ping from Windows 4 to Windows 5. The only difference now from Windows 4 to Windows 7 would be traffic would land again here. No difference. It will only check the MAC address, and the MAC is learning from which switch? Here, right? And from here it would go here and then to the end machine. This is one flow what we have covered. There is another what I'm going to tell you now, and this is more important, and this is more interesting because most of the good interviewers ask this specific theory about InterVLAN routing. Now we are going to remove this specific switch, and we are going to make switch 2 and switch 3 as default gateways. Okay.
Okay.
Okay. So in this case,
Okay.
in this case, switch 1 will have SVI 10 as well as SVI 20, right? And here also it will be having SVI 10 and SVI 20. You must have seen this in your network where you have common SVIs between the two, and then you use HSRP or VRRP between them, correct? Following me?
Yes, yes.
So in that case, how exactly the traffic flows is most important. Let's make the required changes, but before that, let me give you this configs on chat. You can keep it handy with you. So I am switching this device off. And now we will, okay, so let's assume this is not there, and we will only have switch 2. So this is not going to be any more layer 2 switch. Okay, so all we have to do is on switch 2, we have to create both SVIs and give them IP address, correct? What is IP address I should give here? .2 is
1.
fine. Okay, let's give 1. I have created the IPs, which is 10.1.1.1 and 20.1.1.1, right? All good till now?
Yes.
Now I will configure switch 3, and the IP what I have to give here is bit different. So I would give IP address 10.1.1.3 255.255.255.0 and interface VLAN 20 IP address 20.1.1.3 255.255.255.0. No shut. Okay, all good till now? Any doubts? Feel free to ask. Also, what do you think the communication here would work? Because I have configured 10.1.1.1 here on switch 2, and the default gateway from Windows 6 and Windows 7's perspective are connected towards switch 2. Will this communication work?
It should work.
So what exactly will be the role of switch 3?
Switching.
Yeah, pure switching. So we will make the bit change in the topology, but this specific role here for switch 3 will be pure switching. So I am confident that the biggest difference between routing and switching, this specific thing is very clear for every one of you. So what exactly we will do now is, for Windows 6 and Windows 7, default gateway will be switch 3, and for Windows 4 and Windows 5, default gateway will be switch 2. Okay. So this is already present here. So with respect to this, we don't need to make any changes. With Windows 6 and Windows 7, we will make the default gateway to 10.1.1.3 and 20.1.1.3. So Windows 6. The ping is still working. Okay, Windows 6 and Windows 7. Okay, let me clean this up. Oh, okay. The ping is not working. 24. Okay, so now we have to troubleshoot this and check out if the connectivity here is all good and we really have no issues. I will go and do the basic checks.
Still in a block, I think.
Let's check that out. Show spanning tree VLAN 10. It is in forwarding state. Interface Ethernet 0x2. Okay, yeah. Let's. This is a moreover. Let's make the uplink at shut. We really don't need that. Shows spanning tree VLAN 10. This is good, right? We want our interface Ethernet 0x2 to be pinging, to be in forwarding state. So now switch 2 has become the root bridge, and switch 3 has has accepted it as a root bridge. So now from Windows 7, I want to see if I can ping, and the ping is working. Everything good till now? Any doubts? Now, how exactly the communication would work on in a setup something like this? Okay, so now From Windows 4, whenever I will initiate a ping, my source IP address would be 10.1.1.4. My destination IP would be 20.1.1.7. Okay. So the traffic what we are going to concentrate on is between Windows 7 and Windows 4 machine. The source MAC address would be Windows 4 MAC address. Destination MAC address would be what? Can someone tell me?
6 to 10.
Okay, so SVI of 10. When this packet will land on switch 2, what switch 2 will do? Anyone wants to pitch in? Now it is an InterVLAN routing between two switches where you have a lot of switching plus routing. So this is the most tedious thing. If you understand this, you are good with InterVLAN routing.
I think switch 2 will forward the frame to switch 3 via trunk port.
Exactly, that is expected. But the main thing is, what would be the changes done here from source MAC and destination MAC perspective? This is going to be same, right? Your layer 3 is going to be same, correct? You agree with me?
Yes.
What would be my source MAC and what would be my destination MAC now?
So source MAC will be the SVI for VLAN 10 and switch 2.
Okay. Let's assume this SVI 10. And what would be the destination MAC?
SVI for VLAN 20 on switch 3.
Yeah, exactly. Here, exactly, maximum people have the doubts. Okay. Do you agree that on switch 2, I have SVI 20 as directly connected, right?
Yes.
If I have my SVI 20 as directly connected, can I send the ARP request for Windows 7 machine?
Yes.
If I send a request, ARP request, will I get a reply against that?
Yes.
So you mean to say that my ARP will have, or basically my app table will have entry related to 20.1.1.7?
Yes.
Mustafa, you following me?
Yes, I am following you.
Till now clear, right? That
yes.
If it is connected to me, I can send an ARP request, right? Because it is the same subnet.
Yes.
And if I have the ARP entry present for 20.1.1.7, will I also have the MAC address entry in that in switch 1, in switch 2?
No, I don't think so, because for Windows 7, you mean?
Windows 7, yes, Windows 7.
No.
Okay. If again, let me rephrase. Okay, this is my switch 2, this is my switch 3, and this is my Windows 7, correct?
Yes.
Here it is trunk, here it is access, everywhere it is VLAN 20. Okay, I have SVI 20 configured here. I also have SVI 20 configured here, right? This is our scenario.
Yes.
Yes.
Now, if I have SVI 20 configured here, the subnet of SVI 20 becomes connected to me, right?
Yes.
Right.
If it becomes connected to me, do I send, am I capable to send ARP request for that specific IP?
Yes.
That specific ARP request will get originated and sent towards switch 3, right?
Yes, exactly.
Switch 3, what it will do, it will again do the broadcast, correct?
Broadcast, yes.
When it will land on Windows 7, Windows 7 will create a reply packet against that, which would be a ARP unicast packet, right?
Yeah, exactly.
That would be directly sent towards switch 2.
Yes.
I mean, it would traverse through switch 3. There is no denial for that, but it will be processed on switch 2.
Yes.
Following me, this is important. Okay, with switch 2, I have originated a ARP request. It was replied from Windows 7. It received on switch 3. Switch 3 sent it towards switch 2. Right? So switch 2 will eventually have ARP entry, correct? If switch 2 have a ARP entry, it means switch 2 is expected to have a MAC entry too.
Yes.
Yes.
Mustafa, you got me what I'm trying to tell you now, that ARP MAC address are relevant to each other. That's how they pull the data. Let me show you on switch 1. Let me show you on switch 1. Let me clear this up. Okay. Yeah, this is clear. On switch 2, all I will do is I will check show IP ARP 10.1.20. Okay, let's go step by step. This is important. First thing is show IP route 20.1.1.7. You see it is directly connected to me?
Yes.
Yes.
If it is connected to me, I have to check ARP, correct?
Yes.
Exactly.
I do ARP and I see MAC address.
Yeah.
So if I see MAC address, can I check how exactly I'm learning this MAC address?
Yes.
Yes, VPN.
Okay. Do you see I'm learning it on Ethernet 0x2?
Yes.
Where is Ethernet 0x2?
Next.
And
going towards switch 3?
Switch 3, yes.
Right? So,
yeah.
Okay, switch 2, I have to go. Yeah. So it means that I know that if I want to reach, Windows 7 from switch 2, I have the MAC address already present in my table, right?
Yes.
So if I know the if I know the MAC address, will I directly forward the frame destined to Windows 7, or will I still send it towards switch 3?
Towards switch 3.
I mean, who would be the destination MAC address? It would go to switch 3.
Destination MAC address will be Windows 7, I think.
Exactly.
Windows 7.
This is the difference. This is where this is where your routing and switching concepts gets too cleared, that there would be two switches which are having same SVIs. Okay, this is Windows machine. Here also I have SVI 10. Here also I have SVI 10. Even if both have SVI 10s, both will exchange the MAC address of Windows 7, because underlay is still L2, and that's why this switch acts as a L3 plus L2. It's not only L3. What you are telling me is absolutely correct. If you are using, instead of this switches, you were using a pure routers. But that's not InterVLAN routing. That is a pure routing scenario. Are you following me?
Yes. But I think when I initiate the ping for the first time, okay, it will be learned through the SVI VLAN tier, right?
It would be what you said.
When I first initiate the ICMP.
Okay.
From Windows 4 to Windows 7.
Okay.
The ARP will be learned through the SVI VLAN 10 for the first time.
No.
And after, okay.
No. You know why? Because when it will check the destination IP address, it will be part of VLAN 20 only. And the broadcast, the ARP broadcast would be initiated only in VLAN 20. You getting my point?
Yes, I got it.
Something new you learned today. This is I believe so. From here, when a frame is received on switch 2, my source IP is 10.1.1.4. My destination IP is 20.1.1.7. My source MAC address. Now, who would be my source MAC address? Will it be SVI 10's MAC address or SVI 20's MAC address?
10.
Okay.
Yeah, it is. Yeah, in perspective,
about
switch to your.
Yes, from switch to have two SVIs, SVI 10 and SVI 20.
It is source MAC as SVI 20.
Exactly. My source MAC address would be of SVI 20. You know how exactly a source MAC address is decided? From the exit interface. So this packet will exit on under which SVI? Under SVI 20. And that is the reason it will take source MAC address of SVI
20.
And who would be my destination MAC address now?
Windows 7.
Now this frame will traverse from here to here, right? What switch 3 will do? Will switch 3 make any kind of changes?
No change.
So this is same. Everything here is same, in short. Correct?
Yes.
Enjoying?
Yes.
The frame would be received on Windows 7. Windows 7 will create a reply packet now with source IP to be 20.1.1.7, right? Destination IP would be
10.4.
What would be source MAC address?
Win 7.
Windows 7.
And what would be destination MAC address?
SVI 20.
SVI 20 of which switch?
Switch 2.
Are you sure? Because I would be
Switch
sending
3.
packet to my default gateway.
Switch 3.
No, switch 2 because it's already learned the MAC address via the SVI VLAN 20, right? And switch
Absolutely.
Yeah.
Switch 2 will learn the MAC address of VLAN 20, but when a reply packet is created, so what switch 2 will, what Windows 7 will do? It will check the source IP and destination IP. They both belongs to different subnet, right? And if they belong to different subnet, where exactly the packet will be sent?
To the gateway.
To the gateway. So in that case, who is a gateway for Windows 7?
SVI 20 and switch 3.
Okay, so where exactly the packet would be sent? Or who would be acting as a default gateway or destination MAC in this specific packet?
Switch 3.
I want Mustafa to be clear on this.
Yeah, switch 3.
You clear? You are understanding, right? If you are
Yes,
not,
yes.
I am ready to explain you again.
No. It's understood.
Okay, so now let's change the color. And this specific packet will, when it will reach on switch 3, okay, what will be the changes done on switch 3?
20.
What will be my source MAC now?
Switch 3 SVI 10.
The gateway of the SVI 20.
Now
Yeah.
check the destination IP again. The whole process will be repeated. Who is my destination IP?
Destination IP is Windows
4.
Windows 4. Yeah.
So Windows 4 is a part of VLAN.
Yes. Yeah. Reply. Okay.
Yeah,
VLAN,
it is a reply packet.
VLAN 10.
VLAN 10. So what would be my source MAC address?
VLAN 20.
You sure? Because again, I have created SVI 10 here too, if you remember.
Okay.
Right? So again, on switch 3, it is directly connected to me. Correct?
Yes, exactly. Yeah.
If it is directly connected to me, what would be my source MAC address? Here it was SVI 20, right? I have SVI 10 and 20 present on both switches. So what would be my source MAC address now?
SVI 10.
Rest of the everyone, Vishal, Bikash, Ajay, you are very clear about this, right?
Yes.
Okay, perfect. So this would be SVI 10. Now what would be my destination MAC address?
Windows 4.
Bikash, you can tell me. Vishal, what would be my destination MAC address? Because we are almost done with InterVLAN routing.
Windows 4.
Yeah, it is going to be Windows 4, but I just want everyone to participate. Okay. I just want to make sure everyone understands what I'm trying to tell. When frame will be received over here. Now, another question to you. When this frame will be prepared, it would be switched to this guy. From trunk perspective, there would be tagging. It would be received over this. A question now, what exactly switch 2 will do with this frame? Will it make any kind of changes in it?
No change.
And the reply would be sent over here. And this is how your end-to-end InterVLAN routing works. Any doubts?
No, it's clear.
Okay, because we are done with today's session. The configs are quite simple, right? Everyone is aware about it?
Yes.
I have already pasted the configs from switch 1 perspective. Switch 2 and switch 3 are like just same SVIs created. Most important things here are how to check out the flow. You can listen to the video again, write down your notes. I would still try to give some.
You can upload the note in our portal. That will be better.
Okay, I don't have really any notes. I will be typing in front of you.
No, this note.
Which one?
Hey, this one. You're typing now. This
Okay.
note you can upload in our portal.
I will save it. I will ask Gaurav how to upload and get it uploaded. So I'm just adding the commands what you can use. Okay, and any directly connected routes will always have ARP entries unless end host is off down. For routing. Also, one of the most important question I want to ask everyone in routing, whenever a packet is received on a router or a switch, does it check for source IP? Does it check for destination IP, or does it check for both?
Destination IP.
Exactly. Okay, yeah, any kind of doubts? Ajay, Bikash, Mustafa, Vishal.
No, sir. It's
clear.
It's clear, right? Because your voice is low, but I am hoping that you said it is no. Okay, this is from reading this, it is quite understandable.
Yes, sir.
Yes,
sir.
Okay, yeah, you can practice the things. We will be covering another topic tomorrow. All good with the InterVLAN routing, right? If anyone asks you in interview about packet flow, I am hoping you should be able to answer every single detail about it.
Yeah, it's clear.
Okay, perfect. I am happy that I am able to tell something to you guys. For tomorrow, I am hoping it to be Ether channel. So be tuned. Let's meet tomorrow at 8 p.m. India time. For Mustafa, I believe it would be 5:30 or 4:30 for you.
Yes, exactly. 5:30.
Perfect. Okay, we are good now. Have a good night.
Okay,
Study
sir.
more.
Sir, this note please share on any
I will
portal
upload. I have saved it. Just try to copy paste in your local computers too from the chat, and I will speak to Gaurav and add this in the portal.
Yeah, because we are using in mobile, so that's very difficult to copy.
Oh, you're in the mobile. Okay,
Yeah,
interesting. Okay, then I have also have to save the configs of other switches. Try to connect from laptops, guys. This is for your career.
Yes, sir.
Okay, this is, I know it is quite tiring, but somehow sometimes we have to put some efforts to get a best out of our own life. Mustafa, you were asking me something. Please shoot.
Yes, please. I want to have some brief clarification about the CIF and the FIB.
CEF and what you said? What was another
FIB.
one?
FIB.
FIB.
Yeah.
FIB you said, right? Okay.
Yes.
Okay. Okay, it is not getting copy pasted. That's fine. Okay. What is CEF and what is FIB? You know the full form of Cisco Express Forwarding? Or what exactly is CEF's full form? It is moreover Cisco Express Forwarding, right?
Okay.
Right now, you can say FIB is nothing but a software entry. Okay. But CEF is nothing but a hardware entry, which is generated whenever we are using Cisco device. Okay, so how exactly the whole process works is, what would be the first thing? Let's assume we are running EIGRP as a routing protocol. What would be the first thing happening? Tell me.
Routing table will be built.
Exactly. After that, so before routing table, neighborship would be built.
Neighborship, yes.
Yeah. After neighborship, topology table. Exactly. Yeah. After that, topology table will be built, right? After topology table, what exactly will be built is
the best
from
route
topology, the best route would be pushed into your routing table.
Routing table, yes.
After routing table, what exactly it do is it tries to create the hardware entry on the device. Okay, this hardware entry is it helps you to do the forwarding of the packet at very faster level, or at a very faster, let me try to tell you something, how exactly any of the packets at older older iOS or newer iOS works. Okay, so whenever, let's assume these are two switches or routers or whatever you want to consider, switch 1 or router, switch 2 or router, doesn't matter. Divide this whole thing into, divide this switch or router into two parts. Okay, first part is your control plane, right? Yes. Which is nothing but a CPU. And second is a data plane, which is nothing but your line card, or you would say DFC card if it is a modular switch. You know, any kind of modular switch it would be 6500, it would be 4500. All these are line module cards. Now with respect to DFC, what is a full form of DFC? Is a distributed forwarding card. It have its own intelligence. First of all, the step one here would be neighborship, right?
Yeah.
Then it would be topology creation. Locally, you exchange everything under the neighborship. Second would be topology, right? After topology, this whole process of neighborship, topology, and everything happens where? In the CPU.
Control plane.
Control plane, right? After that, EIGRP, local switch to router, doesn't matter who it is, will forward or select the best path and push it into its which table? RIP table. What is RIP?
Table.
Routing.
Information base.
Information base. Correct?
Correct.
From RIB, ideally, the things are pushed into your hardware entries. Now, these hardware entries are nothing but your FIP table. Okay? Whereas Cisco Express forwarding is nothing but a way this whole process works. So in short, I would say that there is a hardware entry created on every prefix. We can give a try. I don't know if it would work on this, but I want to show you. If I have, let me pick a new router here and we will try. I don't know. Let's give a try with this if it really works. The moment if we check now, Mustafa, if I do show IP route, okay, I haven't configured any of the IP addresses, correct?
Exactly.
That's why we see nothing. Now, if I configure any IP address 10.1.1.1, 255.255.255.0, if I do show IP route, you see an entry present here?
Yeah.
Now, if I do show IP CEF, okay, CEF is nothing but a hardware entry, okay?
Yeah.
Do you see something like this? So this is a differentiation, what I was trying to tell you, that sometimes from RIB, okay, this is again a pen. From RIB, an entry would be pushed into the hardware. And you must have seen that Cisco ends up saying that there was a hardware entry or adjacency was the defined, what you can say, the specific entry was not present in the hardware. Have you heard something like this from any of the TAC engineer?
Actually, no.
If you have opened up any of the cases with Cisco, you know what exactly they do? That if you check the routing is absolutely built correctly without any problem, but still you are not able to forward the traffic. Have you seen something like this?
Yes, yes, yes.
Right. And in that case, what exactly happens is that your control plane is built correctly without any problem. Here, okay. The control plane is built absolutely correctly without any problem, which is this topology. Then rib is built correctly, but the hardware entry is not, hardware entry doesn't get defined properly. One of the simple example of this specific is, if you have a route flap happening, the process would be, what exactly would happen in route flap in EIGRP? Tell me. Let's assume that topology gets refreshed, right? If your topology gets refreshed, your rib gets refreshed. Correct?
Correct.
If your rib gets refreshed, your hardware table, or your hardware entries on that specific line card gets what? Refreshed. What is a refresh? Removal and re-addition. Now the algorithm behind this specific hardware thing gets broken because of some kind of bug. It could be a hardware limitation. There are VLSI, moreover a chipset issues. I am not really the hardware guy, but just trying to tell you a generic thing from CEF perspective and or the hardware perspective. So from that perspective, when this gets broken, the entry is present in the routing table, but the hardware entry is not present. And you can check this with the help of this specific command, show IPsec, what we just ran. And if we go very specific, you should be able to see more details in this. Okay. You see it is there are different flags to it which is attached and connected, whereas on which port it is connected, it shows that. If we run a pure routing between this two, then you would see it is getting learned via EIGRP or OSPF or whatever routing protocol you run. Let's try to add any static route and see how exactly we see the entry. I would do it for default route 10.1.1.2. show IPsec 0000 /0. Okay, and if you see, it is detail. Okay, now you see with respect to this, it is showing that it is connected to fast Ethernet 0/0. Now you could go more and more from this is moreover a data plane entries, Mustafa. But here is my point. Every hardware have a different mechanism. Okay, if you go to Catalyst, it have a different mechanism. If you go to Nexus, it have a different mechanism. If you go to XR, it have a different mechanism. So from learning perspective, learn control plane. That's what I have learned, that always go for learning the control plane, because tomorrow if the hardware will change, let's say that tomorrow you are working on Juniper, the platform behavior would be different, correct? But the technology behind that would be still same.
Still same, yes. So
right?
So it's about about the hardware inside the router.
Exactly, it is more about the hardware rather than a software thing. The technology remains the same, but the hardware entries may get changed. So when I was working with Cisco, I used to own the platform of 6500 and 7600, and from that perspective, the way we used to do hardware troubleshooting was different. ASR 1000 was a different platform. The troubleshooting mechanism behind that from hardware perspective was different. So if you are thinking to learn in, let's say you are working in XYZ company, and that company today is using any platform like ASR 9K, for example, and tomorrow they come up with CSR or what is another platform, that 5500 platform. So all things would get changed. And from that perspective, what you would do? Again, you would end up learning a new hardware, right? So that is the reason I don't prefer to learn hardware on personally.
Okay.
At the end of the day, it is your choice. But my job is to tell you something which would surely benefit you from learning's perspective.
Okay, I got the idea. The idea is behind the hardware and the algorithm inside it.
Exactly.
Right. Yeah.
Exactly.
Yeah.
So always learn, always have an intention to learn the control plane as compared to the data plane.
Okay. Okay. Thank you very much.
Perfect.
Perfect. Perfect. Thank you.
Anything else, or we are good with today's topics?
No, it's good.
No, sir.
Good, sir. Very good, sir.
Okay, I hope you enjoyed InterVLAN routing.
Okay, so we'll show you some basic stuff that you might have done in your CCNAs, but I'll show you a little bit deep, so you'll understand what exactly we are going to do in the CCNP. So you can see right now these are the two devices, two routers, 7200 series devices. Let me get connected with these two. So I'll be connecting with them with the serial ports, which is point-to-point link. And okay, let's start it. So let's start configuring it. So guys, what I'll do is you all have gone through with the protocol called RIP, right? So today I'll show you few things that you might have not gone through or you might haven't heard before for RIP protocol, RIP version 2. So RIP is actually you can say it's completely legacy actually. But it is a open standard protocol which can run on any network device, not even Cisco. You can run on Juniper's or any of the network devices like the Ruckus, like the Aruba. You can HP, Dell. So RIP is the protocol, but still the RIP version 1 is gone away nowadays, but RIP version 2 is still there. So let me just start configuring these two routers and you'll understand some of the basic. So I'm just configuring the interface serial 2x0 and just assigning the IP address. So first of all, you might have you must know about that RIP version 2 is your classless protocol, which understands VLSM, right? Variable length subnet masking, which understand these two, and the RIP version 1 doesn't do that. RIP version 1 will not support that. So let me configure this device R1 as classless only. Let me say IP address 192.168.1.1, and I'll be configuring as /30 between these two. So 252, right? No shutdown. And I'm taking for the backend networks, which I'll assume that it is coming from our LAN side. So I'm just configuring two loopbacks over here. So loopbacks are the virtual interfaces. You already must have know about it. So interface loopback 1, and I'll be saying something called 1.1.1. And I'll be taking this as also a classless one because I'm taking as a /24 value for this, but it's actually a class A1, right? That's it. And let me take one more loop back. Let's say loop back 2, IP address 2.2.2.2, 255.255.255.0. I'm sorry, what was it? I went into the loopback, interface loopback 2, IP address. Let's take it as one. I'm sorry. Yeah. Okay. So loopbacks, you don't have to do no shutdown because in the routers, all the interfaces are by default administratively down. So I'll say show IP interface brief. You can see I have just configured the interface for R1 for the serial interface. And you can see over here, this is showing that it's up, but it's showing the protocol is down. The reason being this other side is not configured yet, or even might be the cable has some issues. So if you see protocol down, that means there is some issues with your point-to-point protocol, which is by default working as a HDLC protocol behind this PPP link. You can say the serial link. So let's start this router. Let's configure this R2. Let's wait for it to boot up. Yep, it's here, config T. So I'm just configuring here also interface serial 2x0 and say IP address 192.168.1.2. And as I'm taking this as a /30, so 252, no shutdown is mandatory. But in real environment, you must have to do give the clock rate to sync the serials, right? But as this is a virtualization, so it's not required. This link will come up. If the clock rate is not there, then it might show you the protocol down other side. So that's the one thing. Let me configure loop back here also. Let's say loop back 1. Here I will give the IP address of 11 dot right. I'll take this as also as /24. Interface loop back 2. I'll take it as a 12. So this I'm taking just to have some networks available when we'll run the protocol to see in the routing table, right? So router maintains the table that is called routing table, right? So I'll say show IP interface brief here also. So guys, right now nothing is running, and as it is point-to-point links, they can communicate with each other. But if you try to ping from R2 to their loopbacks, it will not communicate. So just first of all, let me ping to 1. So it's pinging the R1. But if I'll try to communicate the loopback, which is 1.1.1, you can see it will not ping that one. The reason being there is no routing protocol running, so you can see it's not pinging. And let it be, and let me go to the R1. And if you see the command, if you see the command show IP protocols, which will show you the which all protocols. So nothing is running right now. And if you'll say show IP route, you can see there is no routes apart from the connected one, which is connected. Those only the routes it's showing right now, right? So let me run RIP over here, and then I'll show you a few things. So the router RIP, and as I'm starting the version 2, right, and let your things advertise the network 192.168.1.0, which is your network ID, and let me advertise my loop bags as well, and say 1.1.1.0 and network 2.2.2.0. So you can see right now I have ran the RIP right now. So if I'll say show IP protocols, okay. So yes, please mute. Yeah, please mute your mics, guys, whoever has switched on mistakenly. So you can see, guys, here, if you see RIP protocol, it is telling you that right now the RIP is running, and it is advertising these networks. It is taking by default all network as a class full because we cannot, there is no procedure of giving subnet mask over here while advertising the network or the wildcard bits. We cannot assign like that. Oh, font. Let me increase the font. I'm sorry. Change settings. Appearance. Okay. Now you should be able to. Let's say bold. Apply. Now it's fine. Okay. So. So yeah, what I was showing you is let me again run show IP protocol. Okay, so sorry, show IP route also, or show IP protocol. Okay, so you can see right now it is running this one, and the AD value, which is 120, and you can see it can send version 2 packets. So version 2 packets means it will be only able to send you the multicast address, which is 224.0.0.9. And if you want to see, I don't know you have seen earlier or not, I'll show you that with the help of debug. But always remember that debug is not something which you run in the production environment, right? Because debug take a lot of processing powers and all. So you must have run like in a change window or in a downtime. You must have taken that, and then you will be running these debugs and troubleshooting the enterprise network. But right now, as we just want to understand how exactly things going on, so we can do the debugs. So so as I told you, that RIP version 2 sends the multicast address and the update and the multicast address, and it only sends the periodic update, which means it after every 30 seconds. So you can see the sending update every 30 seconds, which is the update timer of RIP, right? And it will always send the 30-second update. Either the router 2 knows or not, it keeps sending. So it is wasting our bandwidth also. That's why this distance vector routing protocol we don't use in that much environment, because it's not that scalable actually. And one more thing is for RIP version 2 or either the RIP, it supports only 15 hops, means its metric, which is it is calculating, it's only calculating according to the hop count, and hop count is just 15 for this RIP, and 16th will be unreachable, means it will be marking that route as a possibly down route. And after one more like after 3 minutes, it will mark as a possibly down, which is 180 seconds, and after one more 120 seconds, it will flush it down. That is flush timer, like it will remove it from the routing table. But right now what I want to show you is, so first router is running RIP, but router 2 is not, right? So let me show you something. I'll say I'll do the debug IP RIP. Okay, so I am just debugging the RIP packet, so it will show me what type of packets it's trying to send right now to R1 and R2, or to the neighbor right now. So you can see debugging is on. As the update will go after every 30 seconds, so might be the if I'll say show IP protocols, so the next due in 14 seconds. So next 14 seconds you will be seeing the some packets going on. Here it is. So you can see, let me just switch it off the debug, so you can do undebug all command, or I'll say you all, otherwise it will keep coming after every 30 seconds. So I have just switched it on. Let's analyze the debug right now. So you can see it is sending version 2 update on the 224.0.0.9, which is the multicast address. And why it is using multicast address? Because we want not to broadcast, right? Because RIP version 1 used to do the broadcast updates so that everybody listens. But here it is doing the on the multicast. The reason being behind that is, so if interviewer asks you why that RIP version 2 do the multicast, it is because it's want to send the updates to a group or to the person who know that specific language, right? Broadcast means everybody can understand that. But if the second person understand what is 224.0.0.9, then only he's going to take this RIP version 2 update, right? But you can see few things, right? So you can see over here few things. It's sending something by a loopback, and a loopback in our case is, you can think like that. Let me just take some PC over here, and we can think that way, that this is R1 is connected to this virtual PC over here, and this PC is running something 1.1.1 network, right? So, but it is sending the update to this one, right? But here, let's say if some hacker is sitting, if he can like if it is a broadcast, for him it will be very easy to like capture these packets and saying that, oh, I am also router, give me all those updates, right? To stop that, what we can do is we can stop these kind of updates on the loopback also, right? And I'll show you two ways to do that. And let's first of all do one thing. Let's run RIP on another side. But another side, what I'll do is I don't run the RIP version 2. I'll run RIP version 1, and let's see what exactly will happen. Which router will gonna receive the packet. So the update, those. Let me increase the font size for this also. Sorry, appearance change something 14, whatever. Hold. Okay, there it is. So let me show you right now. Show IP protocols. Right now it is not running anything. I'm sorry. So let's say config T router RIP, enter. That's it. And I'll advertise my networks, right? So I'll show you like what networks. So it's this one, and it has something 11.11.11.0, but always remember, because RIP version 1 is classless, so it will not understand this 11 network. It understand as a /8 only, right? So, but I'm trying to advertise like that. So I have advertised. So I want to ask anyone if anyone know about it, if anyone can answer. So can you tell me which router is gonna receive routing updates? Either the both or which one? Anyone? If anyone can tell me. Any idea, guys? You must have done all these kind of things in CCNA, but not that much deep, I think. So anyone know that do R1 going to have routes which is available on R2? Anyone? Yes or no? R2. Okay, so let me, okay, no problem. I'll say show IP route right now. But before that, I want to show you something else. Let me go to this one and again enable the debugs. I'll say debug IP rip, enter. Let's wait for a few seconds. Okay, here it is. So you can see sending the this one. Okay, can you see now another thing? See this guy, this one. So let me switch it off. You all undebug all means I am just switching off all the debugs. Earlier it was showing you this way. Where is my debug packets? Okay, here it is. So earlier it was showing you that that some packets are coming from the loop back itself and which is ignoring, right? The reason behind that, the loop back, which is actually LAN side, which is connected to PC1, though they are also trying to send some RIP packets because we have included them in the network, right? But now you can see this guy is ignoring the packet from the neighbor. It's like 192.168.1.2, which is router 2. You can say illegal version. Can you see this? So this is one of the way to identify either the other router is running the wrong version, or maybe what exactly you have to do. So if you debug these things, you will able to troubleshoot. So the thing is, in CCNP, we will understand each and everything that how we can troubleshoot go in little deeper. So okay, so we have understand that the other person is running illegal version, but still we want to see is R1 is going to receive routes, yes or no. So I'll say show IP route, and remember guys, R1 is running version 2, and if you have seen show IP protocol, so you can say it can send and it can receive only version 2 packets. Are you seeing that? So R1 is going to receive the updates or not? Guys says that it will receive. Prashant said yes. Anjani said yes, but let me say show IP route. Let's see what exactly it have. Can you see this, guys? It doesn't have anything. Reason being, this is the router which can only receive version 2 packets. It is not accepting version 1. Reason being, it cannot understand what is broadcast. It can only understand what is multicast. So guys, those who said yes, they were wrong. So R1 is not receiving any update right now, right? It doesn't have any kind of route available over here. No RIP routes, because RIP stand for R. So you can see there is no RIP routes, only connected routes. So the guys who said yes, wrong. It will not receive. Reason behind it is because this is the version which can send and receive packet only from version 2, right? Not from version 1, because other side is running version 1. But let's see what R1 is going to have. So any guesses, guys? R1 will receive?
Yes.
Why?
I
Answer.
think like yeah, first you check, then I will tell.
No, you just tell me why.
I think like one of the version can receive and send also to other version.
See, yes. So I'll say show IP protocols. So you can see version 1 can receive version 2 packets. Are you seeing this? Yeah. That's the thing. That's the thing. But always understand that, guys. Let's say. So I'll show you. I'll just tell you some of the scenario over here that you might get into in future, or maybe. So right now, this guy can receive version 2 packet. That's what I'm sorry. That's why this guy is receiving the protocols. The routes. So you can see this guy is still receiving. But you can see this guy is receiving those packets as /8 only, right? Because it is running version 1, because it it does not understand the VLSM and the CADR and the classless things. So it is receiving, yes, because it can understand the version 2 packets, but R1 cannot understand the version 1 packet, right? So let's say if I want to do that, what I can do two things. First of all, I can do things is I can either go to these interface and say that please send the version 2 packets from here, means convert your broadcast into multicast and send them to router 1. Or either I can go to R1 and say that please try understand the version 1 packets as well. So before that, where this kind of scenario will comes in, I'll let you know. So before that, you can see these loopbacks, which is representing our LAN, representing our local network, which is connected to some switches and PCs. These loopbacks are also running RIP, but there is no use of running RIP on these. Yes or no? Because they are sending traffic to these loopbacks unnecessarily. The router has to do extra work and saying that, hello, loopback, this is RIP packets. But loopback say, hello, I'm a loopback. I'm connected to LAN. What I do with this? It will drop it, right? So any idea if I want to stop those packets sending to these loopbacks? Any idea? Anyone? Okay, no problem. Let's go to R1. Before that, so I'll tell you about that, what we can do on loopbacks to stop these kind of packets, RIP packets, to stop sending these sites, right? You might have learned in CCNA, but you might be not remembering that. So first of all, I want R1 to accept R2's packets, right? So for that, what I should do, so if I'll say show IP route, you can see this guy is not receiving those RIP packets. So what I'll do is I can go to R1 and go to the interface serial 2/0 and say IP RIP receive version 1. Are you seeing that? What I'm telling this guy is, hey, R1, understand the broadcast on your interface CL 0/2, and let's see, this guy will receive the routes. In that case, your Jamal, K value change. K value is in EIGRP, not in RIP. K value is nothing. K value is metric. Here metric is just hop count. Okay, YJ. So I'll say enter. Now any guesses this guy is gonna receive the RIP version 1 packets or not? Or it is gonna this guy going to have R1 routes, R2 routes or not? Yes or no? Anyone?
It should receive.
It should receive, right? I'll say show IP route. No, it's not there. Any idea? Yeah, here it is. Why it took some time? Because 30 seconds, guys. RIP version 1 does not support the triggered updates. You might have heard about it. Trigger update means it will not send update immediately when there is a change in topology or is update in the routing table. So that's the reason. So RIP version 2 supports the trigger updates, but RIP version 1 don't. So that's why the RIP version 2 sent packet after exact 30 seconds. So that's why we were waiting on the R1, and you can see, guys, right now this is having both the routes which is available in the R2. But here also again a problem that is similar to R1, similar to R2. This guy also having the routes as a class A/8, but these guys are actually have the routes of /24, right? So any idea how should I get these with the help of like /24? Or there is no way, because this guy is running version 2. It supports classless, but still this guy has only /8 values. Any idea? I think you must have heard about auto summary, right? The RIP guys, please mute your mics.
Yes, but this auto summary works in a RIP version 2 also, sir.
Yes, RIP version 2 it works. So what I'll do is, first of all, guys, one more thing. So I'll go to R1 and say router rip and say no auto summary. Auto summary means it will summarize for which is actually running by default, but I will say no auto summary, right? But because I don't want to summarize any kind of routes over here, if I'll say that, let's see, is there any change in routing table? Right now it's not, right? It will take some time. When it will get the update, it will update it. Let's see, it will update or not. But what I'll do is I'll go to this guy R2, right? Okay, so first of all, let's see that this guy is still receiving those routes as a non-auto summary or not. You can see it is not receiving. Why? I have disabled the auto summarization, but still this guy is receiving as a /8. Any idea? See, this guy, now the thing is, this guy can send updates in without the summary, but it cannot receive in without the summary. For that, I have to enable that on R2 as well, right? But for that, I have to run RIP version 2 on R2 as well to disable the auto summarization. Then we'll see what will happen in R1, right? So what I'll do is config t router RIP, and I'll enable the version 2. I'm sorry, router RIP version 2, and I'll say no auto summary, right? Now just check, show IP route. Okay, so can you see this, guys? Now you will be having double routes over here, /8, and this guy will be also having similar like that. It will take some time because it should receive the update over here. But right now, if you can see, this guy is having two routes for 1 /8 and 24, and you can see the timer over here. It is going to expire, guys. Reason being this, because this guy is now running version 2, and I have disabled the auto summarization. So what it has done is it is going to remove these routes from the routing table, because these are the classless updates. These are the classful updates actually, right? And you can see the timer should refresh in every 30 seconds, but right now it's more than 1 minute 33 seconds, right? You can see 2 minute 23 seconds. So I told you that the update timer is 30 seconds, and the hold down or the invalid timer is 3 minutes, which is 180 seconds, right? So once the 3 minutes will over, right now it's 2:34, it will mark this route as a possibly down, and another 120 seconds it will remove this route from the routing table. Show IP route. Okay, 2 minute 47 seconds, 2 minute 53 seconds. Here you go, 2 minute 58 seconds, and here you go, right? Can you see this, guys? Here, woo, possibly down. This is showing as a possibly down route. Reason being that is old stuff now. And let's check about this guy. Can you see this? This guy is also going to expire these routes, right? Because this is also going to expire its hold down timer, which is 180 seconds, which is going to take 3 minutes. So if I'll say show IP route, you can see 2 minute 24 seconds. Once it will be 3 minutes, these routes will go away and the new routes will come up or not. We will see that, right? But
So,
it's,
sir,
yes,
actually, I have a question. Like, we can cancel this stuff now, right now.
Which one?
This timing.
I didn't understood what exactly.
Like, we can interrupt the shutdown of this, RIP.
Oh yeah, you can. For that, see what will happen. You have to enable the auto summarization. Then it will again send the hello packet and it will revive.
Oh no, but it will close, or first time it will close, or it will directly start.
No. Actually, see here it will be 240 seconds and 360 seconds. No, what will happen is if I'll remove this auto summarization, and if the route is possibly down, so it is still in the hold actually, right?
Yeah.
So still in the hold right now it will be. So in that case, what it will do whenever it will be again, if I'll be enable, then it will run the RIP version 1 and disable the no auto summary, and then it will again come up and it will send the hello packet again, or the update packet. the trigger, the periodic update, and then it will revive this route again back, and then it will mark this route as a again the hold down timer, and then remove this.
Oh, okay.
Yeah.
Thank
so
you, sir.
if yeah, no problem. Can you see this? See these things we want to see what we study actually. So according to this, so it is expired right now, and this guy gonna have new routes over here, right? Oh, it doesn't have right now. Can anyone say why that those routes gone? It's not coming up. So I'll show you few things. I'll say debug IP rip. I'll say what exactly happening over here, right? And let's see. Once the update comes up, you can see ignored version 2 packet from this guy and ignored version 2 packet from this guy, illegal version. Right? So okay, I'll say show IP protocols. So right now it is version 2. Sorry, go back to 1. I'll say show IP protocols. See, the reason being is I only enabled it version 1 over here. That's the reason. yeah, right. Let's make it enable, then we'll see. So yeah, so say you all and config t interface serial 2x0. I'll say I'll remove that command. No IP rip version, receive version 1, right? So I'll say now show IP protocols. Okay, now it's receiving this one. So now it should not ignore those packets. I'll say show IP route. It's not there. Wait for that update. I'll say debug IP rip. Okay, ignored source packet. Now why it is ignoring? Still it is ignoring, right? Source address from okay, this is ignored from the loop back only, not from this one. I'll check that, then show IP route. Here it is. Yep. So you can see now these guys is receiving update as a /24, right? Earlier it was receiving as a /8 only. So this is the good thing about version 2 and that summarization. So always you have to disable the summarization. Now I want to tell you another thing is that I showed you that it is unnecessarily sending the packets on the loop backs where it should not. Actually, if some hacker is sitting, it can capture those packets and it will come to know about your routing table, entire routing table. So for that, there are two ways. I think you must have understood about the passive interface, right? So passive interface is something which actually stops sending the update on that interface for the RIP specifically, but it will keep receiving also, right? But it will only stop sending. So there are two things. So if I disable the enable the passive interface on this interface serial 2x0, so what will happen is R2 routes will never receives on the R1 routes never receives on the R2 because it will stop sending the updates for RIP. But I don't want that because I want these two guys have communication. I only want the loopbacks, which is it is sending the packets, right? It should stop sending the packets to those loopbacks. So for that, I'll go to R1 and go to router RIP and say passive interface loopback 0 and loopback 1, or whatever the loopback I have created. I think I have created loopback 1. So it will stop sending those updates to loopback. So passive interface, you might have studied that in CCNA, but passive interface actual use is to stop updates sending to the LAN side, because in LAN side no router is gonna sit, right? Or no person is gonna sit which is going to get the routes from you. So that's why we always enable the passive interface on the loopbacks or on the Ethernet side, or let's say fast Ethernet or gigabit or the fiber optic, whatever is connected to the LAN. On those interface, you always enable the passive interface. There is another way of doing that. So another way of this one is, again, see, right now R1 and R2 is a point-to-point person, and they are sending multicast. Let's say if I don't want these multicast also. Why? Because I want only unicast, let's say. Right? So when so if you can see this debug right now, it can say it receives a version 2 packet from 192. This is unicast, guys. Why? Because it already know this guy is point-to-point and it receives a unicast. But what I'm saying is, what I'm trying to say is, let's say if I don't want to send multicast and I want to disable, I want to make all the interfaces as passive, right? And I want to say that only this guy, only these two guys can send and receive, because ultimately my LAN side, they don't want, because they don't want to send any kind of updates on the LAN side. Only these two routers should send their updates to each other to communicate these PC1 and let's take the PC2. So PC1 and PC2 from R1 to R2, right? Loopback never goes down, that's okay, but the thing is we can configure as a passive interface. But there is two things I told you. So I told you what is on R1, either you configure the passive interface, make the loopback as a passive interface to not to send the updates, but it is gonna still send the updates to R2, which is multicast, because both are running RIP version 2. So I'll show you one new thing. So I think you have learned EIGRP also, where you used to configure the command neighbor, right? Either in OSPF you have configured in neighbor command. Guys, in RIP you can do that to enable that as a unicast. I'll show you how. So if I'll say passive interface loopback 1, obviously that that will become as a passive and will not send. But I'll do what? I will say passive interface default command. You know what will happen with this? All the interfaces will become passive, right? Either it is serial, either it is your any kind of interfaces, these all will become passive interface actually, right? Similar command if I'll give on R2, let's see, 150 router RIP version, I'm sorry, version 2 is already there, passive interface default. Once I do that, I'll say, because see, the problem here with RIP is it is very slow because of the timers. It takes some time, but guys, we can change the timers also. I'll show you, and I'll talk you about not today, tomorrow. I'll talk about the load balancing part of the RIP. Okay, let's say show IP route. So these guys, so can you see this? These guys having these routes, and it's gonna expire that, because 1 minute 13 seconds. Otherwise it should have like reschedule with each every 30 seconds, right? But it is, you can see it is gonna expire. Similarly with this guy, it should be, because I made all those interfaces as passive. Show IP route. Yeah, right now it is 49 seconds. You can see again, it's more than 30 seconds. So these routes are gonna expire soon, because what happened is actually right now, I'm sorry, R1 is not sending the RIP version 1 update, and R2 is also not sending RIP version 2 updates, right? Because I made this as a passive, but they can listen, but nobody is sending. Both the sides is nobody is not sending, right? So if nobody is sending, then nobody is listening. Yes, making a passive interface can only stop outgoing side, but not the incoming. But right now, this also stops sending outside. This also stops sending outside. That's why these routes are becoming down, right? That's why these routes are going to be down very soon, right? So for that, what I'll do is I'll make them as a unicast communication. I'll show you how. So what I want is, let's these routes expire first. Okay, so that you will understand that how the new routes came in back again with the help of unicasting stuff. So these are actually not a part of CCNA exactly. But yes, like it's advanced routing, you can say. It's advanced deep routing for RIP as well, right? So my motive is to show you this kind of stuff is to understand that what kind of deepness you can expect from CCNP, right? So we will go this much deep in each and every protocols and understand the debugs and their packets deeply, and then so this guy is already down over here. So I'll show you something good. So still guys, this is a very good practical actually. Still, I want the communication. If you will ask, maybe somebody sitting on the interviewer side, if you ask them that I have enabled the passive interface on all the interfaces and still I'm receiving the RIP updates, he will say that you are mad. But I'll show you can do that. Okay. So here also possibly down, it will take more 120 seconds to remove these routes from the routing table because that's the flush timer of RIP. Okay, so this guy is disabled. This guy is still there. Okay, so what I'll do is I'll show you very interesting command. I'll go to router RIP and say, I'm sorry, router RIP, enter, and make sure that running version 2, but it is already, and say neighbor. This is the new command you might have not seen anywhere. Neighbor, and I'll be telling, hello, Mr. R2, please become the neighbor with 192.168.1.1. That means I'm telling this guy, if you become the neighbor with this guy, but both side, this command is required. Okay, so I said that neighbor, hello, please become a neighbor. I'll say show IP route. So you can see this guy is also gone. But again, I'll go to this guy and say router RIP version 2, that is already there, neighbor 192.168.1.2. I made them a manual neighbor, and you can say I'm just trying to enable the static routing in this actually. Okay. Okay, so let's see what happens here. This is interesting. Show IP route. Woo, man, can you see this? This guy is still receiving update, right? Why? Because I enabled the not the multicast, guys. This time I have enabled the unicast. If you say debug packets, debug IP RIP, see this. Now if you see the packets, whatever is coming, you will be seeing they will be sending the not the multicast. Oh yeah, this is you want to see, guys. Can you see this? Sending version 2 update on this interface and building the update. That's it. There are no multicast sending between R1 and R2. Got it, guys? So this is the interesting thing then we can do in RIP. So you can understand or you can imagine what we can do with the EIGRP. We can play so much. Still, you can play with RIP more. So you can see, guys, these two devices right now is actually disabled all the RIP updates on all the interfaces. When I made the command passive interface RIP, it disabled everywhere. But just because of this new command neighbor, they are still receiving the updates. Guys, I'm telling you, if you try to tell this thing to someone, he will be shocked. If you try to show him this kind of practical, he will be shocked. Hey, how it's possible, man? Right? Bhumik, in RIP version 2 only, we can use neighbor command, unicast. Yes, not in RIP version 1. Obviously, you can't, right? Because that is already broadcasted. Right? Okay, guys, take care. Okay, bye.
Okay, so when we talk about the access list, what that mean? So let me just a little bit describe about the access list. So access list is just like one of the security method to just either permit the traffic, permit or deny. So based on the your network connectivity, let's suppose you having a router, they having a LAN, and let's suppose they having a WAN. Could be LAN to LAN, could be WAN to WAN, or could be anything. So just I'm taking a very normal scenario, LAN to WAN traffic. So if any LAN traffic want to go on WAN, and we just wanted to allow some set of the LAN subnet can access the any of the IP address, okay, WAN IP address, they can be access, but I want to deny, I can also do that deny also. Okay, so these ACLs can apply inbound. I'll tell what it means inbound and outbound also. So what that means inbound and outbound. So see, this is the router. You can just think about this router. So this is your router. If LAN traffic is hitting on this interface, this is the ingress point. So we already probably you guys understand what is ingress. So ingress, that means my packet is just landing to the router. Okay, so that is ingress. When packet is leaving from the router, that is our egress. So when the packet land on the interface, and when you apply, just you are going to apply the ACL on that interface, that ACL is going to be called as the inbound ACL. Okay, so that could be the inbound ACL. And if you are going to apply it when packet is just trying to leave from your router and go to WAN, and then you're going to apply that ACL and that interface, the out of the interface when packet is leaving, that we call the outbound ACL. Okay, so there is just they are not special term written in the book, but just I'm trying to explain what that means inbound ACL and outbound ACL. So you should know when you talk about the inbound ACL, that means you have to just understand where packet is coming. So it's coming, might be when there could be a scenario. It's not like a hard and fast rule that always LAN is going to WAN. Might be there is a special scenario when your WAN traffic is try to access your LAN. So when the traffic WAN is hitting on this interface, it will become your ingress. Okay, so it will become your inbound ACL. Okay, and when it is trying to leave, this interface will become the egress. Okay, so that will just become the outbound ACL. So you just have to think which direction traffic is coming. It's either to LAN to WAN or WAN to LAN. If it is coming from the WAN to LAN, you can apply the ACL on the router perspective. If it is coming from the LAN to WAN, it can be applied from the this interface perspective, this interface perspective. I'll show you in the live demonstration also, so you guys can understand. And in addition of that, we having a two type of ACL. That the first one is the standard ACL, and the second one is the extended ACL. We'll discuss more about that, what that means. So standard is very limited scope we have, and that only you can just only apply based on the source addresses. Extended can be applied based on the source, based on destination. It's very flexible also. I'll explain. So hope you guys understand about this access list, how permit and deny it is going to happen. I can see someone is saying Sasi is saying he is not understand. Let me just repeat it for him. So Sasi, what I'm trying to explain, if your traffic is landing from LAN to WAN, so you have to just identify what are my ingress interface. So you can see the traffic is going via this direction. Okay, this direction. So LAN to WAN. So this is your ingress interface. This is your egress interface. You can see that. So when you are going to apply the ACL on this ingress interface, that will become your inbound ACL. And when you are going to apply on the exit interface, that is egress interface, that will call as the outbound ACL. So that is one thing, LAN to WAN. Similarly, if your packet is coming from WAN, okay, this direction, so this will become your egress interface. Egress, and when you are going to apply the ACL on this place, that will become the inbound. And when the packet start going out from this interface, that will become the egress interface, and this ACL is going to apply on this interface, that will become the outbound ACL. So that I only explain here. Okay, now we are having a two flavor of the ACL, that is the standard ACL and extended ACL. So let me just go with that. So you guys see that like when we start doing the ACL, so standard is like very easy to deploy, but it's only work based on the source addresses. So what that mean? The source addresses, people are very confused about that, what that means. So I'll explain a little bit more, but just try to understand about this slide first. So access control list, what I explain, that can be used for the permit or deny, and that entry can be manually configured inside of the router and always processed from the top to down. So whenever you just create any ACL, so it's going to check like sequence 1, sequence 2, sequence 3. So it is just try to check one by one, and till the time the condition is going to be matched, it is going to be keep checking. So if the first place condition is matched, so it is processed in the first place only. If not matched, then it is going to check the second sequence. Sequence is not going to match for the second sequence. The statement is not going to match, then it is going to check for third sequence. So might be in the last, either the traffic will be fully permitted or fully denied. So there could be two conditions. In last statements also, always you having such kind of statements, either the traffic should be permitted or should be denied. So if you having defined them some kind of the sequences like permit this and deny this in first and sequence, and it is not matching, source and destinations are not matching in that sequences, they're going from top to down, and it will try to figure out which sequence will I land to just process the traffic. But it is always processed from top to down, one by one it is going to check. Okay. Permit and deny traffic, what I explained based on the parameter, what we have defined. We'll see how it is going to be defined. And also we can use the ACL for the traffic classification in the QS, what we have done. So that ACL can be used for classify the traffic based on the traffic ports number, like DSCP bits based of that, and the marking we can do with the width of the ACL, that can be also possible. So this is about the ACL, some basic. Now, if you are going to deploy this ACL, before deploy, like we should know that only match the source IP address. So what that means, I always keep saying that only understand the source. So why it understand the source? Because every packet, let's say suppose you having, this is the destination IP address. So this is your destination IP address, okay, and this is your source IP address, might be the 192.168.10.10. So whenever we are going to apply the ACL, it is not going to check the destination IP address in the ACL field. It always going to check what is my source IP address, and it match always source IP address, and based on the source, we can just either permit or deny. But if I want to do a match based on the destination, it is not possible in the standard access list. It is only possible in the extended access list. So we'll see how extended list is more flexible than a standard access list. Okay. So in addition of that, if anything you just wanted to permit or deny, it could be either permit all or it can permit deny all. So what that means, it doesn't understand like port numbers, protocol numbers, what I can play to permit and deny. It just understand the IP, and based on the IP, it can deny any all the protocols, whatever like you want to allow 443 or 80, that can be either allow or deny. So this is like limitations of this ACL. So we cannot have much flexibility of this standard ACL. It's very kind of the, what I can say, appropriate word. It's very limited scope we have with this ACL. But in extended, we can do each and everything what we having a limitation in this standard ACL. So I'll explain that side also. So in addition of this, they having a range, that is a normal range, that is start from 1 to 99. Any number you are just taking, that is the normal standard ACL, and that also expanded. So expanded, that means if you want to use this range also for the standard ACL, that can be used for 1300 to 1999. So that can be also used. And the last thing and very important thing, you guys should know that where I should place this ACL. That is the very important thing, because if you know the standard ACL, Can someone mute yourself? I can see someone is not muted and some background noise is coming. Okay. So if, let's say, suppose you are just trying to apply the ACL, but you don't know exact location where I should apply, and let's say suppose you're having a this kind of a topology, R1, R2, and R3. Okay. And the source, this is your PC. This having a source, let's say support 10.10.10. And you having a destination somewhere connected on the server here, that is the 8.8.8.8. You want to apply this ACL, and might be this PC don't want to access, this PC doesn't have, we don't want to give access, like we want to deny this server. Requirement deny 8.8.8.8, but permit rest of the traffic, permit any. So permit any means, like let's suppose on this router again we having a server that 4.4.4.4, and this server again having this router again having one server that is a 2.2.2.2. So these are the three servers. This is the first, second, and third. So what that means, just try to understand. Place as close to the destination as possible. So let's say suppose I just created one access list. Let's say suppose I created an access list. I taken any number from 1 to 99. Let's suppose I taken 80, and I said deny 8.8.8.8 and access list 80 permit any. So what I'm trying to say in first statement, I'm just trying to say, hey, you just have to deny this 80, rest you have to permit. You just created access list perfectly fine, permit any. You just have to, this sequence might be not right. I'll just show the right sequence. So just, I'm giving the example for your understanding, but the first sequence is very correct. Okay. So in first statement, I'm saying access list 80 deny this IP address. That's absolutely fine. You created the access list. In second statement, I'm saying, hey, just permit rest of the traffic. But what happen if I apply this ACL on this router in inbound direction or either outbound direction? So what is happening, because this is a standard access list and match the source address, it is simply deny the traffic. If I apply this router, it is simply deny the based on the source IP address of this, and this particular packet is not going to further process by the router. Either it's not going to access this router, this server, and this server. All three servers will be not accessible because I apply and deny the source in the very first place. If I apply on this place, might be I'll able to access this server will be accessible, but this server will be not accessible again. This is the problem. If I apply here, then probably this server is accessible, but still this is, and this is not accessible. I apply here, that might be this is accessible, but this is not accessible. Okay. But if I apply, let's suppose if I apply here, that is a most appropriate way. So anything, even I can apply here also, but if I apply here, that is the most closest one, then this server is keep accessing by this PC, this server is keep accessing by this PC. Only when packet try to reach on the R3 and try to access this server, it is not going to be accessible because it is very close to destination and rest all the traffic is keep processing. So this is the example why you should apply the ACL and why you should know the location where should apply this ACL in appropriate location. Hope you guys understand about this, what I was trying to explain. Okay, so this is the standard ACL. Let me just go with the extended ACL, then probably go for the lab. So now we're having a extended ACL. Extended ACL is a very flexible. It can match source and destination both IP address. Earlier, this ACL was just matching the source, but this extended having a flexibility to match source and IP address. It is also flexibility to match the protocols and port numbers. That is not possible with the standard ACL. That can we do with the extended ACL. Okay. In addition of that, it's having a normal range that is 100 to 199. In previous, we're having 1 to 99, and expanded range is 2000 to 2699. And this is saying you can place it as close as to the source possible. Earlier it was talking as close to as destination, but this is talking as close to as source, because you having a now flexibility to deny this destination address in the very first place. So if I go and create this ACL and I say deny this one, might be this is my extended ACL. So it is going to check the destination address. It is just going to check a destination address, and like based on the destination address, it is going to be deny that particular traffic. So sorry, earlier I made some mistake, so I apologize for that. Actually, this is not a destination. This should be your source IP address. So this PC IP address 10.10.10.10 not the destination. Okay. So in first statement, you should deny the source. You are denying your source. Okay. Now in second extended statement, you are denying your destination. So this destination can be denied in the very first place on this router, and this other destination is keep processing, because in next statement you are just permitting any IP address. So it is keep going the things. But in first statement, because the standard work on the source base, so source is going to deny in the very first place, and that is not going to process to any of the places. So that's why you have to place as close as possible. So if I place this extended one, so this router, this is going to be deny, and this based on the source IP address, but extended one I can deny in the very first, because this is going to match the destination IP address. So this is how extended and standard ACL is classified to each other. Now let's have a demo about that.
So sir, simply standard ACL is related to source IP address.
Yes.
And extended related to destination IP address.
No. It is extended is based on the source and destination, both can be applied. It's not limited to the any IP address. See, it's very clearly written in this your slides also. See, it matches the source and destination both, but your location of the applying could be the as close as to source extended, and extended one as close to as destination. That should be most important. The deploying the ACL is like if we are
can you visibly your diagram, please? What you have to write? Yes. Here, as per standard ACL, we can apply before R3 router port. It is standard ACL.
Yes. This is standard ACL.
Yes, and when we have put in before R1 router is extended.
Yes, extended ACL.
Here we put is a destination IP address.
Yeah, destination IP address. Destination IP address. In first place, we are just matching the source IP address.
Okay, got it, sir.
Got it. I'll explain. I'll explain. I have a topology. So just we try to do the lab. So let's say this is our topology. Okay, and this topology. Let me just erase this diagram. I hope you guys understand. So in this topology, let's say suppose this is your server. Okay, you have to access. So I want to allow access from this PC and block from this PC. Okay. So let's say suppose this is a switch. I can apply ACL on this, but this is L2 switch. Let's just think I'm not going to apply. So this is my L3 router. I can apply. Or this, suppose this is my server. Let's suppose this is also my router, R4 router. I can apply here also. Okay. So let's consider this is my server. So I cannot going to apply the ACL on this server because this is not possible. But this is the next before server we having one router. Okay. So I can apply the ACL on here. Okay. That is my standard ACL. So I'll demonstrate in two ways. One is I'll try to apply in the inbound ACL and outbound ACL. I will see what is going to be happen in first in the standard. All are okay? We'll see this demo and we'll see how it is going to happen, how the configuration is going to happen. So let me just showcase first how this is going to be very, very basic topology, but your concept should be very clear. This is just for demonstration, but if you understand this demonstration, you can deploy any of the ACL. So let's say suppose I'm on the PC right now. I'm on the PC one. This is my PC. Let me show you the IP address. So IP config. So this PC having the IP address 10.10.10. Okay, this is my gateway. This gateway is configured on this router. See that? And I have another PC that is this having IP 10.10.20. This is also having the gateway. Okay, so that's fine. So right now, let me just ping that IP address of the server. This is reachable from the PC 10. And let me just check the 4.4.4 also. So this is also reachable from PC 10. So you all agree? So you can see this PC 10 means the IP address ending with 10. Okay. This is my PC is accessible. Now going to another PC. This is PC 20. And if I'm trying to ping the destination server IP address, see it is also pingable. And let me just try to again another IP address that is 4.4.4. It is also pingable. So makes sense, right? So right now both PC. This PC is also able to access these servers, and this PC is also able to access this server. So till now, everything is fine. So next step, what I have to do, in next step, I want this PC should block access. Server 8.8.8. I just want to block one server IP at one server, okay? But let's say when I block this source base, the another server is also how it is going to block 4.4.4. I just block one IP address, but my other server is also going to block. And this is going to be allowed. This PC is going to be allowed each and everything. So let me just do this. So I'll go and R1 because there is a two way to apply this ACL. I can apply on this ingress interface. This is my ingress interface. And this is my egress interface. So I can apply ACL either inbound or could be outbound. So I'll first apply the inbound, then again I'll demonstrate the outbound, and we'll see that what is going to happen. So let me just go on the router configuration, and this router right now, let me see someone else. Okay, so no worry, Natasha, I'll give the command and very sequence. I should included the command this time. So I have a command line also in this slide today. Okay, so I just included by today. For I understand you guys pain, so I just included. I'll give the command sequence wise. Okay. So I'm just doing the standard one. So let me just go in the R1, and in this R1, let me show you nothing ACL related things is configured. Say my interface are just plain. Anuj is saying, sir, ingress means inbound, similar way WAN. Anuj, ingress means the traffic is coming from LAN, egress means traffic is going to WAN. So in this situation, this is my WAN router, and this is the this interface Ethernet 0x1 is the egress, and this is the 0x0 is the ingress. Okay. So on this, we don't have any ACL configure. See, so IP access list. We having ACL configure, but that is something related to not Cisco CPA. I didn't configure this. I don't know what is this. This might be the hardcore ACL. See, this is not configured. Might be the box itself having this ACL. I didn't configure. See, my configuration doesn't showing any ACL here. You guys can see that. So this might be the box related ACL. And see, these are my two interfaces. Basically, this router is L3 switch, not a router. I make it as L3 switch. So that's why this ports itself having the no switch port. Because if this is my switch and I want to make that L3 port, then we have to use the command no switch port. Then we can only assign the IP address, else that IP address is not going to assign. So that's why I use the no switch port command and then assign the IP address. During the testing, I found there was some issue in the router, so I use the L3 image to just do that lab. Okay, so just for your understanding. Now what I have to do, the first thing, I have to create one ACL, and in this ACL, I'll say, hey, this IP need to be blocked. 10.10.10.20 should be denied to access the server 8.8.8. That's all. Or I can do in another way. I'll just permit this IP address. I permit this IP address. Hey, just permit 10.10.10 to access this one. by default, implicit deny is going to happen. Okay, so let me just show first case. So what I'll do, I'll just commit this IP address and they see automatically how this is implicitly going to be denied. Okay, so let me just do that. Lokesh, no need to worry. Like if ACL is already configured, if you are doing the lab, you can just delete it. But see these ACLs are like inbuilt in the box, and these are not relevant for anything. These are not calling anything, and these are the useless ACL. You can see that they are just for the saving the box. I'll come on it very next topic, that is a control policy, why this ACL is created.
Sure.
Okay.
Okay. Actually, I checked it on new device. I could also see it some ACLs already there. I thought that someone else has configured. And even I checked in the logs, so no one is showing configured like that. That is the reason I got
that might be the box related ACL, and this is very crucial because of that. This is the next things. I'm just going to call policy. I'll explain what that means.
Sure.
Okay. So the first thing, what I have to do, I have just going to create one ACL. In this ACL, I'll permit this IP address and see. I'm not going to write anything this IP address and see this is going to implicit deny how it is going to be denied. So there is a two way. Either I can just deny this IP address and permit this one, and the another way I can just permit this one and it's automatically going to be denied. So let me just demonstrate first way. So I'm just going to this, and because I have to writing the access list standard one, so I just use the access list, and then after use the contextual help, and then it is saying what type of access list do you want, standard one or extended one. So we are talking about the standard one here. So I use the number from 1 to 99. This is the standard one, or I can use the number from this range. This one, 1300 to 1999. These two are the range of the standard. So when I put any number, router will come to know you are configuring the ACL for the standard one. Okay, so only the source is going to match, right? So let me just use the number is 10, that is belong to 1 to 99, and that's all. And then after I'll put permit, and after the permit I'll put the host name. Okay, so host name, what I want to permit, 10.10.10. Okay, so just going to use 10.10.10.10, and that I don't want to use any wildcast. If I not use any wildcast, it understand as a host, this as a host. If I use the wildcast, that understand as a subnet. So I'm just going to not use any keyword. It is going to understand as a host, or I can just write this way also. I can put host, and then I can put the IP also. Okay, so this is the same meaning, but let me just put just IP address 10.10.10.10, and as I use a log word logs. Logs, what does means anything going to match on this ACL, it will show how many packets is going to match. So this is my access list. So this my access list is created. Let me just show you guys what is I done. Access list 10. So this is my access list. Permit this one IP address.
Hi everyone. Okay, so what is troubleshooting basically, guys? A troubleshooting is a method or a guiding principle that determines how you move through the phases of troubleshooting. Okay, so what is troubleshooting? So troubleshooting is a method like how we will fix any problem if anything happens in my company network. Okay, a troubleshooting method is a guiding principle that determines how you move through the phases, like which will be my first step, what will be my second step. And if you check troubleshooting, so this is always whenever you are a L1 engineer, L2 or L3, so you need to focus on these things. Okay, first you need to understand the problem. What is the problem? Suppose a user calling you from US, suppose you are working in India in HCL, maybe in Wipro, maybe in TCS. So if you are working as a TAC engineer, if you are working as a network engineer, so if user calls you or raise a ticket that my internet is not working. So what we have to do, we need to gather information. So first we need to understand the problem, like a user is not able to get the internet connection. So then we will gather information from user. So we will ask some kind of gather information questions, like what is the issue going on? Okay, and like let me tell you those things also. I hope I have covered these things earlier. Okay, so the troubleshooting approach is like you will ask user to gather the information. Like you will ask it, you can try to check if your computer is getting the IP address. Okay, you should also ask about the location of the issue. You will ask building, what is the floor. So means in the first step, what we will do, we'll try to capture all the information. Okay, the first thing what I told you, like we will define, let me add here. So we will try to gather much information as what we want. Okay, the first step is gather information, and then we will check, we will just use our brain and check, okay, what is the, how to resolve this issue. Suppose a user having a issue like internet is not working. So first what we will do, we will check, okay, so this person is John, his location is London, building number is maybe ABC, floor is second floor, IP address. If user is not technical, then you have to give them instruction. Please go to your settings. Okay, if you are using Windows or MacBook, whatever, so you need to understand the basic of Windows, Mac, and Linux, how to check the IP address on all Windows, Linux, and MacBook. So like in MacBook, you go to the system preferences. Okay, you go to the network, and from there, user can see the IP address here 1.3. Okay, because you cannot ask a user to go to the terminal and write IP if config command here. It will be very difficult for them to do these stuff. These are little technical. Suppose a user who is complaining the issue is a manager in sales. Okay, or maybe manager in some another department. He is not a technical geek. Okay, he's not a tech person. So you need to give them simple instructions, or go to Launchpad, the second icon in your MacBook, then go to the system preferences, then go to the network, and then in the network, you can see the third row, second option, then you see the IP address 1.3. So this is like, first we gather information. Yeah. So we are live, so, but still I have still started recording. So the issue is with the, so now the second question, when you analyze, okay, this user is in building number ABC, he is from London, he is from India, Bangalore, whatever location, then you ask them what steps, what happens, what is the problem, are you able to access google.com, anything. So if we say does it nothing is working, then what you will do, you will ask. So this is very important question, guys. From this question, you will understand the issue is a user issue or the building issue, or maybe the floor issue, or maybe a cabin issue. Okay. Because most of the time when you are a network engineer, you will be going to help the candidates, help the employees of other locations. 80% of IT infrastructure engineers or network engineers, they are going to help remotely. 10 to 20% you are on the same location. Okay. Or maybe, means I'm talking about the guys who are working with big companies, HCL, TCS, because these are service based companies. So if you are a network engineer in the same building and you are catering all these local guys, then you need to check that. So ठीक है, तो मैं ये कहने की कोशिश कर रहा हूं कि इंजीनियर जो हैं वो ज्यादातर बाहर का, यूएस, यूके, इंडिया में जितने भी प्रोजेक्ट्स हैं वो बाहर के हैं, तो ज्यादातर आप काम बाहर के लिए करते हो. ओके, सो दिस इशू इज विद यू. सो आपको क्या क्वेश्चन पूछना है, दिस इशू इज विद यू ओनली और द अदर टीम मेंबर्स आल्सो फेसिंग द सेम इशू. सो इफ ही इज सेइंग नो अदर्स आर नॉट having an issue, it means this is the user issue only. This is the user issue. If we say, yeah, 3-4 guys are also saying their internet is not also working in London building number ABC, if they are also saying 3-4 more guys are saying, so it means this is a issue from maybe a network point of view. Network connection is not working, maybe internet work is not working on building. So it could be a big like a bigger issue. Okay, so try to change. So right now, suppose IP address is coming, but you can ask them. This is not every time you should ask, try to change your computer and all, but it depends on scenario to scenario. So you can also ask, have you faced this issue earlier? This is very important question. Why? Because अगर ये नहीं पता आपको, हो सकता है ये issue उसको 10 बार पहले भी आया. Maybe the same issue he already got 10 times, but you are not asking, so he will not tell you, because every customer think that the support team already know this thing. Suppose your network is not working. Last time what they did, maybe they go to the system preferences, and in the network, maybe the Gmail is blocked in company, and Gmail, Google has a DNS entry 8.8.8.8. So normally every DNS server in companies we also use is 8.8.8.8. Suppose Google is blocked in your company, so this DNS will not work and people cannot access internet. So you need to make sure you are able to ping the 8888 or not. Okay, so I'm just giving an idea. So this class is regarding the strategy, how to troubleshoot. This is not I'm actually creating issue and doing troubleshooting. This is what we already do in the classes. Okay, so check the neighbor computer address. So once the problem is identified, okay, then we will check what is the cause of this. Maybe the DNS issue, just I checked. So that's called eliminate potential causes. So in simple words, first you gather information. Okay, whatever information you can gather, the more information you have, the more it will be easy for you to troubleshoot. तो जितना ज्यादा आपको पता होगा उतना जल्दी आप प्रॉब्लम सॉल्व करोगे. And try always to talk to customer. Try to always check what is the issue. Okay, you got this issue earlier or not. Maybe they will also give a clue so that it will be very easy for you to troubleshoot. Okay. After that, establish a theory. Okay, then just try to think what is going on and just you can use your brain. And if you are a new joinee in company, you can ask your colleagues. Do not shy. Okay, do not shy by asking them. Suppose it's a new guy, like I am the new joinee in any company, maybe HCL. So there is a guy who is sitting next to me, Vikas. So I can always request him, and please make sure when you are a new guy, when you are a fresher, do not actually work in an ego. Always try to take help from everyone, and it's always better to learn from someone. Do not be like that. I am a CCNP guy. I will not ask this. He's a CCNA guy. No. So he might have more industry knowledge than you. Okay. How the class is going? Just wanted to take feedback. Do you feel like it's going better? Okay, so this is not part of CCNA. This is a customized program which we deliver in CCNA. Okay, so we add a lot of things which will actually help you in industry. Okay, Kevin, please check if you are there or not. Okay, so then we check the test, the theory to determine causes. Like suppose a cable is not working in a department. Okay, so you can also check. Suppose, let me tell you, there is a software in CCNA which you can use for basic troubleshooting. Okay, let me show you. So yesterday, which lab we did, guys, in CCNA? Yes. InterVLAN?
Yes.
Yes, sir. InterVLAN.
Okay.
Yes, sir.
I think I forgot to save. This is my old bad habit. No worries. Okay, so let's check. This is a topology we have. Okay, so remember, this is the lab we did. Which lab is this? This was this is a branch head. This was a headquarter, and this is the ISP geo. Right. So this was a default route lab. Suppose this user 2.2 is saying my connection is not working. Okay, or maybe so. Yeah. Okay, so FA01. So he's saying, so let me just create a issue. FA01 is a shutdown. Port is shut down. But user is saying his internet is not working. How you will troubleshoot? So first, what was the step?
You just put the
First, somebody called you, you will check, okay, this is building number A, floor, address. So issue we got in headquarters. This is a head office. Yes or no?
Yes.
Yes,
So this is a head office. Suppose this user is sitting on the ground floor. So you will ask, okay, ground floor. Why we need to know the location? Because we map network devices in company with the floor names. Are you getting now?
Yes, sir.
तो हम कंपनी में जो डिवाइसेस लगाते हैं, so we upload, we change the host names according to the building floors and all. There is a nomenclature. कुछ एक तरीका होता है जिससे नेटवर्क इंजीनियर आइडेंटिफाई कर पाते हैं. We are able to understand, okay, this is a ground floor. So when you ask the location of user, okay, so what is your location? He will say, I'm in head office. Okay, I am sitting on ground floor. Then you will automatically understand we have on ground floor, how many switches we have?
One.
Yes. So automatically you will understand, okay, this is a ground floor switch. Okay. So either if you cannot, so right now you can go to switch and normally you can see, okay, can you check if you are getting IP address? The user will say, no, I'm not getting IP, because most of the companies we have DHCP IP. Prashant, Ankita, actually you are asking some different questions and the class is going for different topics. So you can put down in the comment and we will reply you back. Okay. So, so right now this computer, okay, so if we are not able to check the port, okay, if we are not able to trace, because the device is not getting right. So we need to ask the user if you are getting this, like if this is a Windows laptop or a MacBook book. Okay, so we will ask, can you see this green light? Can you see this MacBook? It is giving a green light here, guys.
Yes, sir. Yes, sir.
Okay, in Windows also you see blue icons in network adapters, right?
Yes.
When you go to network connection in the Wi-Fi or in the cable, what you see? There is a blue icons.
Yes, sir.
Yes, sir. Yes. तो मैं कैसे समझाऊं, रुको. So Windows network connections. ये मुझे कोई इमेज मिल गई. Yeah, I got the image, guy. So now you tell me from this image. Okay, so tell me which Wi-Fi is working. Ethernet is working.
No.
Wi-Fi is working.
Yeah, so in Windows we understand with this way. Okay,
Yeah.
and in MacBooks we understand if there is a red light, it's not working. Okay, and when it's a green light, it is working. Can you see that Wi-Fi is working?
Yes, sir.
Yes, sir.
Okay, and these yellow icons are for VPNs in MacBook. Okay, yellow icons for VPNs, red icons when you do not want to, like if the network adapter is not working, and the green light means the network adapter is working. Clear?
Yeah.
So what I'm trying to say, this user network adapter is showing disable, because when you power off, if you use a cable without the the other side is not connected, so automatically you understand and you will call, because this location we are not in head office, maybe we are sitting in any branch, so you will call a network guy in headquarters. If anyone from network team is not sitting there, what you will do, you will ask normal IT guy, right? The normal IT engineer, desktop support engineer, or the technician. You will call them and check, can you go to ground floor and check the cable number? Okay, there is a cable, suppose this is a ground floor cabin number or area number 1. So can you check all the ports? So he will go to the server room, okay, and check which switch is ground floor switch. This switch? Yeah, this is the ground floor switch.
Yes.
Okay, then it will say, sir, there is no light on that port. Can you see the second light? Cable, you can see, right? So you will see there is no light. You can check. And then you can also check in simply, okay, which cable is this? So the local guy will tell you this port is going to FH01, and then you check show IP interface brief, and FH01 is
Down.
So you will do config T interface FH01 no shutdown. Clear?
Yes, sir.
What is the step you will gather information? Now you understand why the information gather information is a very important topic in the troubleshooting.
Yes. Yes, sir.
Because maybe if you have 200 employees or maybe 1000 employees or maybe you have 20-30 locations of your company, how you will understand the user is from which area? Then you will ask the floor, building, everything. Then you are able to do the troubleshooting.
Yes.
Clear? Got an idea? Basic idea?
Yes, sir.
Yes, sir.
Yes, sir. Sir, but how we will configure from
what?
No shutdown, from where will be configured?
So we will go to see all these devices. We will configure telnet. I'll cover telnet and DHCP. So like this device. Okay. So I'll just configure for right now. Like I'm just showing you because we have not covered the telnet right now, right?
Yes, sir.
ठीक है, तो इसको करेंगे
Still
cover.
pending.
हाँ. No, I'll cover that. Don't worry. Okay, so I'm assigning a IP to the switch. Okay. And then after that, whenever you configure switch, okay, 2.2 IP is already there. I can assign 2.5 to switch. Okay. Interface. Okay, this is not SVI. Remember we had done SVI topic yesterday?
Yes, sir. Yes, sir.
So ये layer 2 switch है. This is a layer 2. It's not a SVI. This is called management VLAN, management interface. So I assigned IP 2.5 on the VLAN 1, and there is a configuration which I will show you. This is a configuration of telnet. Okay. So we will cover this. Okay. Don't worry. So I'm just showing you. So whenever you do the telnet on route switches, you need to assign the default gateways. So now, if you are asking how you will configure ground floor, so suppose you are sitting here 1.2, you will go to the desktop, okay, and you will say telnet, and you will all have the IPs of the devices, right? So telnet, what will be the IP of ground floor device? 2.5. This list you will have. So even if you do not have this list, in my office, we have local DNS servers also. In my office, what we will have? The local DNS servers. So local DNS servers will help you to use the host names. Like this is 1.4, and I'll configure this server. Okay, so 1.1 and DNS is 1.4 only. So this is a DNS. Suppose this is a local DNS server, and I will say whenever. So what is the device name?
Ground floor.
Ground floor switch 1. Okay. So you can see HQ ground floor switch 1. This is the full name of this device, right? Can you see that?
Sir. Yes,
right,
sir. Right.
तो मेरे switch का नाम क्या है? Headquarters HQ GF SW1. Okay. Clear?
Yes, sir.
ऐसे ही मिलेंगे कंपनीज में आपको डिवाइसेस के नाम. ठीक है. So this DNS, local DNS will be configured, and what will be the IP 2.5, right?
Yes,
so
sir.
this will be my DNS in my local system, and inside my devices, I will give the local DNS IP 192.168.1.4. So now you do not have to do telnet to the IP because we cannot remember the telnet IP, but I know the device name. What is the device name? HQ ground floor switch 1. Yes?
Yes, sir.
Got the access?
Yes, sir. Yes.
I just entered telnet and the ground floor device name. Yes?
Yes, sir.
Got it? So this is what we configure in the real production networks. That's called local DNS server, so that you can map all the devices. If you want to telnet this device HQ, you just need to add an entry in this device by saying HQ. Okay, this is HQ RTR router. RTR is just a short form of router. Okay, what is the IP of router? Suppose 3.1. Okay, it has a lot of IPs, but I'm okay. So now if I want to ping this device, I can check ping. Okay, HQ RT R. Right? I am getting a ping response.
Yes, sir.
So it means router is working, right? Got it now? How you will configure? So this telnet and all, we will configure. This is a separate class. But what I covered here, like some student, like one student asked, how we will go to this HQ device to configure this device. So we will do this configuration, which is called telnet or SSH. This is what we will cover maybe next class. Okay.
Okay.
Yeah. So let's go back to the topic. So when you have that information, then of course you will have a plan of action, what you need to check, what the problem is. So just in simple words, if you want in a very simple troubleshooting ideas, first gather information, try to think what problem we can solve. Okay, try to determine the theory of the cause. Okay, and then when you have plan of action, okay, try to check if all the things are okay. Okay, and make sure guys, whenever you do anything in companies, you need to take permissions. Okay, you need to take the preventive measures also, because this is a user problem. It's not a big problem. But suppose your internet is slow, you cannot go directly as a network engineer to your company router and reload it. Okay, so because in CCNA labs you might do reload and all stuff in these labs, because this is a lab environment. You can go and you can reload the device. It will not take it will not hamper this, because this is the lab. But in real network, we cannot do these type of things until unless we do not have the permissions, right? And whenever you do any configuration, suppose you are pointing a default route. Suppose you know the default route configuration. So this is what you have to add. ISP, you got an internet connection and you are going to have a default route in this router. You cannot directly implement these changes. Okay, in companies, what we do guys, हम company में क्या करते हैं? So first, there is a incident management tools. Which tools?
Incident management tool.
Yeah. So incident management tools are very popular. Like there are a lot of tools here. Okay, you can see this tool from Zira service also, which is used by. There are a lot of tools. Okay, suppose sorry, suppose हमें कोई tool मिल गया. So let's check any tool. Yeah. So you can you see this type of tool? Can you able to see this? थोड़ा बहुत दिख रहा है क्या? नहीं, just hold on. हाँ, ये ठीक लग रहा है मुझे. Okay. So can you see this picture now?
Yes.
Yes, sir.
Okay, this is a very old design of tool kind of, but just understand all tools like this, very boring to fill. Okay, so you will say that I want to add a default route. Then you put your number, everything, and that I am working in head office. I'm working as a network engineer. You will be getting training when you will join any company like HCL, Wipro, or any kind of company which are into service industry. Okay, so ये चीजें आपको सिखाई जाएंगी वहां. Okay, so you will fill a form, then you give next. So all the head offices, all the big IT departments will approve your incident management activity. So what we are doing, we are going to add a command here, which is a default route, which will forward all my traffic to Geo. This is only one command. Can you see that?
Yes.
But still, it's a very long process. Okay, so what is called? This is called incident management. This is also called change request. CR. क्या बोलते हैं इसको?
CR.
Okay, in companies, this term is called change request or CR. Got it?
Yes, sir.
Okay, तो कुछ step होते हैं. जैसे first you will configure. You will not configure. What you will do, you will configure in Notepad. You will send this configuration. You will copy paste that I want to do these changes on head office, and you will add all these changes into this ticket that I want to do these changes. then your senior manager will approve, then the manager will approve, and maybe then we are going to forward that information. Okay.
Yes. So, sir, basically, what we are learning in CCNA, so in the real world, it's totally different. Means,
obviously, see, in CCNA, you know how to configure.
yes, sir.
You know how to forward my traffic to ISP. But when you open this incident, okay, so you are learning also, so that because when you see this command under show running config, how to check your current configuration, show running config, right? So when you see, okay, so suppose you join a company today. So when you see, because you have the access of router, and when you see, okay, these are the commands. So by looking at this configuration, you understand I am forwarding all my traffic to 201.1.1. And this IP is actually Geo IP, right? ISP IP.
Yes, sir.
Clear?
Yes, sir.
So I'm actually helping you all, so that when you join any company, it will be very easy for you to cope up. आपको बहुत ज्यादा टेंशन नहीं रहेगा. I'm sure many of engineers are here and they are all working on these things. Yes or no?
Yes, sir. We are working on CACT.
See? And how many of you have like worked on ServiceNow, ticket systems?
Yes,
Everyone.
sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, we are working.
So
Working,
even the
right?
incident management, we also getting like addition of access point and switch
Yes.
also, no?
Mhm.
And in change management also we are adding devices.
Good, good. So the class, now you are able to relate what is important, right?
Yes, sir.
Okay, so in CCNA, we learn the network concept so that whenever you join any company, it will be very easy for you to understand the company network. Right? Are you getting? Make sense?
Yes, sir.
Yes, sir.
So let's come back. And once you do all this stuff like define problem and gather information, there are a lot of steps, but in simple way, like we will gather information, we will check what is the information, we will check what could be the issues and how we will fix that problem. And we need to make sure we will document everything. Document means we will be using some ticket tools, we will be using some incident management tools, which you will get some extra training from your company. And then you will, whenever you want to do any changes, whenever you want to do any change, so change is required, and this is called CR, change request. Okay? समझ आ गया सभी को?
Yes, sir. Yes, sir.
हिंदी में पूछना पूछ सकते हो, किसी को नहीं आया तो. All good?
Yes, okay, sir. All good, sir.
ठीक है.
I'm a little bit worried about the configuration, sir, because I haven't done any configuration. Like I haven't installed the Cisco packet tracker
Why?
yet. Because I joined the class last week.
Okay, Tanul, no worries. You can take help and join the Discord server of networkings also.
I've already joined in. I was going through the past videos that you have already uploaded, and I was trying to understand.
No worries.
that.
If you are not able to cope up by next week, we can move you into other batch also. Okay?
Oh, okay, sure, sir.
Yeah.
Thank you.
Don't worry. Just keep. We have not done very complex topics. It's very easy, and do not worry.
Okay, sir. Yeah, I'm able to understand just the issue with the configuration, but yeah,
वो
it
प्रैक्टिस ही आएगा.
only.
जितना प्रैक्टिस करोगे ना, उतना ही आएगा.
ओके सर, लाइक वही मैं 2 टॉपिक अभी बचे हैं, तो उनको करने के बाद ही सर मैं कॉन्फ़िगरेशन का देख पाऊंगी.
ठीक है, ठीक है. पूछ लेना डिस्कॉर्ड में. गाइस, हेल्प हर. ओके?
थैंक यू सर.
Okay. So now when we troubleshoot, there are different structures to solve the problem. और ये 3 तरीके होते हैं इंडस्ट्री में troubleshoot करने के. So there are 3 methods which are being used by all network engineer. Okay, every engineer has a different style. Okay, so so one is called top down. Suppose a user complain. Okay, so this is a server. Okay, maybe this is my application. This is my company application server. Right now, I can access this server from web browser. Let's try 192.168.1.4. So now you can see the application is working, right? Yes, guys. So this is a by default page in Cisco Packet Tracer. You can change also. You can go to services, go to HTTP. You can see index file, right? You can write whatever you want. So you can write here mobile app. Okay, and the app name is TikTok. Your favorite, है ना? ये विष्णु का बहुत favorite है TikTok. Okay, so now you can see the mobile app is working, right? So right now when I'm saying, so there are the three ways to troubleshoot any problem. First is called top down, second is called bottom up, and third is called divide and conquer. Okay, so now user complains. Okay, so user complains. Suppose let me do something. I'll create a issue. Now you need to judge what is the problem. Okay, so हाँ मैंने issue कर दिया create. So when this user from head office 2.2, so when he's trying to access the server 192.168.1.4, you can see I'm not able to access the ping. Even I cannot use the web page of this application. So now the user complains that my application is not working. So what I'm doing right now, I'm checking the server directly in the web browser and it's not working. Yes? मैं सबसे पहले क्या कर रहा हूं, मैं वेब ब्राउजर में चेक कर रहा हूं ना. Yes sir. Okay, so this web browser comes into which layer? Application layer. So I'm checking application. Okay, then maybe I'll go to, now all these are like basically in TCP IP, all first three layers are application only. Yes, obviously we can transport layer. What is transport layer? Where we check the port numbers, remember? Yes sir. Yes, okay, so then we can check on website on these router. So I'll cover that topic, but that topic is access list. Okay, this is a security, like you can block any port number. And a web server or any web service works on which port number? 480 and 443. Yes? Yes. HTTPS works on which port number? 443. 438. And normal HTTP works on which port number? 80. 480. Okay, so now just understand, if I'm using top-down approach, application मैंने test किया पहले. Okay, the application. So application is a web browser. A web browser, I'm not able to solve the problem from web browser. Yes or no? Yes, sir. Yes, sir. In the TCP IP, all three layers are called application. Now the second layer is transport. So what we can check here, any port number is blocked, right? Clear? Yes, sir. Yeah, port number I'll cover ACL topic, then you will understand how to block a port. But you will check the port number with any security rule is there which is blocking my server, no. And when it is there, then you check the network layer. What is network? IP address. So what you can do here, you will go to the command prompt and you can use a ping command. It's not working. So after ping, what command you can use? Trace route 192.168.1.4. So now you can see my traffic is going to 2.1. Yes? Who is 2.1? My head office. Okay. So after that 2.1, what is happening?
It's dropping.
Yeah, requested timeout. Okay, so it is also not giving me any output. Okay, so you can see. So what we can do next? So because my server is in different network, I can check the gateway, like if the router is working in branch or not. So you can ping your branch by 1.1. So are you able to get the ping from your gateway with the application gateway? Let's see. 2.1. 2.1 है ना उधर?
Yes.
So are we getting?
No.
So why we are not able to get the ping from the gateway? So what I am doing now? ये देखो इधर है ना 1.1 है. So let me check again. I should get the ping from 1.1. Okay, if I'm not able to ping, so maybe I need to check the routing. Okay, so right now what we are doing, troubleshooting. Like I'm checking from my router that I can ping 2.2 or can I ping other side devices. So basically this is called network layer when you are doing testing and checking all the path that why I'm not able to ping this 1.1. Can I ping 3.2? Let's check. Okay, so these steps. So whatever step I am doing right now, so this is called a network layer. So first I check web browser, then I check port number, then I check network layer. And even if the network layer is not work, maybe I'll check some data link protocols like ARP. Remember what is ARP? क्या होता है ARP?
MAC address.
Address
Yes,
line protocol.
MAC.
From which we get the MAC address through IP address.
Yes. So this 1.4, okay, so when you try to ping your 192.168.1.1, so right now my gateway is reachable, right? Can you see that from server or from server, if you try to ping your 1.4, you are able to make a ping, right? So it means your IP address is working, and if you check a ARP on the router, आपके router पे भी ARP होता है, you have ARP on the router. Can you see that server MAC address is reachable?
Yes.
So it means IP address, layer 2, all these things, and then you can check the physical. So this is actually we never go to till physical and data link layer. So suppose user is saying my port is down. So which troubleshooting you will use? Top down? No. Which troubleshooting will be helpful in this case?
Transport.
Bottom up. Down to top, okay? अगर मेरा पोर्ट ही नहीं चल रहा, if user is saying my cable is showing down, so which troubleshooting method you will use? Bottom up.
Bottom top.
Okay, so you will check that directly. You will go, or maybe you will ask an engineer, can you please check the port? That's called physical layer. Okay, then you check all these steps one by one. And the most important, which is used by all engineers nowadays, is called divide and conquer. So divide and conquer means it depends. Suppose a user is complaining that my port is not working, you directly troubleshoot from the physical level. But if a user complains that my port number is not working or my website or application is not working, you directly check the port number from transport layer. Can you see that? दो arrow दिख रहे हैं आपको? Can you see two arrows?
Yes, sir. Yes, sir.
So why these two arrows? It depends on the situation. Like if the any service is down, port is down, internet not working, and there is no nothing, interface is up and all, then you can use this. You can start troubleshooting from the network to up. And if you have any physical connectivity down, you can check the physical and data link layer. Clear, everyone?
Yes.
So like the TCP connection port number, you are not getting. I told you what is the example of top down. Like in top down, I'll create some notes here so that it will help you in future. So the TCP connection to port 80 might not uncover such a problem. Or you can say the TCP connection for HTTP is not working. Okay, application not working. In this case, we can use top down. In the bottom up, like if your port is down, bottom up, if interface is down, we will use this technique. Okay, and divide and conquer is actually using these both technologies, using both the things, divide and conquer. So using both top down and bottom up according to the situation or ticket, right? Yes, clear, everyone?
Yes, sir.
Yes, sir.
So like it's like you do the troubleshooting from the middle layer. Okay, middle layer means between the layer. So you can do a lot of stuff like ping is not working, then you check the port number. If ports are working, then you can check further level. So this is what we call. Okay, so there are two major things of troubleshooting, like mostly what we have seen in the industry. So these are called two techniques. So some guys actually follow the path properly. Okay, what is called follow the path? Suppose a user complain internet is not working. So you will ping your gateway first, then you will ping the interface. Suppose that this user is not able to access the internet. So directly, what you will do? First, you will not, suppose Google is not working. So what you can do here, you can ping your gateway first. What is my gateway? 2.1. So tell me my gateway is reachable?
Yes, sir.
Then I will check.
Yes, sir.
Yeah. So then the second step, I can ping my WAN connection. What is my WAN IP?
200.1.1.2.
Yes. 200.1.1.2. So what is this? What is I'm doing? So पहला step मैंने क्या लिया? I'm pinging to my gateway. Then second thing I'm pinging to my WAN connection. Second step. Now third thing is, then I will check the IP which is given, or maybe the Geo IP or the ISP IP.
ISP.
Okay, so this is just a basic troubleshooting if you are not able to access your any WAN application. Okay, normally we think that if Google is not working, oh yeah, my internet is not working. So maybe, so this is the case. Suppose Google is working, but maybe some other application is not working. Okay, maybe some your internal application is not working. So as I told you, we will check any troubleshooting things. When you do a lot of practicals, your troubleshooting skills will improve. So these are just the techniques. Whenever you get any trouble, the first step you can ping your gateway, then second step your WAN IP, then check the internet connection. Okay, clear?
Yes, sir. Yes, clear.
So there is another technique. So follow the path method, like you will go step by step, determine the path, then you will check one by one, trace the path by trace route. All these things you will do in which method? Follow the path method. Clear? समझ आ गया सभी को? All
Yes,
good?
sir. Yes,
So
sir.
determine the path.
Yes, sir.
Yes, sir.
Determine the path that packet flow through the network from source to destination and track the packets along the path. Tracing the path will also help you, and it will also eliminate the devices. Suppose this user is not able to access Google, and if you do a trace route, your trace route is going till HQ. So it means if your trace route is working till HQ, it means I do not have to test my switch, I do not have to test my branch. Yes?
Yes, sir.
Yes, sir.
समझ आया? अगर मेरा ट्रेस
Yes.
रूट कहां तक जा रहा है, हेड ऑफिस तक जा रहा है, so I do not have to test my local devices. And trace route is very good command because it will help you that I just hold on. Clear हो गया सभी को? Okay, so trace route
Yes.
will help you. Like if my this connection is not working, so where the trace route will go? Trace route will go till here, right? And then you will get the output. So let me do it right now. So HQ, so this is HQ. Let me shut down this port GI002. GI0002 shut down. So WAN connection is down now. So if I test my internet is not working, this is not the case, right? You cannot say my internet is not working and all. So you can trace, okay, you can trace RT 8.8.8, whatever, Google IP, whatever. So right now 1.1 is replying. You can see till 1.1 is traffic is going. Mic off, please. Lalit. और है ना मुझे इसमें इस लैब में ना, because this is just a test lab, I have not created this lab for troubleshooting, but I am just thinking this lab has some issues. Maybe you can see 3.1 नहीं ping हो रहा, दिख रहा है? My next stop is not reachable. Can you see that?
So actually, I'm also facing same issue when I was solving this app case.
Okay. So you can see G002. The port is a G000. So IPs are wrong here. Can you see? So I have to remove the IP from 02 first. Then I can assign to GI000, IP address 192.168.3.1. And GI002 IP address is 200.1.1.2 ठीक है। तो ये इशू थोड़ा सा हमें पहले वो सर्वर में इसीलिए इशू आ रहा था। ठीक है, ठीक जा रहा है।
Yes, sir.
Okay, so let's check now trace route again. So now you can see traffic is going till 1.1. Okay, and after that it is not reachable. So till 1.1 your traffic is reachable. Okay, but if you check ping to 3.1, so you can see, so this is my first step, gateway is pinging from branch, my HQ is working, and then you can trace route from the router also by saying trace route 8.8.8.8. So you can see I'm getting a reply from which device? HQ device, but after that packet is not going. Can you see that?
Yes, sir.
दिख रहा है ब्रांच राउटर पे मैंने क्या चेक किया? First I tested from my computer to router. Okay, in trace route what device we are getting? 1.1. Then I'll jump on to 1.1 device and then I trace route from here and I got to know 200.1.1 is replying, but there is no reply from maybe other device. So if I enable the this port, okay, 200.1.2 is working, and this ISP should also return my traffic because I created some sorry. Now you can see traffic is going, right? Because my interface was shut down, I have enabled it. So this is just, I'm giving an idea. When you do a lot of labs, try to think in this way that, okay, like I have told you to do the step-by-step procedure. This is the only thing required in industry. Do everything by step-by-step. Okay? ठीक है, समझ आ गया सभी को?
Yes, sir.
Yes, sir.
Sir.
Okay, so there is another problem which is actually used by technicians, okay, and try to, like, this is very rare case. This is called swap components. So this is used by TAC engineers, or maybe by, like, if you have a suppose a switch is not behaving well. Suppose this switch is actually getting reloaded again and again. तो बार बार ये switch reload हो रहा है. Suppose this switch is getting reloaded again and again. Okay, or maybe some, like, the CPU of this switch is going high again and again. So it can be multiple issues, right? So CPU bhi high ho raha hai, memory issues, maybe a lot of issues. You just need to use another, suppose a separate spare switch is in there in your office. You can just copy paste all the configuration in this device and try to test this device. So what is swap method? That you are move components physically and observe if the problem moves with the component or not. So this is also a normally, like we have seen in industry. So if my one device is not working properly and I already have that similar device as a backup or spare in my office, so I will copy paste the configuration, try to check it. And if that other device is also behaving same, it means there is a problem in your configuration. Clear? समझ आ रहा है? Hello.
Yes, sir.
Yes, sir. Yes, sir.
Okay,
Yes,
this
sir.
is and after that, what you can do here, after that you can also compare the outputs. So once you do the swap component, you can compare the configuration. You can check the commands on router and check on another router which you copied and try to test everything, like if similar output you are getting or not. So this is called comparison. Okay, clear everyone?
Yes, sir.
Yes, sir.
Any questions?
No, sir.
So do you know this is when you do, even we did a lot of like, so the biggest problem of this method na, ye jo compare wala hai. So like you can help, you will get to know some problem, but it will not help you to find the root cause of the problem. समझे? You can take the help, okay, there is a problem in device or in the configuration. This is just to check that problem is in the hardware or in the configuration. ये जो compare करते हैं ना, it will not actually help you to get the root cause of the problem.
Yes, sir.
Clear? So this is required, like when you have a deployment devices. Okay, suppose you want to create a new branch in Mumbai, but this router or maybe Delhi office and Mumbai office is similar. So you will copy the Delhi configuration in Mumbai and you will just change the IP address what is required and try to test. Okay, like you will actually copy the template. Suppose Delhi में भी मेरे वही 50 लोग बैठेंगे. Okay, in Delhi office we will have 50 guys. In Mumbai also we need to build the same design, same network, everything is same. Just the IP address or these things are different. So in that case also you can copy it and save it as a template. So whenever you open new branches with same configuration, you just do not have to deploy the configuration from zero level. आपने बस वो copy paste मारना है फिर, समझे? Okay, so let me tell you. So VPN is basically virtual private networks. Okay, what is VPN? VPN is a virtual private network to create end-to-end private network connection. Okay, so let me give you one example. Suppose you have an office in Delhi and you have office in Mumbai and you have office in Chennai. Okay, and maybe some of your users are working from home. Okay, so they are using VPN for connecting with their office. So over the internet, so when you want to connect to a Delhi branch, your Mumbai branch, or maybe your Kolkata branch, okay, so when you connect over the internet, Delhi and Mumbai, okay, Delhi and Kolkata, Mumbai and Kolkata, like this, so this is called VPN. Okay, so VPN is a virtual circuit. Okay, VPN is a virtual circuit which will help us to make our private WAN. Okay, so because private WAN is secure, so tell me if we are so suppose this is a bank. Okay, we are working for a bank. So if we have a branch in Delhi, Mumbai, Kolkata, so can we share all the details, transactions, everything over the internet?
No, sir.
On with internet public WAN. So can we share everything about our, suppose we work for HDFC Bank, can we share all our Google Sheets and customer data over Google Drive? No,
sir.
right?
No, sir.
We want security, right? We want security, correct? So these are private WAN is very important. So you have two types of WAN. One is private WAN and one is public WAN. So public WAN we all are using right now, which is called internet. And private WAN, we use multiple concept in private. For private WAN, we need VPN. So VPN is basically end-to-end private network connections. So you can see this is a business partner. Okay, so over the internet, this is the main site. Maybe this is a head office, and all these branch offices are connected with this head office. And there is a mobile worker like who is doing work from home. So he can also connect to this office. Okay, so these type of WAN, guys, this type of connection is called site-to-site VPN. Okay, when we are connecting our location to location, that is called site-to-site VPN. And when my employees or maybe the mobile workers, they are using their laptops and connecting the VPN from any software which is connecting to the head office. So that VPN is called remote site VPN. So what is the difference? So when we connect to the Delhi and Mumbai location to location, that is called site to site VPN. And when the users or employees connect to the office, that is called remote site VPN. Okay, so usually when we talk about VPN, so VPN is also encrypted the data so that nobody can access the data publicly. So if we are sharing data over the internet, the data is not secure. So we will use secure VPN tunnel so that my data will be confidential. Okay, clear everyone? Yes, I'm not getting your voice.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so when we talk about VPN benefit, so what is the benefit? So first of all, the cost benefit. Okay, so the first benefit is cost. So we do not have to buy private connections. Suppose if you want to connect a Delhi to Mumbai or maybe Kolkata, if you ask internet service provider to connect my Delhi office, Mumbai office, Kolkata office. So this solution is very costly. Okay, so this solution is very costly. Okay, but when we use a VPN, because VPN can be used over the internet, okay, we will use one protocol which is called IPsec. Okay, so we will use this protocol which is called IPsec over the internet to secure my connection. So what is the first benefit? Cost saving. Second is we are getting security. And third is scalability. Scalability means suppose you have 3 branch offices, maybe in future you have 5 more branches. Okay. So over the internet, just you have to connect your offices with the VPN. And VPN can be like implemented across a wide variety of WAN links. Okay, you can have a VPN on the 4G links, you can have VPN on the internet links, broadband links. So you can use any type of connections to use the VPN. Okay, so let's go ahead. Okay, so this was the first VPN I told you guys. What is this VPN? This is called site-to-site VPN. So when my company router is connecting to my head office router or maybe a firewall. Okay, so this type of connectivity is called site-to-site VPN. Okay, so a site-to-site VPN is terminated on VPN gateways and it is only encrypted between the gateways. So internal computer will not have any information. Suppose you guys are working in a Delhi office. Okay, so maybe you are working as an accountant or maybe a sales team member. So when these employees never come to know, okay, how my traffic is going, because Delhi router, on this Delhi router, we have configured VPN, and on the Mumbai router also we have configured the VPN. So this type of VPN is called site-to-site VPN. I'm on my full screen because I want to write here. This is why my PPT is on the small size. Okay, so when we go further, so this is remote site VPNs also. So when the client is going to create VPN connection with the routers. So this is usually happens when I want to connect to the office while doing work from home or any kind of, suppose there is a company server over here and I cannot access server over the public network. This is my private server. So how I will access this server, because this server is in my office. So how I'm going to access this private server? If I connect with the VPN and if I'm virtually present in my office, okay, then I can connect to this private server. So, okay, let me give you one example. Okay, so guys, suppose this is my laptop. Okay, I'm currently connected with the broadband connection. Okay, this is a normal Wi-Fi. So my computer IP is 192.168 or maybe 1.3. So this is connected with this broadband, and this is 192.168 maybe 1.1. Okay, so this broadband is over connected to internet. Okay, and we have an office maybe at different location, and in this office we have server here, and this server is working on 10.1.1.1. Okay, so this is our office. Just hold up. Okay, so now if I connect this laptop, okay, over the internet, if I connect this laptop to the office router, so I will be virtually present in my office and I will get a different IP. Maybe I will get 10.1.1.2. So now this is my VPN IP. So when I connect to the office VPN, I will enter my username password and I will be virtually present in my office. And now my laptop and the server are in same network. I can access my private server. Okay, so this type of connection is called remote access VPN or remote site VPN. Okay, remote access VPN is a better term. So let's go ahead. Okay, now this is very important, guys. Like when we talk about VPN technology, people get confused. This is why I'm taking this session on YouTube also. So people think that VPN MPLS is also VPN. Then why we are using IPsec? Okay. So let me tell you, as you guys are from CCNA, I'll not actually confuse you. So this is an enterprise managed VPNs. So like suppose you are working for a company like Nestle, Cadbury, Dabur, these kind of product based companies. Okay, then if you configure VPN, you will configure these VPNs which are called site to site VPNs, or you configure remote access VPNs. Okay, but when we talk about the service provider VPNs, so these are different ones. So these are not actually VPN. These are called VPN services. Okay. So this is called MPLS technology. So we have layer 2 MPLS, layer 3 MPLS. So as a customer, you will not run MPLS. So when you become a service provider, so if you are Airtel, if you are Reliance, so these companies uses MPLS. Okay. So if you learn MPLS, you will be able to apply to the service provider companies. But if you want to stay with the enterprise companies, like product-based companies, then you might do not require the MPLS knowledge also. Okay. So yes, various companies are looking for both mixture. Okay, that's the different case. But yes, so when we say about enterprise VPNs, so these are the normal VPNs, which is actually over the internet we connect our office. Okay, this is a cheap solution. This is cost effective. But if customer wants to connect his Delhi, Mumbai, Chennai, all the branches with the ISP, that is called a service provider managed VPN. This is called MPLS. So in short, let me give you one more idea. Okay, with the practical, suppose I have 100 employees. Okay, so I have 4 or 3 branches. Okay, I have 3 branches. So maybe this is my Delhi office, this is Mumbai, this is Chennai. Okay, so over the internet, I will buy the normal routers. Okay, the router which support VPN. Over the internet, I'm going to connect all my offices with internet, and over the internet we are going to connect all the offices with VPN. So now the question is, why we want to connect with VPN? Why we want to connect with VPN? Yes, anybody from the company, why we connect with VPNs, guys? Yes, show your knowledge. Yeah, Dinesh.
So that we can access internal server.
Yes. Yes. So maybe in Mumbai we have server. Okay. So maybe in Chennai we have some different, maybe some another server. Okay. And maybe in Delhi we have a tele server. So we have different servers at different location. Okay. And we have a LAN network here. We have hundreds of users available in Delhi. Okay. So now all these users, they want to access these tele server. Okay. Suppose these are accountants. So tele is basically a software for accountants. Suppose these all 4 accountants wants to access the tele server, which is in Mumbai. Okay. So tell me what we are going to do. So we are going to connect my office with Mumbai office with the help of VPN. And with the help of VPN, what will happen? My private network, suppose this private is 1.0. Okay. And this is 192.168.2.0. Okay. So these are 2 private network. Tell me, can we ping private IPs over the internet? Without VPN, what do you think? Can I ping your private IP?
No,
sir. No, sir.
Because, yeah, so let me tell you the reason. Because the routers which are used by ISP, so ISP routers block private IPs. So their ISP routers block private IP. So if the ISP routers are blocking private IP, so then how this VPN technology is able to connect? So what is happening? So we are actually building a tunnel. Okay, we are going to build a tunnel and we are sending our private information inside the tunnel. That is basically called VPN. So we are hiding the information from public that we are not actually dealing with the private to private IP. we are dealing from this router to this router, that ISP will come to know, okay, the traffic is going from the Delhi router to the Mumbai router. But in actual, we are sending my internal traffic inside the tunnel, where a tunnel is built between R1 and R2, right? Between Delhi and Mumbai. Got an idea?
Yeah.
Yes,
So how
Okay,
do
so this happens when we talk about enterprise VPNs. But let's understand now service provider network. Suppose you have Delhi office, Mumbai office, Chennai office. Okay, but now this time you do not take internet connection. Internet connection is different, but you ask what? ISP. So you call ISP ATEL, okay, that I want to connect my 3 offices. So ISP will use MPLS technology, okay, MPLS or other technologies also. So MPLS, so they will give you connection from their Delhi office. So they will give you Mumbai connection from their Mumbai office. So they will give you connection from their Chennai office. So now you can see ISP, internet service provider, ATEL or any company has given me connection. So now they are going to create tunnels inside their network that is called MPLS L3 VPN or L3 or L2 VPN. So L3 is basically when they make the tunnels with IP addresses, that's called L3. L2 VPN is basically when they use some VPLS or some advanced technology. Okay, so means when we talk about service provider VPN, who is making the VPNs? Service provider. And when we talk about enterprise VPN, who is making the VPNs? The companies or we as enterprise customer. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, so what do you think? What do you think? Which is more reliable? If you want to send a lot of bandwidth, if you want a high speed, so which VPN is more reliable? Enterprise or service provider?
Service provider. MPLS. Yeah.
Yes.
Service provider.
So if you have heavy applications, so if you have very heavy applications, okay, suppose you are working for a very good company like Facebook, LinkedIn, Apple, these kind of companies. So they do not worry about the money, right? So they worry about the bandwidth. They worry about the speed. They want high reliability. So if you want high reliability, which VPN is better? The service provider VPN.
Service provider.
Okay, but if you want cost-effective solution, which VPN is better? The enterprise managed VPNs. And there are a lot of VPNs. Let me zoom in so that you will get to know what VPNs. So these are the VPNs. So first type of VPN is IPsec VPN, which is popular. So then there is a GRE over IPsec. Okay. So then there is a Cisco DMVPN, which is called Dynamic Multi-Point Virtual Private Network. So this is another method, IPsec Virtual Tunnel Interface, VTI. I never use this, but yes, this is also a site-to-site VPN. And when we talk about remote access VPN, so here this VPN is called a client-based IPsec. This is over the IPsec, and there is a clientless SSL connection, secure socket layer connection. Okay, so normally people configure IPsec and GRE for their connectivity. But when we talk about the service provider network, layer 3 MPLS, layer 2 MPLS, okay, which is also known as VPLS, okay, virtual private line service. MPLS is multi-protocol label switching. So these are the technology which are no longer. You can check frame relay video on our YouTube, but this technology is no more in the world. Almost, I think 1 or 0.1% people still uses frame relay, but still it is gone. So you do not have to waste your time to learn these technologies, frame relay and ATM. So after this CCNA program, when you go for CCNP, so I'm just giving an idea. This IPsec and all and DMVPN. So these are 2 tunnels are in CCNP. Okay, and this layer 3 MPLS is also in CCNP enterprise. I'm talking. Okay, so this is not in MPL. This MPLS is not in CCNP. But yes, we have added as a bonus topic in CCNP. But if you want to learn the complete layer 2, layer 3, okay, these MPLS, so that comes under the CCNP service provider. But I think if you learn IPsec, if you learn DMVPN, if you know about layer 3 MPLS, still you will become a very good engineer. Okay, so the batch maybe after the CCNA batch when the CCNP is coming, so you'll be going to learn these topics also, IPsec, DMVP and all. Because as a network engineer, you should know these technologies because all the companies are working on IPsec, DMVPN, GRE, so these topics. Okay, so when it comes to the service provider, so there it is known as layer 3 MPLS, and layer 2 MPLS is also getting popular. But it is a very advanced stage. When you learn layer 3, then you can go for layer 2. Okay, so let's go to VPN. So as I told you, remote access VPN means when your client, okay, means when your worker, when your employee can access the office, okay, so that they can access their private server. So what they have to do, so they can go to the VPN connection. So let me show you practically. Okay, so let me go to my system, my network. So I have already created a VPN. So I'm using MacBook. For Windows, I think you need to connect. So you can see I have connected. So this is a VPN connection I have made. This is the router IP of my company. Okay, so I'm going to click connect. Okay, so I just wanted to show you guys. Hello. My voice is clear, guys?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so I told you this is my Wi-Fi connection. You can see what IP I am getting here. You can see here. So what IP I'm getting here? 192.168.1.3. Yes.
Yes, sir.
Hello. Yes. Okay, and I'm now connected to VPN. This was now you can see. So there is a timer going on in this laptop. You can see 0052 seconds. So I'm connected to my office VPN. So what IP I got from VPN? 172.16.0.3. Can you see that my IP got changed?
Yes, sir.
Yes.
Yes.
Okay, it means I'm in my office network and I can open any internal server. Okay, so the office network, I can access my internal network. So you can let me show you. So this is a VMware installed in my office. Okay, I am able to access this server. So you can see 10.1.1.1. Okay, this is in my office. I'm able to open this VPN, this private IP from my home. But if I disconnect my VPN, let me show you. If I disconnect this VPN, for 1 second, my connection will reset. Hello, I'm audible?
Yes, sir.
Okay.
Yes.
Now I have disconnected the VPN. If I try to open this IP again, okay, if I try to open this IP again, let's see what will happen. So now you can see this website is not working. Now you got it. Why we connect remote site VPNs?
Yeah.
Yes, sir.
So you're saying it make a tunnel. So is it make a tunnel on a dedicated IP or in a single IP?
Yeah. You need to buy a public IP.
Okay,
so you need a public IP and which will be on your router, and then you can create the username and password of your employees and give them username and passwords. So whenever they are at their home, they have to connect to the office VPN, and then they are virtually present in my office and they can access the applications. Okay. So there are two type of remote access. You guys also using daily, which is called client-less VPN connection. So whenever you open a website, like maybe a google.com or something like that, so whatever connection you see here over this, so this is called a VPN also, but this type of VPN is called client-less VPN connection. Okay, we do not need any software. The web browser is helping us to build. Bhupender, can you please turn off your mic? Thank you. Okay, so the connection is secured using a web browser. So generally, when you use any bank website and all, so that is called client-less VPN connection. And when when you use a software, but in MacBook, I have not installed any software. But when you use a mobile, what we call Windows or something like that, so there is a Cisco software which is also used popularly, which is called Cisco AnyConnect. Okay, the software name is Cisco AnyConnect. So you will enter your public IP here, and once you enter the public IP, it will ask you your username and the password of your company VPN, and then you have to enter, and then automatically you will be connected to the office. Okay, so this is called client-based VPN connection. But in MacBook, I do not require, because I can create, I do not need an extra software. I can create a VPN from here. I can go, I want to create a VPN like this, and which IPsec, which protocol you are using, like IPsec, and then I can enter my username and password server address, and then you will create the VPN. Just after that, you can connect to the VPN. Okay. So this is called remote access VPN. Okay, so when we talk about this VPN, guys, okay, so the IPsec, there is a protocol called IPsec, Internet Protocol Secure, and then there is a one protocol which is used over the website, which is called SSL. Okay, so the websites are using this mechanism, which is called SSL, Secure Socket Layer, okay, which is limited. Only web applications can use this SSL, like websites and all. But IPsec can be used for almost all IP-based applications. Okay, so this is also strong, but SSL is not that strong. Okay, so when we encrypt the data will be encrypted between 56 to 256 bit. Okay, means this is a high encryption. So SSL is also providing you 40 to 256. But in IPsec, we need to install some softwares, or maybe we need to connect, configure this between router to router. Okay, and where SSL is, Urvish, ask a support team here. Okay, so requires web browser on a host. And so when we go about a site-to-site VPN, so normally when we connect the site-to-site IPsec, okay, so this type of connection we use normally in companies, we use IPsec protocol, Internet Protocol Security. So site-to-site VPN, again, I told you guys, this is when you connect your company router to company router or company firewall to company firewall. That is called site-to-site VPN. Okay, so remote. Okay, so when we talk about this protocol, which is called now there are multiple types of protocol. As I told you, first is site-to-site VPN. So where client does not have any knowledge of VPN, so you will configure the IPsec between this router and this router. So over the internet, you will configure your site-to-site VPN. Okay, so what will happen? This router is going to encrypt my traffic and forward the traffic to the destination. Okay, so this is called site-to-site IPsec VPN.
And what if you will open a public IP over this VPN?
So these VPNs will be built over the public IPs only, Upinder. So we need 2 public IPs to configure this. Okay, suppose you got IP 200.1.1.1 this side, and you got 205.1.1 this side. So when you have public IP, then only you can build IPsec tunnels over the internet, because you are making over the internet, right?
So my question is, let's suppose if I'm trying to access internal IP of one branch to another branch, then a router will make a tunnel between 2 router. I mean, between 2 remote location.
Yes, correct. So you have a server in Mumbai, suppose.
Yeah.
Okay, this is a server in Mumbai, and you are sitting in Delhi. So your routers are already connected with the VPN.
Okay.
When you want to share a file to Delhi to Mumbai, you do not have to create a VPN again and again. So that is an automatic process. Once you build, already a connection is virtually connection is already built between 2 locations.
And if with this VPN connector, I try to open a public IP, then would it? Then
so yeah, so that is a permission. So now if your network engineer has configured to allow the public access, so when you connect with the VPN, there are 2 methods. So some companies, what they do, suppose you are accessing a very secure server. Okay. So you do not want that the user can access the website and user can access the server also. So sometimes they block the internet when you connect with the secure server. But some companies, they give you access to access the internet and you can access the server also. So totally depends on the company.
Okay. Okay.
Okay, so now the next technology is also, this is also IPsec, but here we are using a GRE tunnel. Okay, so GRE is a non-secure tunnel. Okay, so GRE is also like connecting your one office to another, but it will not forward the packet. Like it is like same like site to site. You need two public IPs. So when you have public IP here, okay, so suppose 1.1.1, 2.1.1.1. Okay, so you can connect the GRE tunnel, but this tunnel is not secure. Anybody can check what is going inside the packet. So this is a very old technology. GRE, like many people used earlier GRE, but for security reason, so GRE does not like initially put security. They do not provide encryption. So GRE, you can read this line, GRE does not by default support encryption, and therefore it does not provide secure VPN tunnel. But when you use a GRE over IPsec, means when you use GRE with IPsec, so it will give you more secure. Okay, so it will create a more secure tunnel in comparison to the normal GRE.
Sir.
Yeah.
Sir, if you allow, can I ask you one thing about if lab?
We'll discuss later on.
Okay.
Okay, so when we use a GRE technology, guys, okay, so when we use GRE over IPsec, so first you are sending your packet. Okay, so you can see GRE is a technology which will add one another IP. Okay, so let me tell you. So GRE, we will try to do that lab also, GRE in CCNA. Okay. So many people, they learn CCNA from different places. They come to know, okay, GRE, never heard about that in CCNA. Okay, suppose this is a Delhi router. Okay, this is a Mumbai router. So over the internet, what will happen? You will create a GRE tunnel. So you got a public IP here. You got a public IP here. Okay, but if you want to send your private network, so why we are using private net VPNs? So that you can communicate your private IP to the another private IP. So now this is 2.1, this is 1.1. So I told you, can we forward my private IP over the internet? Yes?
No.
So what will happen? I'm going to forward this IP. So this IP will be hidden inside this packet. Okay. So GRE will add another header, which is 1.1.1, but this IP is hidden inside this IP. So how many IP headers we have now? This is one IP header. So when we use GRE technology, generic routing encapsulation, it will actually add another new IP header, which will put the public IP. So now we will forward the packet over the internet, and internet will see that traffic is going from 1.1.1 to 2.1.1.1. But internally, they are 192.168.1.1 and going where? 192.168.2.1. So in one packet, you have private IPs and the public IPs both. But when the internet will come to know, okay, internet devices will come to know, okay, traffic is going from 1.1.1 to 2.1.1. But inside that packet, okay, inside that packet, what is there? The traffic is going from 192.168.1.1 to 192.168.2.1. So this concept is called GRE. So now you can use IPsec and GRE, okay, which can actually help you or the companies to protect your company network. But if you do not use IPsec with GRE, so the connection will not be secure. So GRE basically encapsulate the original header. It will add extra information. So you can see this is IP. Okay, so you can see here the normal where we are going. This is my actual original data that I want to go from private IP to private. Okay, and this GRE header. So this is a GRE. which is the protocol which is forwarding your information. So GRE is adding one extra another IP, so that over the internet you will use the public IPs. Okay, so that's called GRE. So you can see here, so this is happening 192.168.1.0 is going to the email private server, but original IP packet is this, and which is actually GRE tunnel or IPsec tunnel is actually sending that original packet inside the tunnel. Can you see that image, guys? Yes. So this is the big pipe which is called IPsec, big water pipe. Let's assume IPsec. Okay, there is a pipe which is IPsec VPN, and inside that there is another pipe which is GRE tunnel, and then another pipe which is called original IP packet. So who is protecting my data? Which is the bigger pipe? IPsec, which is securing my tunnel. Yes.
Yes.
Hello.
Sir. Yes, sir.
Okay. And IPsec is using which method? GRE. And inside GRE, which we are forwarding the original IP packet. Okay. So this is all industry. And so another type of VPN. So two VPNs we have discussed: site-to-site IPsec VPN. Okay. And GRE over IPsec. Okay. And the third is a very popular nowadays, which is called a DEM VPN. So this is called a dynamic multi-point VPN. Okay, which is also used, and this is a concept of multi-GRE. Okay, multi-point GRE. So let me show you what is this DM. Why we use a DM VPN? Okay, so this is, suppose you have 10 branches, guys. Okay, you have 10 office. Okay, over the internet, if you connect your 10 office from Delhi to Mumbai, you have to build a tunnel between this. If you want to forward traffic from Delhi to this, so every router, on every router, suppose this Delhi router wants to go to this Mumbai. Okay, or this Mumbai router wants to go to this router. So they need VPN tunnel like this. Every router will have a tunnel with every router. Then only you can forward information. Yes or no? Yes. We will have a lot of tunnels. Suppose you have 10. So 10 minus 1, you need 9 VPN tunnels on every router. Yes or no?
Yes. Yes, sir.
Okay, normally if you want to connect all the offices, every router, if you want this router can communicate with every branch office, then on every router, you might have to configure 9 tunnels. But this DM VPN technology actually eliminating also when you have a 10 branch, okay, when you have a 10 branch office, so over the internet, just one tunnel is required on every router. And because this is called dynamic multi-point VPN, this is called multi-point GRE. On with the one VPN tunnel only we can go to any of the branch. Okay, so it means the DM VPN is very good in terms of VPN tunnel, and with one tunnel only we can access all my branches. So tell me, which will you prefer? If you have 10 branches, you will go with the normal tunnels or you will use a DM VPN? Okay, just to inform you, Apple.
DM VPN, sir.
Okay, Apple kind of companies are using dynamic multi-point VPNs to connect their offices. Okay, so they have 200 plus offices all over the world. So most of the branches or connections, they have connected with the service provider VPN. I told you with the MPLS, but some third-party sites or the customer sites or the retail offices, they have connected with the DM VPN. Okay, Apple Store, जानते हो ना क्या होता है? Hello.
Yes, sir. जानते.
Okay, so suppose they have retail offices, they are selling the laptops and all. So they do not want high secure reliability in the retail offices. Yes, you want reliability, you want high speed in Apple actual offices. So for third parties kind of sites, what you will do, because I do not want reliability and all, over the internet, I will connect all those offices with the DM VPN. Clear, everyone?
Yes.
Yes, sir.
Idea होगा ना थोड़ा सा मैं यही जान रहा हूँ. Okay, just you need an idea. This is the objective of this class. Okay, so DM VPN is a Cisco software solution So DM VPN will simplify the VPN tunnel configuration, that you will not create a lot of tunnel. Just you need to build that maybe one tunnel will help you to connect all over the offices. So DM VPN works on which technology? Multi-GRE. The GRE we discussed. Okay. It is working on this MGRE, which is called multi-point generic routing encapsulation. Okay. So this is the DM VPN. And when we talk about IPsec virtual interface, this is also similar to IPsec. So IPsec virtual tunnel interface simplifies the configuration, and we are going to connect one office to the another office. Okay. That is like we are building a tunnel or virtual tunnel interface between one to one location. It is similar to like that only. Okay. But when we talk about service provider MPLS VPN, these are the two VPN tunnels, which is provided by service provider VPN or service provider MPLS. So MPLS is basically a technology where we are going to forward the information and we are going to learn how ISP configure MPLS. Okay. How ISP configure MPLS tunnels. So there are two types of, there are many types of VPNs. Okay. Let me tell you how many I know. Okay. This is like, there is a multicast VPN, which is called MVPN, EVPN. Okay. Okay, there is a already I told you VPLS technology, L2 VPN, okay, L3 VPN. Okay, so there are other technologies also. So these are like all service provider VPNs. Okay, the VPNs we discussed about IPsec, DM VPN, okay, normal IPsec or GRE tunnel. So these all are enterprise VPNs, and all these VPNs are service provider VPNs. Okay, so when you learn these technologies, it means you are going to work either for a service provider or either you work for Cisco, Juniper, these companies. Okay, my 10-12 years experience into service provider, and I worked with Juniper. So Juniper Networks actually meant what they do, they have a TAC team, okay, technical assistance center. So what we do, so when a big ISP, maybe Airtel is connecting customer offices, and Airtel is connecting a lot of VPNs, so they are using Juniper or Cisco kind of devices. So now if Airtel is getting problem because we are using Juniper routers, if they get problem, where they will ask? The Juniper TAC team. Yes. So if they get if Airtel ISP get a trouble, if ISP get a trouble to connect their like routers with VPN or MPLS technology, so maybe there is some issue going on. So who will fix this issue? The company, right? The OEM, original equipment manufacturer, yes. The router company, right? So there are also people, yeah, there are also people with the tag profiles. They need these type of knowledge, L2 VPN, L3 VPLS, or this stuff. So by learning this technology, you do not get job into only in service provider. You can directly apply to these companies like Cisco, Juniper, Nokia, Alcatel. Okay, so the Huawei, Ciena. So these all companies also hire those engineers who have service provider knowledge. Okay, got it? अभी सब ऊपर से जा रहे हैं ना तुम्हारे. But trust me, I'm trying to give my best so that you will get an idea in a CCNA batch. Nobody, what you know as a CCNA guy, I'm sure, or those guys who are watching in YouTube, many people, they do not understand what is going on. Okay. So I hope you got information about the real industry today. Okay, so let's discuss about IPsec. I am giving you a little bit overview of IPsec also. So now we understand IPsec is basically to connect my office with another office over internet with a secure method, and which is called IPsec. Okay, so when we talk about IPsec is basically internet protocol security, and which gives me 4 things. First is confidentiality. Okay, confidentiality means no cyber criminals can check what is going inside my packet. Okay, that we are going to confidentiality means we are going to protect our data with the cyber criminals, hackers and all, so that I'm going to encrypt the data. Okay, that is called confidentiality, and that is provided by IPsec, Internet Protocol Secure. So the second thing IPsec provides, if somebody asks you an interview, so this is how you are going to say IPsec, Internet Protocol Security, is a protocol to secure the connection, and it provides confidentiality that we are going to encrypt the data. Second is integrity, that nobody can check or change the packet. Here we are going, nobody can read the packet. Let me write the simple language, read the packet. Okay, nobody can read the packet, what is going inside the packet. Other, nobody can change the packet. Nobody can change the information inside the packet, which is called change the packet. Means we are going to use some hash algorithms so that nobody can actually alter the information. Okay, and third is origin authentication, that we are going to use some passwords in a very simple language. We are going to use some passwords. If I set a password on one side, suppose I have a Delhi branch. Okay, if I'm going to set a password here that my password is Cisco. Okay, do not give this password, which is very weak password. Maybe if I give NW Kings 123, okay, NW Kings 0113 #1. So if this is my password, that on the another side also I have to give one password, so that nobody, if any attacker is there, somebody try to steal the information. So they, to read this packet, to change this packet, so they cannot connect to my VPN tunnel until unless they do not have the password. So IPsec is also giving you authentication with it. If you want to connect the router with another router, or like one branch to another over the internet, so we have a confidentiality. Nobody can read the packet. Nobody can change the packet. Nobody have the password. Okay, which is actually given by Internet Key Exchange Protocol. And there is another method also, that these passwords we are not going to share to each other. We will come up with the one shared secret password. There is an algorithm called Diffie-Hellman. Okay, so this is another trick. This is a very secure method. So like they will do some math. Okay, I'm just giving an idea. So with the Diffie-Hellman, they are going to do some math. So they will agree on one password. Okay, suppose this is the public secret. Okay, but this is not the actual password. So router will calculate some math, and they have their actual password is, suppose this 331#. Okay, this is the actual password. So with Diffie-Hellman algorithm, with this Diffie-Hellman technique, we will not share the exactly password. We will share the wrong or some kind of password, public secrets. But if some even hacker come to know this password, no, they cannot get the data, because with this they have some internal math with this Diffie-Hellman, but actual password they calculate inside their devices only. They do not share the private secret. This is called a private secret. Okay, so they randomly generate this private secret with this public secret. So public secret they exchange. Okay, so that's the basic concept about this. So let's understand. So now if I talk about IPsec, guys, IPsec is not a protocol. It's basically a framework. Okay, like if you go to a shopping mall and suppose you want to buy a milk. Okay, there is another different brands available. Now, if you want to buy the nuts, the different brands available. If you want to buy some pizza sauce, maybe different brands available. So you have different packages. Now you can choose this. Now you can choose this, this, and this, and this. So this is how we are going to use confidentiality. Okay, with the IPsec protocol. So first you have to choose which type of which protocol you want to forward the data. So this is called authentication header, and this is called encapsulation security payload. Encapsulating security payload. This is highly secure. If you want to understand simple way. So this ESP, you can check on Google also about the full form. So if you send the data with ESP, the data will be also encrypted. Suppose you are sending a data, suppose you are sending a Google file or any PDF file. So that PDF file, the actual data will also be encrypted when you will send with ESP, encapsulating security payload. But when you send with AH, it will only secure the headers, which is called authentication header. We will only secure the information, okay, but we will not encrypt the data. But normally, if you talk about which is more popular, the ESP is more popular. So now with confidentiality, these are the security method. Okay. So every confidentiality means encrypt the data. Okay. ESP is using, and we are going to use these data encryption standard, DES, data encryption standard. So this AES is advanced encryption standard. Okay, seal, I do not remember the full form of this. You can check it out. Okay, this 3DS and DS. So this is a 168-bit something. This DES is 56-bit. So now tell me if your password is maybe Cisco 123, okay, or anything. But if you use a DS, so DS is going to encrypt this data with a 56-bit. Maybe it will send this number. So this is the encryption, guys. This is the 56-bit means 0 and 1. So this is the actual encryption. But if you use 3DS, maybe your encryption is this. Okay, I'm just typing a very far writing. Okay, so what do you think which is more secure, guys? The 56-bit or 168-bit? Yes.
168-bit.
Yeah. Okay, but if I'm going to share the file from one router to another router, router 1 to router 2, if I'm going to forward my traffic, so all data is going to add one another field of with every packet which what we will send from one router to another with IPsec, we are going to use 3DS. With every packet, 168-bit will be added for encryption. So it means whatever information you are passing, so your packet header is getting increasing, and you will able to send the small data in each packet. And if you, in every packet, if you are not able to send much data, what will happen? The reliability will suffer. Yes. Are you getting? If you put a lot of encryption, guys, but you can only send the limited data, you are actually protecting your data. Okay, but the problem, what is happening here, that you are not able to send a lot of data. So sometimes if you need normal security, you are not actually sending a much secure data. So you can go for DS only. DS also, this is also secure. But instead of 168, it is only going to take what? 56-bit of encryption. That is also secure. But if you want high security, you can go for 3DS. Are you getting now?
Yes, sir.
Yes, sir. Yes, sir.
Oh man, this is so amazing protocol. Okay, so now the second is, I told you integrity. What is integrity? Here, what we are doing, confidentiality, is to encrypt the data so that nobody can read. Yes. Integrity is that nobody can alter the data. We will send hash codes, hash algorithm. Whatever data I'm going to forward from one location to another. Okay, first we will have the 3DS or something like that. But I'm using, suppose, MD5, which is called Message Digest 5. And this is a SHA. SHA means SHA only. Okay. Secure hash algorithm, I think. Yeah. So MD5 is also going to, whenever you send a packet, so this packet is going to generate one code, okay, which is called hash. Suppose this is my hash algorithm. Okay, this is one hash. So if this number is, we are sending from this side, from Delhi, Mumbai got to know this message. Okay, 101 something. So if everything, even single 0, 1, everything is same, it means both the side hash is same. Yes or no? The hash is same both the side. If anybody try to alter this data, so what will happen? The hash numbers will change. Yes or no? If anybody try to steal information, what will happen? The hash will be changed. And if hash values are not same, the Mumbai router will discard this packet. Are you getting now?
Sir, please say this repetition. Please.
Hash is basically a secure number. Okay. So the hash basically MD5 and SHA, it is going to generate a one number, maybe 0176235 y hash 123 like this number. So if this number from source side and from the destination side, if both, when you send a packet, you send a hash here. Yeah. You send a hash code here, and when the destination will see, okay, and it will see, okay, the hash is the same or not. Okay. So the hash number is just, suppose I'm sending you a courier, but I will just mark here a red with some, what we call, I will just mark, suppose this is a courier. Okay. And I'll put a glue here. Okay. And maybe I'll just mark here that is some red dot, that nobody, whenever somebody try to open this, okay, so this glue or this mark will be like, will tell the receiver that somebody try to open this. Right? The same way, you are putting a number or secure hash so that the receiver router will come to know, okay, this code is same. So this is how they protect the integrity, means the sender and the receiver is same. Okay. And nobody try to send or alter the data. Clear?
Yes, sir.
Okay. The third method is authentication. So one is called pre-shared key and one is called Rivest Shamerlmin Edelman. Even tongue twister aa gaye na bahut aaj class mein. Okay. So these are tongue twisters. The pre-shared key means if you use PSK is pre-shared key, you will just enter a password Cisco 123 hash like this. And on the other end also, you have to send the Cisco 123 hash. This is called pre-shared key. But when you use RSA, okay, so when we use RSA, Rivest, Shamerlmin, Edelman, these are three scientists who made this. Remember the SSH protocol works on RSA algorithm?
Yes, sir.
Yeah. So this is the same algorithm we use for secure shell. So RSA and PSK, if you use RSA, so then you need to generate the digital certificates like we generate on SSH. So we can use RSA also for authentication, but yes, pre-shared key is better. We can put a password here, we can add a password here, and that's it. Okay, after that, these are the Diffie-Hellman. So there are different ways. Diffie-Hellman 1, Diffie-Hellman 2, 5, and 6. Okay, nowadays there's maybe new versions also. So if you check the Diffie-Hellman, so it is more of a security. If you use 1, 2, 3 or 1 or 2, so there is a difference between the encryption method. So now you can see with the slides also, IPsec uses authentication header and the ESP encapsulation security payload. So AH is appropriate only when confidentiality is not required, and ESP provide both confidentiality and the authentication. It means it is also going to encrypt the data. If somebody asks you in an interview what is ESP and AH, ESP secure the encrypt the data also, but AH just encrypt the headers, not a data. Okay, so this is confidentiality, guys. I told you this is where, suppose this, you can take this example that this user Gail and Jeremy, okay, so this Gail has transferred one amount of $100. So this encryption algorithm is going to encrypt that $100 transaction into some code. But if somebody try to the threat or intruder, so that intruder cannot read this data, and there on the other end, the decryption algorithm will actually tell, yes, the amount is getting transferred. So this is called confidentiality. Okay, confidentiality. बहुत सारे tongue twisters. Okay, let's go ahead. So when we talk about confidentiality, okay, so DS I told you 56 bit. 3DS is 56 into 3, and if you calculate it, it comes around the, I think, 168 or something. You can calculate. And AES is a 128, 192, and 256, and SEAL is basically a stream cipher. This is the full form, I think. Okay, which encrypts the data 160. So the least secure is DS, the high secure is SEAL, which is, but Cisco router do not, I think they support the latest devices. But the normal Cisco devices, they support 3DS and AES. So when we talk about confidentiality, which is actually going to encrypt the data, okay? So it encrypts the data continuously. And when we talk about integrity, integrity is SHA is 160-bit, MD5 is 128-bit. The SHA is more secure, which is called secure hash algorithm. And these two hash algorithms are used for data algorithm that guarantees integrity, that nobody has changed the packet. Nobody can change the packet, because whenever you send a packet, you will put a HMAC. Okay, there is a hashed message authentication code. With every packet, you are going to send HMAC in IPsec, and when you will forward, that HMAC will be actually a data, or it is like a encryption. Okay. So there are some formulas which is going inside the IPsec. So this is also called hash values also. I'm trying to show you something. Okay, so I just, yeah, you can see, I am sure you guys can see this. Okay, yeah, so you can see here, guys. So whenever we send a data, we also add a hash algorithm, which is MD5 or hash. So whenever we, with the data, we will send a hash value. And when the receiver receive the data, so it is going to check the hash values. So because there is hash value in the data also, and there is a hash also. So now inside the data hash value and the hash value we sent, so if that is matched, so the data is good. If that is not matched, the data will be not accepted. Okay, so it means, so whatever hash value we are sending from here, that hash value copy is inside the data. And when we receiver received it, so the data and hash will be separated, and then hash value and the hash value which is inside the data will be matched. And if that is matched, the data is good, else the data is bad, or the packet will be discarded. Is this clear, everyone? Hello, hello, hello.
Yes, sir.
Good. Okay, the third thing is authentication. I told you we will use the pre-shared key, which is like easy to configure and must be configured on every server. But if you use this algorithm, which is RSA, Rivest Shamir Edelman, so we will use the digital certificates to authenticate the routers or to authenticate the devices. Okay, this class is very important because even if you go for AWS, Azure, or any kind of cloud platforms also, all the tunnels are created on this protocol IPsec. Okay. So till the time you do not understand very well, keep learning this. I'm sure this is the most simple IPsec class ever as anybody has taken. I'm sure if you guys tried earlier. Okay, so this is Diffie-Hellman 257, and these are 14, 15, 16, 19, 20, a lot many available. So if you use a Diffie-Hellman, what will happen? The two peer, remember that thing that we are going to share the secret keys. Okay, so Diffie-Hellman provides allows two peer to establish a shared secret key over an insecure channel. It means that we are going to agree on one number. Okay, and that number will be not shared. The private key will not be shared. Let me show you that also. The DH Diffie-Hellman 125 like this. Okay, so this is the actually concept. Okay, the image is very small, so I'm sure you guys can read this. This is so you can see these are two devices. Okay, do not see here the girl and this cheese kind of stuff. So just understand these are two devices. So both are going to generate a prime number. Okay, so both will agree on prime number. So one agree on 13, and then there is called a generator, which is like a random generated by devices like 6. Okay, then both the devices are going to generate a private key. So you can see private key 5, private key 4. And there is some math, which is like 6 to the power of 5, which is this number generator. And we will have the power of 5, which is a private key. And then we are going to mode this with the 30 number. And when you calculate, there is a value which is called public key. So this public key we are going to share with both devices. But this public key, nobody can modify this public key, because internally the Diffie-Hellman is when you share your public key, and when this router is going to share the public key, the router is going to agree on the shared secret. Can you see the shared secret is same of both the sides? Can you see that, guys? Shared secret 3, shared secret 3, right?
Yes, sir.
So then they will come to know, okay, this is my shared key. And if shared secret number is same, it means we have actually transferred the keys very well. And now we are actually sending the information correctly. So if you want to share the keys with the normal method, so 1 to 5 you can use. But if you want high security 2048 bit, if you use this Diffie-Hellman 15 group 3078, so can you see the number is increasing, the bits are increasing. It means whenever we are going to use all these methods, so this is all going to secure more. If you use a Diffie-Hellman,
sorry for interrupting.
yes, Uma Shankar, tell me.
सर प्राइम नंबर जो आपने बोला है वो थोड़ा सा एक बार और रिपीट कर देंगे प्लीज.
So that is basically a cryptography, dear. Okay, so prime number, you have to learn like cryptography books if you want to completely understand that. Prime number is basically like what I have understood till now, that both devices will agree on prime number, that agree upon two numbers. Can you see that agree upon two numbers?
Yes, sir.
Both devices will agree on two numbers. One will be called prime number. One will be called generator of prime number, which is 6. Turn off your mic. Okay, so this is generated by both the devices. And then there is some formula which is like this: G into private key and mode with the prime number. So G is generator, which is 6, private key number 5, and the mode is 13. And then they calculate this number public value 2.
Okay, no, got it.
Okay, so this is an internal formula. I'm just showing you to elaborate it more how it is actually working. But actually that's if you learn the cryptography, cyber security, those stuff, maybe you guys have to learn this. Okay, so this is IPsec, guys. If you understand this, like I'll tell you, IPsec protects and authenticate IP packet between source and destination. In IPsec, we encapsulate the packet with either AH or ESP, which ESP is more popular. And when we talk about IPsec provides confidentiality, integrity, authentication, and Diffie-Hellman to secure the keys in a very appropriate manner, or key exchange. So you can see here. So let's revise. Confidentiality uses encryption algorithm to prevent cyber criminals to read the packet. Integrity means hash values. Okay, remember that it will divide, and inside the data, it will match the hash. If the hash values are same, it will accept. If the hash values are not same, it will reject the packet. Okay, this is useful when you want that nobody will change the packet, nobody alter the source and destination packet. Then third is about that key exchange. Okay, that is called authentication. So authentication is basically we are going to set a password from one side and the similar password you need on other side. And then the Diffie-Hellman method, that we are going to use the secure method to exchange the keys, because if key is actually copied, so maybe the data will on the risk. So we are going to protect the keys. So this is the key. Who will secure these keys? Whatever password you will set here, the keys will be secured by Diffie-Hellman. so that they will randomly generate a prime number and the generator, then there is a formula something. Okay, then they will come on and agree on the shared secret. And this means that yes, we are successfully secured the keys. Okay, so guys, this is all about today's session. I hope you guys enjoyed this, right?
Basically what I was telling you is that I was discussing about the theme of the complete network engineering industry, or the theme of the Cisco certifications, because the syllabus or the content of the Cisco certifications is pretty much in line with the theme of the industry itself. Okay, so what we were discussing is that basically as a network engineer, most of the time we are working with devices like routers and switches. Okay, and in both of these devices, or even some other kind of devices, maybe like a firewall, or maybe like a load balancer, or even some other kind of device that might come to your mind. Basically what we as network engineers do with these devices is that either we are accessing these devices to push some amount of information, or some configuration commands and so on. Okay, or at some other times we are just trying to get some information out of these devices. So basically at the end of the day, whenever we are trying to deal with these devices, we are either pushing some information or we are getting some information out of these devices. Okay, and till date there have been primarily two ways of doing it, that is pushing information or getting information out of the devices, and those have been CLI and the SNMP. Okay, so in CLI we basically have two technologies, that is our telnet and SSH. Okay, and in both of these technologies, basically one of them is just unencrypted way of doing it, and SSH is the encrypted way of doing it. But at the end of the day, both of them help us to access the command line interface of these devices. And once we have that access, we are either running show commands, or in some other network vendors you can call them display commands. Okay, to get some information out of the devices, and in some other cases we are just basically accessing the CLI to do some kind of a configuration on the devices. Okay, now CLI has been good enough for the longest period that we know of. Okay, and the problem that has started to occur with the CLI is that in CLI, with CLI, we can not basically scale it up to the networks of today. Okay, when I say networks of today, these networks have become more and more critical. These networks have basically they cannot have downtimes. Okay, everything is dependent on the network, the company's revenues, the company's earnings, everything is dependent on the network at times. And basically CLI was developed for human interaction with these devices, and at a time any human can do one task. So with the CLI we could access just one router at a time, and manipulate the configuration, or maybe check out some configuration on one particular device at a time. So basically this has over the time become the most unattractive way or incapable way of dealing with the networks of today. Okay, and then there is another technology that has been for almost the same amount of duration as the CLI has existed, and that is the SNMP. Okay, now the problem with SNMP is that most of the times we are the configuration of SNMP that you will find on devices will be in version 2C. Okay, which is one of the unencrypted versions of SNMP that is being used throughout the industry. Okay, and basically again it provides you the option to get information or push information, but SNMP does the task of pulling information in very small chunks of data. Okay, so basically with SNMP we have to deal with something called the MIB or the OIDs. Okay, if I had to show you what these OIDs look like quickly. So basically these OIDs look somewhat like this. Okay, and this OID is basically nothing but a way to go through the MIB, or which is a kind of a database that is there on your device, and with this particular address we can basically access a particular information, like if what is the current status of an interface, or like what is the current status of a BGP neighborship or an OSPF neighborship. Okay, so we have to deal with these complex OIDs or these complex addresses that can change as we go from a vendor to vendor, or if we go from one device to another device, these OIDs keep changing. Okay, so this way because is also not the best way when you are trying to deal with the networks of today to be able to make changes, because SNMP in today's network, if you'll see commonly, I'm not talking about the capability of SNMP, I'm talking about how it is being commonly used in today's world, and you will find that SNMP is being used just to get some information out of the devices, and over the time there have been multiple attacks related to SNMP on devices and so on, and due to which nowhere you will find that SNMP is being used. Almost nowhere you will find that SNMP is not being used for pushing any information on the device. Okay, so it is not being used for this particular purpose in like 99.9% of the environments. Okay, so in such a scenario, okay, what is the next step? Okay, everyone wants to know that what is the next step, and that is where basically things like the API come into picture. Okay, so that is our third way of accessing the devices, accessing the networks. Okay, just a minute. Okay, so API is something that has come out very recently in the recent years, as early as some of the important RFCs have come out in 2006, and the latest protocols like the REST-CONF. Okay, the RFCs for those have even come out as late as 2017. Okay, so it is a fairly new way of accessing our devices to be able to get the information. And nowadays most of the devices that are coming out, or most of the operating systems for the devices that are coming out from almost all vendors, are supporting this new way of accessing those devices and getting information out of them. Okay, so what do we basically do in the case of using the API to access the information is, what the vendors are doing on their devices is that what they do is, like for example, if you look at any particular device, there are two kinds of data on that device. Okay, the first one is your configurational type of data, and the second one is your operational type of data. Okay, when I say configurational, it is things like, if I talk in the context of an interface, okay, to keep things simple, in the context of an interface, the configurational data would be something like a description of that interface. Okay, or maybe the IP address, IPv4 address of that interface would be something we can say is a configurational state, or we can also say the admin state, whether if it is manually shut down or not. Okay, so these are something that you can say are configurational types of data about an interface on the router, let's say. And similarly, when I say operational kind of data, okay, on that same router would be something in the again in the context of interface, it could be the number of packets that have come in on the interface, the number of packets that have gone out of that interface, the number of errors that might have occurred on that interface, or things like that. Okay, so basically all these information, all this type of data, okay, you can categorize it as the operational type of data. Okay, so basically we used to look at both these kinds of data using our show commands in the CLI. Okay, but now what they have done, they have gone one step ahead and using some data models, okay, that are specific to these different kinds of technologies that are running, or different protocols that are running on the devices. Based on that, they built data models for all the different information that has to be stored, and on that same router where you were just storing the information which was being accessed using the show commands, now that same information will be stored in a different kind of database. Okay, now database is a term that is slightly closer to the the internet world, okay, the HTTP world, the web world. Okay, so they store this information also in form of databases that can then be accessed using a REST API call. Okay, now that same information that we were accessing using show commands, okay, that same information is now also stored in databases with the help of data models that basically construct that database. Okay, it's stored in the database, and now we can access this same database and access that same information which is kept in these databases using the REST API. Okay, now what is the benefit of doing that? We will try to understand that with the help of few examples that I have prepared for you. Okay, so what I'll do is, this is a Linux machine that I have with me. Okay, and this is a basic topology that I have prepared. Okay, so this is the machine that I am currently on, this one. Okay, and from this machine I have direct access to a normal router and one CSR router. Okay, so on the CSR router, basically what the kind of operating system that we have is the IOS XE. Okay, it is the Cisco IOS XE. Fine. So and if I go on a normal router, the operating, this is a IOS V router. So basically on this router, the operating system is a normal IOS. Okay, let me show you quickly. So it is a normal IOS software. Okay, Cisco IOS software. Whereas on a CSR we have the IOS XE software. Okay, and now most of the new devices that are coming out of Cisco, if you talk about the IOS XR series or the 6800 series routers, or any modern routers or devices, or even if I talk about the latest Catalyst 9000 series switches, so all these devices have this IOS XE software. Okay, and on this IOS XE software we have to enable a very basic feature. Okay, that is, we have to enable the REST conf. Okay, I'll show you quickly. So there's a simple command that you have to run, that is, just a minute, that is REST conf. Okay, and it will basically enable the REST conf protocol, and the same credentials, this is the command REST conf. Okay, so if you just type in, if you just go to config mode and type in restconf, okay, and hit enter. That will enable restconf, okay. But there are certain requirements, okay, sorry, I just closed it. There are certain requirements that are there, okay. I'll show you those also quickly. Do show run again. That is, you have to enable the HTTP server, the HTTP secure server. Both of these you have to have a higher privilege. You have to basically create username, password on your device. Okay, so all these basic setups that you have to do for like something like an SSH, those things you have to do. But besides that, you just have to use the restconf command to basically enable the HTTP server on that. Okay. So these are some other commands that have to be enabled. Generally we disable these commands, but in this case we have to enable it. Besides the restconf command, we have to have the username, password, we have to have the line VTY enabled and all these things. So all the basic setups, and besides that you just have to use restconf command, and this will enable restconf. Okay. Whereas on the normal router, we can access it using the CLI. In this case, this particular session is a console session, but I can also access the same router using SSH, and I have enabled SSH on that. Okay. So I just want to, with two examples, okay, I just want to contrast that how both of these scenarios work. Okay. So in the first example, I'm working with the NetMiko library. Okay, so in the basically the NetMiko library, what it does is it uses the in the background, what it is doing is it is basically accessing the device using the SSH protocol. Okay, and the IP address that I've used, as you can see, is 192.168.26.1. Just to show, I'll do show IP interface brief, and you can see that it has 192.168.26.1 on the device. Okay, so in that same I'll use that same IP address to SSH into the device using this script, and this script will basically take the output of show IP interface brief. Okay. So this is a very basic script. Okay, it will it will ask for my username, it will ask for the password, and once I have provided that, it will create a session using the connect handler function of the NetMiko library. It will create a session, and on that session I will send a show command, that is the show IP interface brief command, and I'll take the output. Okay, and I'll just print that output for you to see on the screen. Okay, so for now I'm doing that. There are some extra steps which I am not showing you right now, but I'll show you later on. Okay, so let me run this script, and it is asking for my username, and that is Python, and the password is also Python. So once I do that, it basically accessed the router and it ran that show IP interface brief command, and here you can see is the output of the show IP interface brief. Okay, and it has been printed out on the screen. But now you can say that okay, SSH is good enough, I can access the show IP interface brief, but what is the problem with that? Okay, what is the problem with that output? The problem is that, let's say for some let's say I have to create a report, okay, or let's say I have to create some kind of a database on my PC, okay, in which I need to have a database that which particular interface has which particular IP address on a device. Okay, and I have to do that for all the devices in my network. So in that case, if I use SSH or if I use SSH, or if I basically use NetMiko library, what will happen is this output that I'm getting out of the device, okay, this output is basically a complete block of text. Okay, just like I ran the show IP interface brief output here, in that same way it was executed by my script also, and this complete block of text was given out to me. Okay, now from this complete block of text, if I want to access individual interfaces and their particular IP addresses, it becomes a difficult task for me. Okay, now to be able to do that, I have to go through a very lengthy process where I will have to use things like regular expressions and similar other things to be able to go through this output line by line and be able to extract that particular field of data. Okay, and why this problem is there? Because this particular output was primarily made for humans to read. Okay, primarily made for us to read. Okay, because we just want to have a look at that information and just look at some information out of it, and based on that, maybe if this is the, let's say this is the IP address we were looking for and this is the interface that has it, then we would just copy this interface from the command line and execute our next command and so on. Okay, and we'll look for some more details about gigabit Ethernet 0x0. Okay, so that is very good for human consumption. But what if, like, for either for creating a report or maybe for taking some further action, that is if this is the interface which is having some issues and I want to automatically, using a script, I want to shut this interface down so that my traffic then gets forwarded from a different interface, or maybe if I want to shut down this interface so that the BGP protocol automatically chooses to go through the second path that is available, because this particular path has a lower quality at this point of time, because maybe there are certain drops. Okay, but those drops are not being taken care of by the BGP protocols, because these drops are intermittent. So BGP protocol has a wait timer and therefore it does not go down, but my customers are suffering because of that. Okay, so I got to know somehow through my management systems that this link is not suitable enough. So I will have to find out this interface to be able to do that. Okay, now that task is pretty difficult when you use something like regular expressions. Okay, so what I've done is I've written this piece of code, okay, where I have written a complete regular expression, okay, that will help me to extract the interface name from a particular line of this text, then the interface IP, then the admin status, then the physical status of that interface. And in this particular case, I'm not doing anything funny. I'm just trying to print it out again on the screen. Okay, so what I'll do is, this time I'll not print the output that I'm receiving from the device itself, but I will print out the processed output that my script is processing. Okay, so as you can see, I have custom headings, that is interface name, interface IP, admin status, physical status, whereas you have all these extra columns also in the case of the normal output. Okay, so let's run this particular script now. Okay, so if I run it again with the new changes, let's see the output that I get. Okay, now again I'm able to access all the interfaces which have an IP address on them, whatever the admin status of those interfaces is, whatever the physical status of those interfaces is, I'm able to access that. Okay, for only the interfaces which have an IP address on them, because that is how I built my regular expression. Okay, so that it can identify the interfaces with the IP address on them. Okay, now the problem is, first of all, I have to have an extra understanding about regular expressions. Okay, number two is that this particular regular expression that I have built for show IP interface brief will not necessarily work with some other show command. Okay, so if I were to execute, if I wanted to extract the data out of, let's say, show interface description command, then in that case I will have to write a completely new code, because this particular piece of code can only parse or only extract the details out of show IP interface brief commands output. Okay, similarly, I have basically in this regular expression provided support for only two types of interfaces. Okay, that is this particular regular expression, if I give it an output which has, let's say, 10 gigabit Ethernet interface, or which has only an Ethernet interface, or maybe a fast Ethernet interface, in that case this regular expression will fail. So I will have to again basically modify this regular expression to be able to support all kinds of interfaces. Now you just imagine, and even if I get an interface which has a sub interface, like if it has dot something, dot 1, dot 2, then again it will fail. So just imagine that how many types of permutations and combinations there can be in the case of just Cisco with the number of with the types of interfaces names. Okay, so that is basically the problem with parsing this kind of data. Okay, so it is not the most efficient way of doing it, because this particular CLI, as you can basically the CLI was not built for machines to work with the router. Okay, so in this case basically this Python script is also acting as a machine only. Okay, a basic machine which has only one task, that is to extract the IP interface brief data. But it was basically CLI was meant for humans to interact with it, and that is why this kind of problems are there. Although we can overcome these problems with by being a little more smart about it, and we can find our workarounds and all those things, but it is very, very tedious. I will have to write a lot of lines of code to be able to deal with these problems. Okay, I will have to write hundreds or even thousands of lines of code to be able to deal with every individual command. Like if I have to write, like I guess this is like 10 lines of code. So if I had to write even 10 lines of code, which is obviously not the case for all commands, because there are certain commands which have a lot of information in them. Okay, so to be able to extract all that information from all those commands, you can take a good guess that what is the amount of code that I will have to write. Okay, so it is a very big task, okay, in itself. So that is why this is not the way we are going to proceed. And very quickly people in the networking industry came to know that this is not the best way to deal with this, and that is why API came into the picture. Now what I'm going to do is I'm going to access my CSR router again, which is also a normal router. Okay, which can also be accessed by anyone using the command line interface. Okay, where you can run your show commands, you can configure that router using the CLI, and you can do everything just like the normal iOS router on the CSR router also using the CLI. But here it also provides us an extra feature, that is of the REST API. And now what I'm going to do is I'm going to use the requests library of Python, which basically makes your PC as a HTTP client. Okay, so whenever we are going through any like this particular browser that I'm using to access the lab, so even this browser makes your PC an HTTP client. Okay, so in a similar way we can use Python requests library to make our PC to make our PC act like a client, an HTTP client. And this time I'm accessing the host 25.192.168.25.100, which belongs to the CSR router. So if I just run show IP interface brief, you can see that 192.168.25.100 belongs to the CSR router. Okay, so I'm going to access it on that IP. The port, as you can see, 443 is the HTTPS port number. The username is Amit and password is Cisco, the basic details. Okay, and as you can see, this is the URL that I am using, which has something to do. At this point, I don't have the time to explain everything about this URL, but as you can see, it looks pretty much like any website's URL. Okay, and I'm using this particular URL to access the interfaces data, okay, on the device. Okay, now this time with that URL, I'm passing in some additional HTTP headers, and I'm basically sending a GET request to this device, and I'll be getting a certain response. And out of that response will have a status code, like just like any HTTP status codes. If you are aware, there any good status code starts with 200, lies in the 200 series. Bad status codes lie generally in the 400 series and 500 series if you are getting any kind of an error. So most of you might have come across 404 error when you try to access any website, and if that website is down for some reason, you will get a 404 error. So similarly here also you will get those status codes. Okay, and then whatever the response is there, the text that is there in the response, that I will be returning to this particular variable interfaces. Okay, and just to show you, I'll be printing it out, and I will also be saving it in a file. Okay, so this is the file. Currently it is empty, and once I've run this script, you will be able to see data in this particular file. Okay, and I'll show you the kind of data that I'm receiving this time from the device. Okay, so as you can see, I have done nothing special on the data till now. I'll be writing the raw data, the raw JSON data that I'm receiving from the device into this file, and then what I'll be doing is I'll be using the JSON library that is there in Python to basically convert that JSON data into a Python dictionary. Okay, just to confirm that it is a Python dictionary, I will be printing out the type of that data on the terminal, so you can see that also. Then I will basically, this particular portion of code, what it does is it parses the dictionary data. Okay, and once you parse that dictionary data, I'll explain this code once we are done running this. So let me run this quickly. Okay, so as you can see, this is the complete data that we got. If I go to my file, this is the data that we have received from the device. So now you can see, I'll put this data on the side. Okay, so this is the raw data that we got. Okay, interfaces data, which is in the interfaces variable. So this is the data that we got, and as you can see, this data is organized very much, it is very different from the CLI data. But here in this also, we are getting that similar kind of data about that interface. That is, we are getting the IP address, we are getting the subnet mask, we are getting the type of that interface. It is an Ethernet kind of an interface. What is the name of that interface? Then we are getting the information if this particular interface is enabled or not. It means that manually or administratively it is unshut or not. So enabled true means that it is no shutdown. Okay, so basically this interface is active, you can say, from an administrative point of view. Similarly, we are getting for gigabit Ethernet 2, gigabit Ethernet 3, 4, and we have one more interface, loopback 120 on the router, which has these IP address details. The type of this interface is a software loopback. So we are getting all these details, basic details about the interfaces, but this time this information is given to us in JSON format, which is very easily convertible to a Python dictionary. Okay, now what is the benefit of that? Converting, as you can see, when I printed out the type, it prints out dict. Okay, so which stands for dictionary in Python. So we are converting that information into a Python dictionary. Now, since Python dictionary, as the name itself has Python in it, it is a Pythonic object. Okay, so if anything is already in a format that is very easy for Python to work with, you will obviously get the benefit of that. Okay, so as you can see, we can very easily parse through that dictionary and extract different pieces of information that are there. Like for every single interface, I want to access the name. Okay, I want to access the name of that interface, I want to access the IP address, I want to access the net mask, and in case if a particular interface does not have an IP address, like in this case for gigabit Ethernet 4, it does not have an IPv4 or an IPv6 address, I want to print out these two particular strings, that is no IPv4 and no mask in that in the place, and then I want to print out the status of that interface. Okay, if the status is enabled or not. Basically true means enabled and disabled. So I was able to very easily parse that particular dictionary and was able to extract all that data, and I did not have to go through the hurdle of learning regular expressions or things like that. Okay, and these scripts are basically very easy to write. Once you will learn Python with us, you will see that if you are trying to work with a piece of text, it is very difficult to parse, whereas if you are working with a Python dictionary or a Python list or a Python tuple or some other type of Python object, it is very easily to work with. It is very easy to work with in Python. Okay, because these are Python objects. So basically what is happening here is that the devices are taking a step forward and providing you with the data that we were wanting to access earlier also in a new kind of format, which is very easy for other machines to work with. Okay, so I could very easily write this piece of script, and generally this particular amount of data had this particular amount number of lines had to be written only to print it out on the screen like this. If I just had to access a particular interface and basically access the IP address and maybe do something with it going further, maybe shut it down or unshut it depending on my scenario or my requirement, it would have been very easy. I would not have to write even these many number of lines. Okay, these lines have just been written to be able to print it out on the screen. So basically this is not something you'll be doing all the time. So otherwise, just with like only you can say just around 20 to 30 lines, with just 20 to 30 lines of code, I was able to get that data and was also able to do a lot of things with it because that data was given to me in a supportive or in a very helpful manner using the JSON format. Okay, so that is where the industry is heading slowly and steadily, and that is why exams like N-Auto have come into existence, and slowly you will see that, and not slowly but in today's date, if you open any exams syllabus, you will see some portion of these technologies mentioned in there. Okay, even if you open the CCNA exam today or like in CCNP, the basic exam also has a portion for automation or a section for automation, and they have this special exam N-Auto, which is completely for learning automation only, and even the CCI has that. And not just about the routing switching domain, if you go into any of the domains, and now they have even come out with the DevNet certification, which is completely focused on network developers, okay, who want to do development with the network, on the network. Okay, so this is what I had to, present to you.
So we are going to learn network automation. So this is you can consider this is like day one for this network automation. Okay, so why we need network automation? First, we need to understand the problems in the current network right now. Problems in current network, or many books even saying they are traditional network. Traditional is not a correct word. I would say current network. Okay, suppose when there are many routers connected with each other. Okay, suppose these are your different cities like Delhi, Mumbai, Chennai, Kolkata, all are connected. So when you have very big network, you need more staff. Right now, if you have very big network, you need more people to manage this stuff. Okay, you need more people. Okay. So right now, another problem, if any engineer you are hiring, many engineers, like you need expertise on one vendor. Suppose you have Cisco devices, like these devices are Cisco, you need Cisco engineers. If you have Juniper devices, you need Juniper engineers. Okay, so if you have Arista company devices, you need Arista engineers. So this is why companies are looking for multi-technology or multi-skill engineers also. But this is very rare that one people know all the things. Okay. So, but right now, even by paying a lot to them, suppose we have hired a person on Cisco on very good salary, then we hired Juniper person, Arista person. Now, all what they are doing, like they are working on these devices, and daily either they are checking the logs, either they are doing some configuration, but most of the things what a network engineer is doing right now, it's not productive. What is not productive? So right now, whatever the work they are doing, they are all repetitive tasks. All they are repetitive tasks. So we need to eliminate these repetitive tasks. Okay. So this is the problem. Okay. And additionally, not just this, by even learning configuration, we need to, if we want to configure this Delhi router, we have to go Delhi by using Telnet, SSH, or by physically also. Then Mumbai. So you can see on all the devices, suppose you have 100 plus branches. So you have to go one by one on all the branches. Means we have to go on every device. Okay, so this is time consuming. This is like box to box management. This is called box to box management. मतलब हर डिवाइस पे आपको एक एक करके जाना है. You have to go to the devices one by one, and this is little time consuming. Suppose if someone will ask you to take or to check the OSPF neighbors, okay, or maybe you need to see the health or CPU of all the routers, then maybe you have to run the CPU commands on all devices. There are some softwares in the market which are on SNMP, Simple Network Management Protocol, SNMP softwares. Okay, they tell the health about the devices, that routers have high CPU or the health is okay or not. But still, you can only check, but you cannot do a lot of configuration. If you use SNMP kind of software, you can only monitor the things. These are called monitoring software, but you cannot do any configurations. Okay, and the most important thing, guys, when the engineers do their work manually, okay, so it is like a human error is the problem. So when we do a lot of copy paste right now, suppose like right now in CCNA, you have seen we use all the configuration on Notepad, either on Notion or Notepad files. And even me, myself, also sometimes do some mistakes in the Notepad. तो कई बार हम नोटपैड पे जब कमांड लिखते हैं तो गलतियां करते हैं. Okay, so mostly human error comes when we are writing all the commands on notepad. So these are the current problems in our network. Like we have big network, more people to support the network. We need more people for different vendors. If you are using Cisco, Juniper, Arista, you need more people, and all of them are doing repetitive tasks. Okay, this is like high investment on the company. And then box to box management, like every device we have to go manually and configure it. Okay, this is also a time consuming process, and human errors also is the major issue because all the configuration mostly we do on the notepads and all. This is another problem. Okay, so what is then network automation? What network automation is going to help you? Okay, let's see. तो जब नेटवर्क ऑटोमेशन की बात आती है, व्हाट इज द एडवांटेज ऑफ गोइंग टू द नेटवर्क ऑटोमेशन? व्हाई मस्ट कंपनीज आर माइग्रेटिंग और engineers have to learn automation? Because when we are going to configure the network automation, it is we are going to automate means automatically things will happen, like which things, like configuration things will happen. Okay, we will also test the configuration. Okay, we will also deploy the things, like all the configuration, test, everything will be done automatically. Everyday task like backup of the configuration, everyday task like backup. Okay, like checking the health of device. Okay, basic functions all will be done automatically. Repetitive task will be eliminated. Repetitive task will be eliminated or will be controlled. तो जो बार बार हम एक काम करते हैं वो कंट्रोल हो जाएगा. We do not have to do repetitive tasks again and again, and we can easily control them more efficiently with more efficiently. तो हम बहुत अच्छे से कर पाएंगे. We will be able to do this, and also it will also improve my network service. Okay, it will improve the network service. Okay, because if when network is down, if engineers are working on it, so most of the network issues comes with the human errors also. तो बहुत जगह पे network down होता है human error की वजह से. When you are actually doing automation, it is rare that humans will do mistakes. Okay, तो चीजें easy हो जाएंगी. So when we automate the things, what are the benefits you are going to get? Better network control. तो पहले तो हमारा नेटवर्क कंट्रोल बहुत अच्छा हो जाएगा, इश्यूज बहुत कम आएंगे. We will be able to easily manage the network. Low cost, because we do not have to actually put a lot of people and doing repetitive tasks. Okay, lower number of errors will be lower. Okay, so the devices will not have downtime, less downtime. Like device जो होंगे हमारे बहुत कम down जाएंगे. Okay, so this is all benefits of network automation. This is why companies are moving. तो एक ये reason है इसलिए company move कर रही है. Okay, so how we are going to automate? Okay, how we are going to avoid the human errors? How we are going to do all this stuff? Okay, so we have to understand the type of automation we have in the network right now. So types of automation. So what type of network automation we have? So there are multiple like automation, like right now the network automation going well in the data center networks. So in data center, there are many advanced devices. Okay, very big devices or the high end devices called Nexus. And these all devices are controlled by one controller, which is called APIC, Application Programming Interface Controller. Or this is also known as ACI, also Application Centric Infrastructure. So all these devices, if you have many devices, so they all can be controlled in the data center with this technology called APIC. So automation is doing good in the data center and network. because data center को manage करना बहुत tough हो जाता है, because you cannot put many engineers in the data center also. Okay, so you need to control all the devices from one location. Okay, you cannot go to all the devices one by one daily basis by checking their health, because data center is full with noise, cooling, high cooling, a lot of things. So even you cannot stay in data center for even 2-3 hours. You feel like it's a problem, right? So it's better to manage all the things from one place. So the same way, cloud is going well in the market right now. Cloud networks right now, if you talk about AWS, Azure, or Google Cloud Platform, even there also there are some scripts, there are some concepts which is like a Docker, Kubernetes. There are many things in cloud network also. The things are getting automated. Like suppose you want to run 100 Linux servers and you need to install maybe some application on 100 Linux server. So this type of automation you will see in the cloud network automations or cloud automations. तो data center और cloud में तो हो ही रहा था अभी तक, but right now even the wireless networks are getting automated. So wireless network, the best example of wireless network is Cisco Meraki. There is a solution from Cisco which is called Cisco Meraki. This is a wireless SDN solution, or what we call automation solution, where you will control the Wi-Fi of all the locations from one place. Like all your Delhi, Mumbai, Chennai, Kolkata, New York, Dubai, all things can be all Wi-Fi controlled from one place, which technology is known as Cisco Meraki. Okay, so now we have new technologies in the market from past few years. So in the local area network, this technology is known as SD. Cisco call this is SD access. तो ये एक टेक्नोलॉजी जिसे बोलते हैं SD access. And in the WAN, there is a technology which is called SD-WAN. Okay, SD-WAN. Okay, so but yes, these are the network automation things which is going good in the market right now. So for a better, if you are a if you are an engineer who works mostly in the enterprise, both technologies are doing good in the market. SD-WAN is more popular, but SD access is also doing good in the market. Okay, so data center also, like if any person has a 5 years, 6 years working on data center, definitely they should upgrade themselves to learn this ACI and all. So it's all about where are you working, where you need to automate the process. So let's discuss more. So right now, any network device, so कोई भी network device होता है, whenever we talk about these network devices, like either it's a router or a switch or either a wireless device, so they can be configured with 2 methods, but you know only one method, which is CLI. तो अभी तक आप लोगों को सिर्फ एक ही मेथड आता है जिससे बोलते हैं CLI, because you are a CCNA candidate, most of you, right? So only we know one method, which is CLI, but there is some another method which is called API. Like CLI stand for command line interface, and there is another thing which is in the market, API. Okay, this is not in the devices. The API is a API stand for application programming interface. So we can access the devices from application programming interface, but many devices do not support APIs. Okay. So we need APIs, which is application programming. Suppose a router, guys, which is connected to another router with which interface? With a fast Ethernet interface. The similar way, when we talk about network hardware, okay, you connect 2 hardware machines by their cable or connector, which is called interface. The similar two softwares, like when we talk about the software, because they are virtual, तो जो software होते हैं, softwares do not have the physical connectivity, they have virtual connectivity, which is called API. So API is used among all software to make compatible this software with this software. तो API क्या करता है, इधर का डिटेल इधर चले जाना. So like two applications or two softwares interact with each other with the help of APIs, which is application programming interface. The similar way you have fast Ethernet or gigabit Internet interface, the similar way you have APIs, which is application programming interface. Okay, so now we will talk about SDN, guys. So this is just a fancy name, SDN, which is known as any network which is controlled by any software, which is called software defined network. So SDN is not a actually technology, it's just a general word. Okay, this is just a general word. The technologies are SD-WAN, SDXS, okay, Cisco Meraki wireless solution, Cisco ACI or APIC. So there are many softwares, many companies like Velo Cloud, which is from VMware. Okay, this is a SD-WAN solution by VMware. This SD-WAN, like how we control all the locations from one place. I'll explain all these things, don't worry. Okay, so what is SDN? So we can actually control all our network from controllers. Okay, what is this controller? Okay, so I'll show you. मैं आपको एक टोपोलॉजी दिखाता हूँ. I'll show you one diagram of our SD-WAN lab. तो एक lab दिखाता हूँ मैं आपको, so that you will get an idea at least what is going in the market. Just hold on, Ravinder. So guys, this is our lab, which is of SD-WAN lab. So I'm sure that you get overwhelmed. ये बहुत advanced लग रहा है. Okay, but I'm just let's break down into parts. So you can see this side we have Delhi routers. This is Mumbai network. This is Dubai network. This is Chennai network. This is USA data center, and this is all networking's office or maybe headquarter. Okay, तो जो ऊपर का जो दिख रहा है, this is like all our like headquarter or anything, if you want to understand this. Okay, so this is our head office or the main center location. So right now you can see all the devices are connected, all these locations are connected with the internet and with MPLS technology. Means all the branch offices like Delhi is connected to MPLS, which is private WAN. This is for private connection. And Delhi location is also connected to internet, which is public connection. So every location have private connection, internet connection, private connection, internet connection. MPLS is just a technology to connect all our head office with branch offices. MPLS is a private technology. Suppose you want to connect Delhi to Mumbai, but you do not want to connect with the internet. This type of connectivity is called MPLS connectivity. So you are paying for private link. But when you connect Delhi to Mumbai with internet connectivity, this is your public WAN, this is your private WAN. This is costly, guys. This is cheap or not costly. So internet connectivity costly nahi hoti hai, but MPLS technology is very costly. Okay, so what you have, like all the branch offices are connected because you need more reliability. Because on internet you will not get speed. Okay, so all these locations are connected, but right now, do you know, we do not have to control Delhi. We do not have to control Mumbai. We do not have to control Chennai, US data center, Dubai. We can control all these location from one device, which is called vManage. This is vManage. Okay, this is vManage. Okay, it's like a manager of all the devices. This device is going to control all the devices here. Delhi, Mumbai, Dubai, data center, Chennai. All they are reporting to this device, which is called vManager. Okay, so because most of the locations are on internet also. Maybe suppose you have a network in Shimla. Okay, this is like a hill station, but you have only internet connectivity. You have this type of device. So all these devices on the locations are called vEdge. vEdge is like same like a router. Okay, same like a router. It is available both in hardware and in software also. Why software I will explain later on. Okay, because maybe you have one location in AWS cloud. तो हो सकता है आपकी एक location, maybe you have one location at AWS cloud and you have vEdge software, virtual vEdge in the AWS cloud. Maybe in AWS you have some servers. Okay, तो इसलिए software vEdge use होता है, but in physical location you need a physical vEdge device which is similar like a router, and many router also support this vEdge functionality. vEdge is nothing, this is just a router with just a fancy name now, because all the edge locations are like all the branch offices, all their routers are called vEdge. Okay, and all they are controlled with this device which is called vManage. Okay, it's written wrong here. vManage is the correct one. Okay, but nowadays, now we have vSmart here, vBond here. There are two more management. So all three of them, vManage, vSmart, vBond, all these devices are management devices. तो ये सारे management के part होते हैं, because all they are management devices. So this vBond is used for authentication. Like, because I told you, maybe some locations like your hill stations are connected with internet only. You do not have private link. So then we need to make sure that this device is a authenticated branch. तो हमें ये make sure करना है ये authenticated branch है. This is genuine our company device. So this device will register with vBond, and then vBond will give the approval, then it will register to vManage. So vBond is a separate device for authentication. तो ये authentication करता है. So there is a vSmart where we are going to make the policies. We are going to do routing. All these locations are sharing routes with the vSmart. Suppose Delhi will share his routes with the vSmart. Mumbai will also share. US data center will also share. Chennai will also share. Now we can control this vSmart accordingly. Like if you want to connect Delhi to Mumbai but not to Chennai. So all these policies you can configure in this device which is called vSmart. So you can see, guys, this is not a future. This is already we are teaching. This is called SD-WAN, which is like automation. So we are going to control all the devices from here itself. तो सारा कुछ हम यहीं से manage करेंगे. Okay, got it? So this is just an overview so that you got an idea. Like automation is not about future. Automation is already going on. Okay, so yeah, so I have given a good overview. So you have seen, so that vManage kind of device is a controller. तो हमारे नेटवर्क में क्या होगा, मैं आपको एक चीज और बताता हूँ. So right now, like if we talk about Delhi, Mumbai, Chennai, Kolkata, right now we have all connectivity like this. Maybe we are connected with the internet and all. But tell me, if you want to configure Delhi, Mumbai, Chennai, Kolkata devices, so do you have to go to all the routers or you can control from one location? Obviously, you can do telnet, SSH, but still you have to log in with their IP addresses manually, differently. Right? Because all these devices, like inside these devices, So inside these devices, you have two planes. One is called control plane. Control plane is like managing all the devices called control. Like all four routers are exchanging OSPF packets with each other. So tell me, this is control plane or this is a data plane? What do you think? So ये क्या है? All your routing protocols, all your routing entries, everything, it's related to your control plane. All routing decisions, all done by control plane. What is done by data plane? When you send a traffic from computer A to computer B in Kolkata or Chennai, okay, so when the traffic is going with the help, router is forwarding this traffic, and that is data plane. So if you see this device, router or switches, they are doing two things. One is control plane, one is data plane, and there is one third plane in the device which is called management plane. So management plane like telnet, SSH, okay, so managing the device, console cable, all these things are management plane. Like accessing the device is called management plane. So data plane means forwarding traffic is called data plane. Okay, so this is all our current traditional network. So what if I tell you that all these locations, we will put the devices with the latest methods. Okay, nowadays like V-Edge or kind of these devices. So they are only going to use inside them. They are programmable devices. All these are programmable devices. So there is a device which is like papa of this network, which is like the main controller. This is called controller. And we are going to manage all these devices from this controller. Okay, so it means we need a software. We need a software to control the hardware, right? Software to control the hardware is called software defined networking. Okay, so we need a software to control the hardware. Okay, this term is called SDN controller. इसी को हम क्या बोल देते हैं? SDN. This is all my software defined networking. तो ये पूरा हमारा SDN बन चुका है. Like all these devices are going to control with this SDN, like this software which is a controller, this kind of a software. Okay, and network engineers are going to configure this SDN controller and going to manage all the network. तो हम पूरा network यहीं से manage कर लेंगे. We are going to manage all our network from here only. So the future of networking is network automation. Future of networking is network automation. We all have to understand network automation. But right now, if you are a fresher, if you are thinking after CCNA, you should go to DevNet and all, that's okay to go. But right now, it will take time. So first learn those things which is important right now. Okay, so we are going to control all the devices from one device, which is called controller or SDN controller. Okay, so there are many controllers. There are many controllers in the market, which is called SDN controller. बहुत सारे market में software हैं. Okay, which are SDN controller. We'll discuss what type of SDN controllers we have. Okay, but we need to understand how it works. Okay, we need to understand. So as of you know now, like let me repeat again. So now when we have controller, like this is going to manage the control plane. तो पूरे devices का जो control plane पहले सबका अलग-अलग था, right? Every device has individually control plane, data plane, management plane. So all these devices will only forward the data, but all their management and the control will be controlled by controller. Okay, control plane. Like control plane is like a brain of the device. That brain is controlled by this controller. तो हमारा पूरा brain जो है controller है. Okay, so this is a controller. Okay, so you can controller का example मैंने अभी दिया था आपको. Like vManage is like a controller. vManage kind of a device is a controller. It's like a software, okay, which is installed in servers. So this is vManage kind of a device, is a controller. Okay, all these locations which are like Delhi, Mumbai branches, ye jitni bhi locations thi hamari, all these locations are connected, okay, are connected with this controller. Okay, all these locations are connected with this controller. So when we connect all these locations, like these are like maybe our routers, maybe our switches, maybe some firewalls, because most of the advanced network devices, they support controller nowadays. Okay, like wireless. So all these devices are controlled by controller, and these kind of links or the connectivity between the controller and the devices, like all these are network devices. ये हमारे क्या network devices हैं. Okay, this is network devices. This is a controller. So between controller and network devices, so these kind of connections between controller and network devices are called southbound API. Okay, remember the above device is a controller, which is a software, and these devices have software installed in their devices also. So tell me how two softwares interact with each other with the help of API. Understand now API? API padha tha na? API is used to connect two softwares to interact. This is called a southbound API because this is in the end. This is the network going down. All these locations are connected with controller. There is a top layer also where we are going to manage the software with some kind of Python. We are going to manage the software maybe with some language called Java. Okay, but still Java is not that popular. Python, Ansible. Okay, so these are some network automation languages. Okay, so like Python, Ansible and all. So they are like a different layer. So this link between the controller and this applications, which are like Python, Ansible and all tools, this is called northbound API. Northbound API. Because this is on the top, this is why it is called northbound API, because this is also a software ID, or this is also a software. So the connection between these two are called northbound APIs, and the connection between controller and the devices is called southbound API.